Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to help you get started with Python, so sit back, relax, and enjoy the show. If you wouldn't mind, please like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. I'm gonna tell you why you need to learn Python. It's the easiest programming language to learn, as well as being the most popular in the world right now. And according to Glassdoor, the salary for new Python developers in the United States is $64,000. If any of this sounds good to you, well then, let's get started. If you need to download Python, go to python.org/downloads and click this yellow Download Python button. Open when done. Check Add Python 3.9 or another version to path. Install now. And then give it a little bit. It states here that setup was successful, so let's close out of this. Our next step is to download an IDE. That's an acronym for Integrated Development Environment. Think of it as software that helps us write other software. One IDE that I recommend is PyCharm. You can find it at jetbrains.com/PyCharm. Go to download. If you would like to pay for a professional version, you can click this download button. But since I don't like to pay for things, I'm going to use the free community version. At this point, we just have to follow the standard installation procedure. Click Next. You can pick a destination folder, but I'll keep the default. Next. If you would like a desktop shortcut, then check this. I would also recommend updating the path variable. Next. Install. And then give it a minute or two. Then after finishing, I have a desktop shortcut, so I can just click on this to run PyCharm. Let's create a new project. Name this project whatever you like. I'm going to name this project Hello World. And I recommend not creating a main.py welcome script right now. I'll show you how to do that manually. And let's create. If you need a Python file to work with, this is how to create one. Go to File, New, Python file, and I'm going to name this main, and then click Python file. Alright, ladies and gentlemen, we now have an empty Python script that we can use to begin coding. Now, if you checked this box, create a main.py welcome script, and then created a new project, then your main Python file will probably look a little something like this, but that's completely fine. We can just delete this. I don't know about you guys, but the font is very small for me, so let's change that. We can change that by going to File, Settings, Editor, Font, and you can increase the font size. Let's say 25. You can also change the font too. What's a good one? How about that? Then click Apply and OK. Much better. We can actually see something. To run a Python script, just click this green play button in the corner. Alternatively, you can go to the Run tab and then go to Run. Okay, so this box that appeared at the bottom, this is referred to as a terminal window. This will display any output that your program has. And this line at the end, process finished with exit code 0, that just means that there were no errors in this program. So currently this program doesn't do anything, but let's change that. Let's print something. Let's print a message. So to print a message to the terminal window, type print, and then add a set of parentheses, and then you can type a message, but it has to be within quotes, either double quotes or single quotes. It doesn't matter. So let's think of a message. I don't know. I love pizza. Then let me run this. And in my terminal window, it says, I love pizza. To print another line, just add another print statement. Print, and then your message within quotes. It's really good. And well, what do you know? It printed, I love pizza, it's really good. So ladies and gentlemen, you just wrote your first Python program. By the way, you can change the font as well as the font color of your terminal window by going to File, Settings, then go to Editor, Color Scheme, Console Font, and Console Colors. Let's change the font. Let's say I would like whatever this font is, then click Apply. Let's change the font color too by going to Console Colors. For any output, you can click number 2 and select a color. Let's say I would like bright green. That should be decent. And for anything else, let's say this will be a dark color so I can barely see it. So then let's click apply and OK. Oh yeah, that's much better. Well, everybody, that was your very first Python program. I'll post any useful links and timestamps for this video in the comments section down below. But yeah, welcome to Coding with Python. Hey you. Yeah, I'm talking to you. If you learned something new, then help me help you in 3 easy steps by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain how variables work in Python, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright, let's do this. A variable is a container for a value. It behaves as the value that it contains. It's much like in algebra lessons back in the day where we had to solve for whatever value x was, and then we can reuse x and it behaved exactly as that value. Well, with programming, we can do that, plus we can assign variables of different data types, so they are not limited to just numbers. We can assign whole words, numbers, and even these things called booleans, which are either true or false. But I'll get more in depth into data types a little bit later on in this video. So let's create a variable, and this is how to do so. We need a unique name for this variable. Let's say name. Name equals some value. Now the first data type that we'll cover is strings. A string is a series of characters. So to create a string, we can either use single quotes or double quotes in Python. And we can assign this a value of whatever your own name is. So I will assign this variable name a value of bro. Now this variable will behave exactly as if it was this value, this name, and then we can reuse this variable for something. So let's print whatever our name is. Print name. And this will print whatever your name is to the console window. Now when you print your variable, make sure you don't put it within quotes, because what we're doing then is literally printing the word name, as you can see here. So if you need to use your variable for something, make sure it's not within quotes. Now we can combine our string variable with another string. So within our print statement, let's print a string literal such as hello space plus name. So we are combining strings, and then we're printing the result to the console window. So this will print hello bro. Now you can actually check the data type of a variable. So I'm going to turn this line into a comment. So what you'll do is take the name of the variable, surround this with a set of parentheses, and then precede the set of parentheses with the type function. And this will print the data type of this variable to the console window. And you can see that it says class str, short for string. A string is a series of characters. A name is a good example of a string, a series of characters. So that is how to check the data type of a variable. Just use the type function. Now you can actually combine variables together as long as they're of the same data type. So let's change our name to maybe first name, and we'll create a second variable called last name. Now a common naming convention with variables, if it has 2 words, separate each word with an underscore. It's not necessary, but it's common practice for Python. And honestly, I sometimes forget about that, but don't tell anybody. So let's create another variable called last name. Last name equals whatever your last name is. And then let's create a third variable called full name, full underscore name. And let's combine first name plus last name. And let us display full name along with hello plus full name. Now, these 2 names were combined together to create a whole new variable. Actually, what I think I'll do is add a space within my variable. So I'm doing a bunch of string concatenation. I'm combining the variable first name plus a space character plus last name. So the result is hello, whatever your first name and last name is. So that is a variable of the string data type. It is a series of characters. Now, with strings, we cannot normally use these for any sort of math, That's where the next data type comes in. For the time being, I just turned all of these lines into comments, and we are going to move on to the int data type, short for integer. This time, let's create a variable called age, and we will assign this a value of whatever your age is. Let's just say that I'm 21. Now, when you assign a value of the int data type, make sure that it is not within quotes, because then technically it would be a string then, and you can see that the color scheme for this number actually changed. So if this was a string, we would treat it different than an int data type, because with strings, we cannot normally use them for any sort of math. So we now have a variable called age, and we can actually increase or decrease or do whatever we want with the age. Let's increase our age by 1. Let's say it's our birthday. To do so, we would say age equals age plus 1. And then let's print our age to the console window. Print age, and you can see that it says I am 22. Now there's a shorthand way of writing this. What you'll do is type age plus equals 1. So that's kind of like a shortcut, and this would work the same too. Now let's print the data type of our age variable because we can. Within a print statement, I will print the age and add my age variable to this type function, and this will print the data type of my age variable to the console window, and I will turn this line into a comment just so that it doesn't get in the way. Now, if I were to print the data type of my age variable, as you can see, it is of the int data type, short for integer. It only stores a whole integer number. Now, what if this was a string? So what I'm going to do is surround my value within a set of quotes, and I will turn this line into a comment so that it does not get in the way. You can see that the data type of my age variable is now a string. And with strings, we cannot normally use them for any sort of math. So let's attempt to increase our age variable by 1. And we ran into an error, a type error. Can only concatenate string to string, not int. Now the point being is that it's important to use the appropriate data type, because with strings we cannot normally use them for any sort of math. You'll want to use a data type of a numeric value, an int or a float, which we'll discuss a little bit later. Now here's a situation to consider. What if we would like to display our age variable along with a string literal, much like what we did with this line involving a string literal such as hello plus the user's full name. So let's attempt to do so, and this is not going to work, and I'll explain why. So within our print statement, let's say something such as your age is plus age. Now we're going to run into a type error. That's because we attempted to use string concatenation with a string literal and a variable of a different data type, a variable of the int data type. In order to display our age along with the string, we would need to convert our age variable to the string data type. And one way in which we can do that is by typecasting, and we'll cover this more in the next video. So we're going to surround our age variable, that is of the int data type, with a set of parentheses, and precede this with str, short for string. And this will convert our variable to a string that will allow us to display it with another string. Now, if we were to run this program this way, this will now display your age is, and in this case, 22. So if you need to display a variable of a different data type along with the string, you would just need to use a string cast to convert that data type to a string. But we'll cover this more in the next video on typecasting. So that is the int data type. It stores a whole integer number. And the next data type is the float data type. And I'm going to turn these lines into comments and we can move on. Now, the float data type is a numeric value that can store a number that includes a decimal portion. An int data type cannot store a decimal portion. That's why it's int, short for integer. It only stores a whole number. This time, let's say we have a height, and I will assign this a perfectly normal height of maybe 250.5 centimeters. So this decimal portion is important. That's indicating that this is a floating point number, a float for short. So let's print our height to the console window. Print height, and this will print whatever my height is. And now let's check the type of our height using the type function. So within a print statement, I'm going to add my height, surround this with another set of parentheses, and precede this with the type function. And the data type of my variable height is a float, short for a floating point number, a numeric value that contains a decimal portion. And now for practice, let's print our height along with a string literal. So let's create a string literal such as your height is plus height. but guess what? We're going to do some typecasting. So surround height with a set of parentheses, and precede this with str so that we convert height to a string so that we can use string concatenation within this print statement. And this will print the message, your height is 250.5. Actually, let's add centimeters to the end. So plus cm. And there we go. And that is what a floating point number is. Float for short. It is a numeric value that contains a decimal portion. Now, the last data type that we're going to cover is the Boolean data type. It is a variable that can only store true or false. Let's say we have a variable called human. If we were to assign this a Boolean value, this would be either true or false. And we can print whatever this value is. Let's print whatever human is, and this will display false. Now, the reason that you may want to use Booleans instead of strings, even though you can still store a string representation of the word false or true, is that these are very useful when we get to if statements. We can check to see if some statement is true. So that is a good use of Boolean values. Now let's check the data type of my human variable. So let's print type human, and this will print to the console window bool, short for Boolean. Now make sure you're not putting this within quotes, because then it's technically a string and they behave differently. Now the data type is a string, and you may have noticed as well that the font color has changed between strings and Boolean values, so that's another good indicator. Now what if you need to display your value along with a string using string concatenation? Well, guess what? We're going to typecast again. So let's print something. Are you a human? So we need to use string concatenation. So I will convert my Boolean variable of human to a string. And I have been programmed to inform you that, yes, I am in fact a human. That is true. Well, everyone, that is the basics of variables. It is a container for a value, and they behave as the value that they contain. There are 4 basic data types: strings, which store a series of characters; ints, which store a whole integer; floats, which are floating point numbers; a numeric value with a decimal; and Booleans, which only store true or false, and they're very useful with if statements. So that is it for variables. If you would like a copy of all this code, I will copy and paste all of this to the comment section down below. But yeah, that is how variables work in Python. Hey people, what's going on? It's Bro, hope you're doing well, and in this video I'm going to explain multiple assignment in Python, so sit back, relax, and enjoy the show. Well then, since you clicked on this video, I should probably explain what multiple assignment is. Now, multiple assignment allows us to assign multiple variables at the same time using one line of code. Here's an example of us using standard assignment. Let's say we have a variable name, and I will set this to a value of my name, but you can use your name for this example. Let's say age equals 21, and how about a variable called attractive? I think I'm gonna set this to true. Okay, so we have a bunch of variables, and then we can print the value of these variables with some print statements. So let's print name, age, and attractive. So we have name, age, attractive. And as you would expect, this prints bro, 21, and true. Now, another way in which we could write the same code is to use multiple assignment, and this allows us to assign multiple variables at the same time using one line of code. So I'm going to turn all of these lines into comments, and this time we will only use one line of code. But to do this, we're going to list all of our variables separated with a comma. So that would be name, comma, age, comma, attractive. And we will set them equal to those values, but in the same order, separated by commas. So that would be bro, comma, 21, comma, true. And this would do the same thing, only using one line of code. Here's another example. Let's say we have 4 variables: SpongeBob, Patrick, Sandy, and Squidward. And let's pretend that they're all around maybe 30 years old. At least it seems like they're around 30 years old, but I could be wrong. I'm not too familiar with SpongeBob lore. So let's set them all equal to 30. Now, we could write this using 4 lines of code, or we could use multiple assignment to write the same thing using 1 line of code. So if all of these variables are all equal to the same value, there's a little bit of different syntax here. So let's begin with the first variable of SpongeBob equals Patrick equals Sandy equals Squidward. Then we're going to set them all equal to 30. And this should work just fine using only one line of code. Well, everybody, that's pretty much it for multiple assignment. It allows us to assign multiple variables at the same time using one line of code. I will post all of this code in the comments section down below. And well, yeah, that's how multiple assignment works in Python. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to demonstrate some useful string methods in Python. So sit back, relax, and enjoy the show. Alright, let's do this. In this video, I'm going to be explaining and demonstrating a few useful methods available to us for strings. Now let's create a variable called name for this example, and you can use your own name if you want. So we now have a variable called name. And for my first example, let's print the length of our name variable. So to do that, we can surround our name variable with the length method, and this will print and return how long the length of our string is. And for me, the length of my name variable is 3 for 3 characters. If I were to increase the size of my name, well then that's going to change to 8. So that is the length method, and I'm just going to turn this line into a comment, and let's move on. So next we have the find method. I just copy and pasted print name so I can reuse it. Name dot, and actually if you have IntelliSense set up, if you add dot after your variable, you'll get a suggestion, well, a few suggestions of different methods and other features that you have access to. So let's find, which is, screw this, I'll just type find. Find, then we can find the first index of where this character is. Let's say I would like to find where capital B is. Well, that is at index 0 because computers always start with 0. So this first character would be 0, then R would be 1, and then O would be 2 for this example. Alright, so that is how to find a character within a string. Moving on. So let's capitalize our name, and I should probably make this lowercase. So name dot capitalize, and this will make my name capitalized. But if there's any spaces and then additional words, it's not going to capitalize that, only the first letter in your string. Next, we have upper. This will make your string all uppercase. Name, upper. And now it is uppercase. Guess what's next? Lower. Name, dot, lower. And I should probably make this capital again. And everything is lowercase. We're making some good progress today. Next, we have isDigit. This will return true or false, depending on if our string is a digit, which it's not, so this will print false. If I changed my string to a bunch of numbers like 1, 2, 3, then this will return true. Let's change that back and move on. Next we have isAlpha. Are these alphabetical characters? Oh, make sure you add the parentheses afterwards, my bad. False, because we added a space within here. Now it's true. So you can use isAlpha to check to see if your string contains only letters, alphabetical letters. Next we have count. We can count how many characters are within our string. I would like to count how many O's are in here, and this should return 2. That's right. Okay, we're almost at the end. We can replace characters within our string. So we use the replace method, and we pass in 2 arguments, the character we would like to replace and the character we would like to replace our character with. I would like to change all O's to A's, and now my name is Brakad. Oh, you guys are gonna like this next one. This isn't technically a method, but it's a really neat feature. So one thing that we can do that's available to us with Python is that we can display a string multiple times by multiplying that string by a given number. So let's say I would like to display my name 3 times. I can just take my string variable, then add times 3, and this will print my name 3 times. Bro. Like I said, not technically a method, but it's a useful feature that you might be interested in that's related. Alright everybody, so that is a few useful methods available to us for strings. If you would like a copy of all this code, I will post this in the comment section down below. But yeah, those are a few useful methods available to us for strings. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys all about typecasting in Python, so sit back, relax, and enjoy the show. Alright, welcome back everybody. I have a super quick video for you guys today on the subject of typecasting. Now, typecasting is the ability to convert the data type of a value to another data type. Here's an example that I've written already. I'm just going to paste it. I have 3 variables for this example, x, y, and z. X contains 1, this is a whole integer, int for short. Y contains 2.0, this is a floating point number, float for short. You can tell it's a float because it ends with a decimal portion. And z contains a string of 3. A string is a series of characters, and you can tell it's a string because it's surrounded with a set of quotes. And remember, with strings, we cannot normally perform math on strings. So I have 3 print statements for x, y, and z. And as you would expect, they contain the values of 1, 2.0, and 3. Now let's begin by converting both y and z to the integer data type via typecasting. In order to perform typecasting on a value or variable, type that value or variable and surround this with a set of parentheses. Whoops, I missed. And then precede this with the data type you'd like to convert this value or variable to. I would like to convert y to an integer, and then you can use this for whatever you need. So I'm going to replace y within my print statement with y after we typecast it as an integer, and this will display 1, 2, not 2.0, it's the whole integer of 2, and then 3. So this is not a permanent change. If you need to make this as a permanent change to y, you'd have to reassign it. So let's say y equals y, and then we're going to typecast y. So let's surround this with a set of parentheses and precede this with the data type we'd like to convert y to. So now y is a whole integer, and then we will print y without the typecast this time. And our result is 1, 2, 3. Now z is storing a string, and with strings we cannot normally perform any math on strings. For example, within my print statement, I will state z times 3. You would think that the result would be 9, right? Well, you're wrong. It's going to print 3 times. If you need to convert a string to a int or a float, you would just have to typecast it. So this time, let's typecast z as an integer, z int, and we will typecast z as an integer. So then if we have z times 3, the result is now 9 instead of 333. So that's the basic formula for typecasting. Now let's convert these to floating point numbers, but let's include x as well because x is feeling left out. So let's convert x to a floating point number. So float parentheses, and we will surround this with x and display x. And actually, let's convert y and z to floats as well because why not? So the results are now 1.0, 2.0, and 9.0. Remember that we multiplied z times 3. And then if we need to convert these values to a string, we would use the string cast. So the results now are 1, 2.0, and 333. Now you might be thinking to yourself, when would you need to convert an integer or a float to a string? Here's a situation. Let's say within our print statements, we need to print these variables along with another string. So within our print statement, let's say x is plus x. We would like to display these together. And let me copy this and do the same thing for y. We'll say y is plus y. You cannot normally display a string along with an integer or a float because we're using some string concatenation. So this will result in a compilation error. Can only concatenate string, not int to string. So that's a situation in which you might need to use typecasting to convert an integer or float to a string. So let's display x and y as strings via typecasting. So we'll surround x and y with a set of parentheses and precede this with the data type we'd like to convert these values to. We would like to convert x and y to both strings, and now this will compile and run just fine. Well, everybody, that's the basics of typecasting. If you would like a copy of all my code, I will post everything in the comments down below. If you found this video helpful, don't be afraid to help me out by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on, everybody? It's Bro. Hope you're doing well, and in this video I'm going to teach you guys how we can accept some user input in Python, so sit back, relax, and enjoy the show. Ladies and gentlemen, this is where the fun begins. In this video I'm going to explain how we can accept some user input in Python, and we do so by using the input function, and then we type in our input to the console window, but it would probably be good practice to let the user know what we want them to type in exactly. So let's ask for somebody's name. Within quotes, inside the input function, I'm going to type, "What is your name?" And now our program will wait for us to enter in some user input. So you can use your own name for this example. I'm going to type bro. Now to submit some user input, you just type or press enter. Now you can see that my process finished with execode 0. That means the program is done running. So we should probably do something with this value. We can actually assign it to a variable so we can use it elsewhere in our program. So to do so, we precede input with a variable like NameWorks, name equals input. And when we accept some user input, we will assign it to this variable that we called name. And now we can do something with it. So let's print a message involving our name variable that we have. So how about hello plus name? Now when I run this program, we can accept some user input and then do something with that input, such as display a message that says, "Hello, bro." And then you can type in whatever you want for your name. Let's say I'm Dude. What is your name? Dude. Hello, Dude. Now this next part is very important. When we accept user input, it is always of the string data type, a series of characters. What if we need to accept a number? Well, you can, but you can't normally perform any math on it because it's of the string data type. We would need to cast it as either of the integer data type or of the float data type. So here's an example of why we can't perform any math on a string. Let's say we have a variable called age. Age equals input, and let's ask how old somebody is. How old are you? Now, I will add 1 to somebody's age. Let's pretend it's their birthday. Age equals age plus 1. This will add 1 to their age. Now, let's try and run this. What is your name? Bro. How old are you? Let's say that I'm 21. Okay, we ran into an error, a type error. Can only concatenate string to string. With what I mentioned previously, we cannot normally use strings for any sort of mathematical equation or operation. We'll want to cast it to the integer or the float data type. So let's cast our user input to the integer data type, and we will surround our user input with a cast. Surround your input with a set of parentheses and precede this with int. And now we can use this user input in a mathematical operation. So let's try it, even though this won't display age yet. So what is your name? Bro, 21. And our program finished with an execode of 0. There were no problems. Now let's attempt to display this age. So I will print you are plus age plus years old. We're doing some string concatenation here. What is your name? Bro, how old are you? 21. Alright, we ran into a type error again. Can only concatenate string to string. You cannot normally display a variable of the integer data type along with strings because we're doing string concatenation. We're adding strings together. We would need to convert this variable back to the string data type so we can cast it. We'll surround our age variable with a cast. Now this is what's going to happen. We will accept some user input, it will be of the string data type, and then we will immediately cast it to be of the integer data type so that we can treat it as a number instead of a character. And then if we need to display this age, we will need to convert it back to a string so that we can use some string concatenation and display all of these strings together. And now let's try this theory. So what is your name? Bro. How old are you? Let's say I'm 21. Hello, bro. You are 22 years old. Here's a situation. What if we enter a number that contains a decimal portion? So let's try this again. Let's say I'm 21.5 years old. Well, now we ran into a different issue, a value error. Invalid literal for int with base 10. That means if we cast a string as an integer, it can only be a whole number, a portion that does not contain a decimal. And that is where the float data type would come in. It is a data type that can contain a decimal portion. For this example, let's create a third variable called height, and we will ask for somebody's height. Input, we'll create a prompt that says, how tall are you? And we will cast this to be of the float data type so that our string, our user input, can contain a decimal portion, and then we can treat it as a number instead of a series of characters. And I think I will delete this line, we won't really need it anymore. And then let's print their height along with a message. You are plus, then height, but we need to cast this back to being a string. So we'll surround our height with a cast, plus, let's say cm tall. All right, let's test this. What is your name? Bro. How old are you? Let's say I'm 21. How tall are you? Let's pretend that I'm 250.5 centimeters tall. I'm adding the 0.5 just to test to see if this will accept a floating point number. Hello, bro. You are 21 years old. You are 250.5 centimeters tall. Not really. All right, everybody. So that is the basics of user input in Python. Normally with user input, it will give you a value of the string data type. If you need to use that value for any sort of math, you'll probably need to cast it to be of the integer or the float data type. So if you would like a copy of this code, I will post this in the comment section down below. But yeah, that's how to accept user input in Python. Hey, what's going on, everybody? It's Bro, hope you're doing well, and in this video I'm going to demonstrate a few useful functions related to numbers in Python, so sit back, relax, and enjoy the show. Okay, let's begin. In this video I'm going to be demonstrating a bunch of useful functions related to numbers, and a bunch of these functions are located within the math module. Now let's create a variable for this example. Let's say pi equals 3.14. Just the first few digits of pi is fine for this example. And now here's a bunch of useful functions that you guys would probably be interested in. The first is round. Round is a built-in function, and all we do is type round, then add a set of parentheses, and then we can pass in a value or a variable as an argument, and the round function will round that number for us. So pi rounded to the nearest whole integer is, you guessed it, 3. Now, we can round a number up by using the ceil function of the math class. Ceil, short for ceiling. So let's print our result, and in order to access this function within the math module, we would type the name of the module, dot, and here's a bunch of functions that we have access to. So we are looking for ceil, and it's actually at the top here for me, and ceil will round a number up to the nearest whole integer. So pi rounded up is 4. Then on the flip side, we can round a number down by using floor, and that is also located within the math module. So let's type math.floor, and pi rounded down would be 3. Up next, I have the absolute value function, but it's ABS for short. ABS will give you the absolute value of a number. So the absolute value of pi, actually let's make this negative 3.14. The absolute value will tell you how far a number is away from 0. So if you pass in a negative number, it will give you a positive number. So that is ABS, short for absolute value. Next we have the pow function. Pow will raise a base number to a power. Let's raise pi to the power of 2. So we pass in 2 arguments, a base and an exponent. Pi to the power of 2 is 9.8 and some change. So that is the pow function. Next we have square root. So this is located within the math module. We'll type math.sqrt, short for square root. And the square root of pi is, let's find out. Oh, I guess we can't pass in pi. Let's round a different number, like 420. Oh, I guess that's because I made pi negative. Okay, so the square root of 420 is 20.4 and some change. So that is the square root function. All right, we have two left. We have the max function. The max function will find the largest of a varying amount of values. So let's create three variables for this example. Let's say x equals 1, y equals 2, and z equals 3. We can use the max function to find the largest of these values. So within a print statement, let's use the max function and pass in all of the different values or variables that you would like to compare. So I would like to find the largest value between x, y, and z. And the result in this example is 3. Now the min function will find the lowest. So min, and then pass in your values or variables. So I would like to find the minimum value between x, y, and z. And in this case, it is 1. Well, everybody, those are a few useful functions that you guys might be interested in. If you guys would like a copy of this code, I will post this in the comments section down below. But yeah, those are a few useful functions related to numbers in Python. Hey, what's going on, everybody? It's Bro. Hope you're doing well. And in this video, I'm going to explain string slicing in Python. So sit back, relax, and enjoy the show. Alright then, let's talk about slicing. Slicing can be used to create a substring by extracting elements from another string. The same principle can also be applied to different collections as well, but in this video we're going to be focusing on slicing strings. Now to slice a string, we can either use the indexing operator, which is a set of square brackets, or by use of the slice function to create a slice object. This is a little more complex. We'll discuss the slice function near the end of this video. So, with slicing, there are three optional arguments, three fields that we can fill in depending on where and how we want to slice our string. A starting index, a stopping index, and a step. Let's begin with the starting index. Now, for this example, let's say we have a string variable called name, and this will store a value of whatever your own full name is. Yes, I legally changed my name to Brocode. You can use your own name for this if you want. So what I would like to do is to create a substring based off a sliced portion of my full name. So what I would like to do is create a substring based off of just the first part of my name, just bro. So let's begin by creating a substring. Maybe I'll call this first name equals. Now to slice a string, type in a string or the name of a variable that contains your string and follow this with the indexing operator. And like I said, we'll discuss the slice function a little bit later. So we need a starting index and a stopping index, but we'll begin with the starting index. Where do we want to begin our slice? So computers, they always start with 0. So the first character in your string will have an index of 0. I would like my slice to begin at index 0. So I'll list that for the starting position, the starting index. So let's test this just to be sure it works. I'll just print first name. And let's see if this prints capital B, which it does. So following that same pattern, the next character within my string would have an index of 1. That would be R. Then the next index 2 would be O, and 3 should be an empty space. All right, so that is the starting index within string slicing. If we would like to slice an entire portion of our string, not just one letter, we need a stopping index as well. And both of these fields are separated with a colon. So let's say I would like to slice the first 3 characters of my string. So this would have an index of 0, 1, 2. And this isn't going to work as you would imagine, and I'll explain why. So you would think that indexes 0 through 2 would give us 3 letters, right? But it only gives us 2. So this first index is inclusive. The stopping index is exclusive. So if I want the first 3 characters, the first 3 letters in the string, I would need the starting index to be 0 and the stopping index to be 3. And now this should print my first name and not anything else. There is a shorthand way of writing this too. So if you were to leave this first index blank for start, well, Python is going to assume that this is 0, the beginning of your string. So this would be no different than what we had previously, just having :3. Now, let's try and create a separate substring for a last name. So, last name. Name. Now we need a starting index and a stopping index. So we need the starting index at least. So this would be 0, 1, 2, 3, 4. 4, colon, and where do we want this to stop? 0, 1, 2, 3, 4, 5, 6, 7. And remember that this is exclusive, so we're going to place 8 here. And now I would like to display last name, and this should just display code. And a shortcut is that if you were to leave stop blank, but you still have that colon, this is a shorthand way of writing, I would like every character starting at index 4 and everything after until the end. So there would be no change to this as well. You can write it either way. Okay, so we still have to discuss step. Step is an optional field that we can set a value to. So step is how much we're increasing our index by between starting and stopping. So it is entirely possible to create a substring that will count only every second character after the first. Normally step is 1 by default, but if we were to set that to 2, we're going to count only every second character. So let's try this. Maybe I'll create a new variable called funky name because I really don't know what else to call this for this example. Let's say funky name equals name, and I'm going to count only every second character, including the first. So the indexes would be 0, colon, 8 for my example, but if you're using your own name, that's probably going to be something different. So the default for step is 1, and if I were to display funky name as it is currently, this will just display my full name. But if we set step to 2, this will only display every second character, including the first. So funky name is now, for me at least, BOCD. Now if step was 3, this will print only every third character, including the first, where it's B space D. A shorthand way of writing this is that you could leave start and stop empty, but the important thing is to have these 2 colons. Python is going to assume that if you leave your starting index empty, you're referring to index 0, the beginning. If your second index, your stopping index, is empty, Python will assume this will be the very end of your string. So just having 2 colons and then step 3 would be no different than what we had previously. For this next part, I'm going to explain how we can reverse a string in Python. So let's create a new substring variable called reversed name equals name. I would like to use the entire string, so I can just use 2 colons. Python will fill in the rest. So for the step, this is going to be -1. It's kind of like we're counting backwards, and we're going to create a new substring based off my name, but in reverse. So if I were to print my reversed name, this is now edoc.orb. I think that's how you pronounce it. So that's how to reverse a string in Python using slicing. Now let's move on to part 2 of this video. I'm going to be explaining the slice function, and we can use the slice function to create a slice object, which is actually reusable, so that's somewhat convenient. Let's take a different scenario this time. Let's say we have a website URL. Website equals http:// google.com, but use whatever website you want. What I would like to do for this program is remove and create a substring based off the website name and not anything else. I would like to exclude the HTTP portion as well as the .com portion of this website URL. So let's break it down step by step. Our first step is to create a slice object, so I will name the slice object as slice. Slice equals, and I will invoke the slice function. So within the parentheses of the slice function, we can add up to 3 values: a start, a stop, and a step. Exactly the same as what we did with indexing. However, with the slice function, we separate each of these values with a comma instead of a colon, but it works the same way. So we would like our substring to begin where the name of the website begins. So we would like our start to be 0, 1, 2, 3, 4, 5, 6, 7. So I will pass in 7 for where my substring will begin. And now each value within the slice function will be separated with a comma instead of a colon, like what we did with the indexing operator. Now for the stop index, that's going to be a little bit tricky, and let me explain why. One issue that we're going to run into is that not all website names are consistent with their length. They can really vary. So it is not possible for us to use the same stopping index for each of these website URLs. So one way in which we can account for that is to use what is called a negative index. Each character within a string has a positive index as well as a negative index, and a negative index works almost exactly the same way, except the character most on the right begins with a negative index of -1, and the character on the left of that would be -2, -3, and -4. It's as if you're counting backwards. So with indexing, we can use some combination of positive and negative indexing. So I would like my substring to end where this dot is. So this would have a index of -1, -2, -3, -4. And remember that this is exclusive. So I would like my slice to begin at index 7 and a negative index of 4 for the stopping position. So that will give me just the website name and remove the HTTP portion as well as the .com portion of my website URL. And now we have a slice object and we can reuse this. So to apply your slice object, type in the name of your string, index operator, and place your slice right within here. And let's print this. So print our website and apply the slice to it. And now this should give us just the website name. And now let's test this with maybe another website. I'll rename this as website 1 and let's create website 2. And let's try a different website name for good measure. So let's try Wikipedia. So we can reuse our slice object and we will apply our slice to website 2 this time. And this should remove the URL portions, HTTP as well as .com. All right, everybody, so that is slicing strings in Python. You can either use the indexing operator or the slice function to create a slice object. If you would like a copy of all this code, I will post all of this in the comment section down below. But yeah, that is how string slicing works in Python. Hey, what's going on, people? It's your bro. Hope you're doing well. And in this video, I'm going to explain if statements, else if statements, and else statements in Python. So sit back, relax, and enjoy the show. All right, people, let's talk about if statements. An if statement is a block of code that will execute only if its condition is true. It's a very basic form of decision-making with programming. For this example, let's create a prompt where we will ask a user for their age, and depending on what their age is, we will print a response. So let's say age equals input, and then we will add a prompt. How old are you? Now this will return a string, so we should probably cast this as an integer data type. So we now have a variable called age where we will accept some user input. Let's check somebody's age with a variety of if statements. So let's check to see if somebody's age is greater than or equal to 18. So to create an if statement, type if, and then some sort of condition. If age is greater than or equal to 18, to finish this if statement, add a colon at the end. Now pay attention to this. If I move down to the next line, you'll notice that my cursor is now indented. Any indented code underneath an if statement is the block of code for that if statement. So if this condition is true, we will execute some block of code. If it's false, we'll skip over it. So if somebody's age is greater than or equal to 18, let's print you are an adult. And let's try this program. How old are you? Let's say I'm 21. So my condition when we get to the if statement is going to check to see if this condition is true. If it is true, we're going to execute this block of code. If it's not, we skip over it. So how old are you? Let's say I'm 21. I'm going to hit enter. And my if statement is true, so we execute this block of code which prints, you are an adult. So what if this condition is false? Let's say I'm 12. Well, then we're just going to skip over this block of code and continue on with the rest of the program. If you would like your program to take some other course of action, if this condition is false, we can add an else statement. So after the if statement, add else. Make sure you get the indentation right. You don't want this within the block of code for the if statement. So if this condition is false, we can take some other course of action. So if somebody's age is less than 18, let's print you are a child. So let's try this again. I'm going to enter that I am 12 years old. Not really, but let's just pretend I am. So this will now print you are a child. If this condition is false, perform this block of code for the else statement. So with if statements, we can check more than one condition before reaching the else statement by using an else if statement, and we add that after an if statement. So it's shortened to ELIF for else if. So let's check to see if somebody's age is less than 0 for some reason. So let's print, you haven't been born yet. So with if statements, we start at the top. We first check the if statement. If this is false, we move down to the next statement to check. Then we check our else if statement. If this is also false, then we resort to the else statement. The else statement is sort of like a last resort. If all conditions evaluate to be false, then we execute the else statement. So let's try this. How old are you? Let's say I'm -1 years old. You haven't been born yet. So with if statements, we always begin with an if statement and we check that condition. If that condition evaluates to be false, then we will skip this block of code and move down to the else if statement. If there is one, it's optional. If this condition is also false, then we will use our else statement as a last resort if there is one. If there is no else statement, then we just skip over all of this then and continue on with the rest of the program. So you can add more than one else if statement. So let's check something else. Let's check to see else if age is equal to 100. So if you need to check to see if a value is equal to a particular value, make sure you use double equal signs. This is the comparison operator for equality. If you use just one equal sign, that's the assignment operator, and Python thinks you're attempting to set age equal to 100. So if you want to check to see if age is equal to 100, then use double equals. So let's check to see if somebody's age is equal to 100. So let's print, you are a century old. Now pay attention to this if I were to run this program. How old are you? Let's say I'm 100. So this is printing, you are an adult. That's because we first check our if statement, and well, we're 100 years old, and 100 is greater than or equal to 18. So we print this block of code, we execute this block of code, and then we skip everything else, even though age is equal to 100 within our else if statement. So the order of your if statements does matter. So let's change this around. Let's add this to the very beginning. And this will be our if statement, and we will set age is greater than or equal to 18 to be an else if statement. So we're first going to check to see if age is equal to 100. If not, we will check to see if age is greater than or equal to 18. And we just follow that order. So let's try this again. How old are you? I am 100 years old. You are a century old. So we first check our if statement. If this condition is true, we will execute this block of code. If it's false, we just go down the order till we reach our else statement. Well, everybody, that is the basics of if statements. We have if statements, else if statements, and else statements. So if you would like a copy of this code, I will post this in the comments down below. But yeah, that is how if statements work in Python. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to explain logical operators in Python. So sit back, relax, and enjoy the show. Alright, everybody, let's talk about logical operators. These are used to check if two or more conditional statements are true. So we'll be discussing the AND as well as the OR logical operators. There's also a third one called NOT, but that works a little bit different, and I'll explain why. So let's create a program to demonstrate this. Let's create a program where we will ask somebody for the temperature outside. And then depending on the temperature, if it falls within a certain range, we will print a message. So we'll need to use AND as well as OR logical operators to do this. So here I have a prompt, temp for temperature equals input, what is the temperature outside? So I'm going to cast this as an integer data type. So what if we want to check to see if our temperature is within a certain range? We can use the AND logical operator to check two or more conditional statements. This is how we might do that. Let's check if temp is greater than or equal to 0 degrees Celsius. And we can check another condition too. If temp is less than or equal to 30 degrees Celsius. So we need to add a colon at the end to finish this if statement. And let me just fix some of the spacing. Okay, so with the AND logical operator, in order for this entire condition to be true, both conditions must be true. This needs to be true, and this needs to be true. So if our temperature is equal to or above 0, as well as being less than or equal to 30, that means our temperature falls within a certain range. So let's print a message such as, the temperature is good today. Print, go outside. All right, let's try it. So what is the temperature outside? Let's say it's 20 degrees Celsius. Well, the temperature is good today. Go outside. This condition is true. 20 is greater than or equal to 0, and temperature is less than or equal to 30. Let's try a different temperature, like negative 20 degrees Celsius, so it's really freaking cold outside right now. As you can see, nothing happened because our first condition was false. Our temperature is not greater than or equal to 0, but our temperature is less than or equal to 30, so our second condition is true, but our first condition was false. And in order for this entire statement to be true, since we're using the AND logical operator, both conditions must be true in order for this statement to be true. Now let's discuss the OR logical operator. We can check to see if our temperature is below or above a certain range. So let's write else if temp is less than 0 or temp is greater than 30. So that means it's going to be either very cold outside or very hot outside. So let's print a message. The temperature is bad today. Print, stay inside. All right, let's try this again. What is the temperature outside? It is negative 20 degrees outside. The temperature is bad today. Stay inside. So with the OR logical operator, as long as one of these conditions is true, then the entire statement is true. It doesn't matter if one of them is false. As long as one of them is true, then the entire statement is true. Last but not least, we have the NOT logical operator. This works a little bit different from the AND as well as the OR logical operator because we can check one or more conditional statements instead of two or more conditional statements. So what the NOT logical operator will do is that it'll take a conditional statement. If it's true, it's going to flip it to false. If it's normally false, it's going to flip it to true. So for this example, we have another way in which we could write this, although it's a little more complex. So if our statement is true, what we can do is that we can flip it to false using the NOT logical operator. If it's normally false, we can change it to true. So what we'll do is surround one or more conditional statements with a set of parentheses and precede everything within the parentheses with the NOT logical operator. So if the statement is normally true, it's going to become false using the NOT logical operator. If it's normally false, it's going to be true then. Let's do the same with the else if statement. So surround one or more conditional statements with the NOT logical operator. So now these roles are going to be kind of reversed. So let's try this again. What is the temperature outside? It is negative 20 degrees outside. The temperature is good today. Go outside. So what we should probably do is kind of reverse these roles. So I'm just going to swap everything within these if statements with each other. And now this should work the same as it did before, but we just wrote it a little bit different. What is the temperature outside? It is 15 degrees outside, 15 degrees Celsius. The temperature is good today. Go outside. So with the NOT logical operator, you can surround one or more conditional statements with the NOT logical operator. And what this will do is flip it from being false to true or from true to false. Well, everybody, that's the basics of logical operators in Python. If you would like a copy of all this code, I will post this in the comments down below. But yeah, that's the basics of logical operators in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain while loops in Python, so sit back, relax, and enjoy the show. So, while loops. A while loop is a statement that will execute its block of code as long as its condition remains true. Later on in this video, for this example, we're going to create a program where we will prompt a user to enter their name. If they attempt to skip that prompt, then we will continually ask the user to enter their name, and they can't continue on with the rest of the program until they do so. The key thing to keep in mind with while loops is that you'll want some way to eventually escape the while loop. If you don't have any way to escape the while loop, that's referred to as an infinite loop. So let's create an example of an infinite loop because it's fun. So to create a while loop, type while and then some sort of condition. So for our condition, let's say while 1 is equal to 1. So this will always be true. Now, what do we want to do when we execute this block of code? Let's print something. Print help. I'm stuck in a loop. All right, so let's try this. While 1 is equal to 1, print this statement. And we will just continue on and on within this while loop because we have no way to escape this while loop. So now let's use this concept and write a program where we will prompt a user to type in their name. If they don't type in anything, then we will continue to prompt them to type in at least something. So let's say name is equal to, and then to just keep this blank, we'll just set this to a set of quotes. And then let's write a while loop here. While name, and let's check the length of name. If the length of our name is equal to 0, then we will ask the user to type in their name. Name equals input, enter your name. So then once we escape the while loop, let's print something. Print hello plus name. Whoops. Hello plus name. All right, so when I run this, we are giving the user a way to escape the while loop. They have to type in something for their name. As long as the length of my name is equal to 0, keep on printing this prompt, enter your name. So I'm just going to hit enter a bunch of times. Enter your name, no. Enter your name, no. Enter your name, no. So we are stuck within this loop until we enter something for our name. So this time, let me type in a name, then hit enter. So therefore, our condition is now false. The length of my name is now 1, 2, 3. So 3 is not equal to 0, therefore our while statement, our while loop, is false, and we continue on with the rest of the program. There are a few variations in which you could write the same program, so let's write this a different way. What we could do is say name is equal to none, while not name. And this will pretty much do the same thing, it's just another way of writing this. Well, everybody, that's the basics of while loops. A while loop is a statement that will execute its block of code as long as its condition remains true. For our example, we asked the user to type in their name. If they were to leave it empty or blank, we would keep on asking the user to type in their name. So if you would like a copy of this code, I will post this in the comment section down below. But yeah, that's the basics of while loops in Python. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video I'm going to explain for loops in Python, and at the end of this video we're going to create a countdown timer, so sit back, relax, and enjoy the show. Alright guys and gals, let's talk about for loops. A for loop is a statement that will execute its block of code a limited amount of times. It's similar, but different from a while loop because a while loop could iterate an unlimited or infinite amount of times depending on the condition. A for loop will only iterate a limited amount of times, and before we start executing its block of code, we already know how many times we're going to repeat this block of code. So for this example, let's create a for loop that will simply count up to 10, and then we'll create a few more sophisticated examples. So to create a for loop that will count up to 10, this is what we'll type. For, and then we need some sort of counter. People usually either write index or they shorten it to just I for index. For I in, and we can set a range. Range 10. So we will execute this for loop 10 times. And to finish this for loop, just add a colon at the end. So the next line or lines will be indented. So that's the block of code for the for loop. What do we want to do during each iteration? Let's just print what I is. And let's take a look to see what would happen. So we executed this for loop 10 times, except with computers always start with 0. So when we said for I in range 10, we're counting numbers 0 through 9. So it's as if this number is exclusive. So there's two ways we can change this. We could say range 10 plus 1, or what I would do is say print I plus 1. So this will give us numbers 1 through 10. So that's a for loop. It will execute a limited amount of times. This time, let's count a range between two numbers, not necessarily 0 to 10, but something else. So let's say for I in range, maybe the numbers 50 through 100. So within my range function, I will pass in two numbers. The first number will be the starting point, and the second number is the ending point. This first number is inclusive, and the second number is exclusive. So let's print this. Print whatever I is. So this will count 50 through 99 actually. If you wanted to include this last number since it's exclusive, what we could do is just add 1 to the end. So this would give us 50 through 100, except that this will iterate 51 times since we're counting 50. So you just have to pay attention to your range and the numbers that it's counting. Now, one thing that you could do with the range function is that you can add a third argument, and this will function as the step, how much you want to count up or down by. So this time, let's count up by 2. So I'll add comma 2. We're passing in a third argument this time. So this program will now count up by 2, starting at 50 and go all the way to 100. A benefit of for loops is that we can iterate through anything that is considered iterable. This could include a string, the letters in a string, or any sort of collection. So this time, let's create a for loop that will iterate once through each letter in maybe a name. So for I in, and let's type a name here. Type in whatever your first name and last name is. And then we will print whatever I is. For I in whatever your name is, print each letter in the string. So when I run this, each letter within my name will be printed to a new line. All right, people, for my last trick, we're going to create a program where we will simulate a countdown starting at 10 and count down to 0. And then maybe once we reach 0, we can print something such as Happy New Year. So to create this program, we'll need an import. So at the top, we're going to import the time module because we'll be waiting 1 second after each iteration of this for loop. So to create this program, let's say for, you could say I, but you can really write anything here. And to demonstrate that, let's say 4 seconds. 4 seconds in range. So the starting point is going to be 10, the ending point will be 0, and we'll add a step. What do we want to count up or down by? Let's set this to -1, so this will be a countdown starting at 10 and ending at 0. So after each iteration, let's print whatever I is, or in this case, seconds. And then we can sleep, have our thread sleep for a number of seconds too. So after we print seconds, type time.sleep and pass in how long you want to sleep for. I would like to sleep for 1 second. And then at the end, let's print Happy New Year. Make sure this isn't within the for loop. Print Happy New Year. And well, that's it. Let's test this. So we'll begin at 10 and count down to 0, and you can see that my thread that is running this program is sleeping for 1 second after each iteration of this for loop. Then once we reach 0, it will display Happy New Year. Well, everybody, that's the basics of for loops. A for loop is a statement that will execute its block of code a limited amount of times. It's different from a while loop because a while loop could execute an infinite or unlimited amount of times. With for loops, they execute limited amounts of times, and before we enter the for loop, we already know how many times we're going to iterate this for loop. If you'd like a copy of all this code, I will post this in the comments down below. But yeah, that's how for loops work in Python. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to explain nested loops in Python. So sit back, relax, and enjoy the show. Hey all you people, let's talk about nested loops. A nested loop is a general concept of having one loop inside of another loop, and that's really it. It doesn't matter if it's a for loop or a while loop. So the inner loop will finish all of its iterations before we finish one iteration of the outer loop. And to best demonstrate this, we're going to create a program where we will draw a rectangle made out of a certain symbol that we choose. We need to set a width and a height. And to best do this, we'll need to use a nested loop. We'll create a few prompts, one for rows, columns, and a symbol that we want to make a rectangle of. So let's begin with rows. Rows equals input, how many rows? And we'll need to cast this as an integer data type because we're working with numbers. Okay, let's do the same thing for columns. So replace rows with columns for this next line. Input, how many columns? And we'll create a symbol variable. Symbol equals input, and this we don't have to cast. Enter a symbol to use. Now it's time for the nested loops. We're going to create an outer for loop as well as an inner for loop. The outer for loop will be in charge of the rows. The inner for loop will be in charge of the columns. So let's begin by creating our outer loop. So we'll write for I in range rows. We would like our outer for loop to iterate as many times as we have rows. And we're going to create an inner for loop that will iterate as many times as we have columns. So within the block of code for the outer for loop, we're going to create another for loop. This time it'll be for, and a common convention for inner loops is to write j as an index because j comes after I guess. So for j in range columns. So our inner for loop will iterate for as many times as we have columns. All we'll do within the inner for loop is print our symbol that we have, except we'll have one issue. Using a print statement, after we use the print statement, we will enter a new line character in and move down to the next line. We can actually prevent that by adding comma end equals quotes. So after using a print statement, this will prevent our cursor from moving down to the next line. So pay attention to the indentation too. So there's kind of two levels of indentation. We're currently within the inner for loop. So that's pretty much it for the inner for loop. Now we're going to print a new line once we exit the inner for loop. And you can see that the indentation is on this line right here. We're within the outer for loop now. And that's pretty much it. So let's try this program. How many rows? Let's say 5 rows. How many columns? Perhaps 6. What symbol do we want to use? Let's say the $sign. And let's try it. There we go. There's our rectangle. So we have, let's see, 6 columns, 1, 2, 3, 4, 5, 6, and 5 rows, 1, 2, 3, 4, 5. In summary, a nested loop is really just this concept of having one loop inside of another loop. It doesn't matter if it's a while loop or a for loop. It's really situational. The inner loop will finish all of its iterations before finishing one iteration of the outer loop. So what we did to demonstrate that is that we had the outer loop in charge of the rows, and an inner loop in charge of the columns for our rectangle program. So if you would like a copy of this program, I will post this in the comment section down below. But yeah, that's the basics of nested loops in Python. Hey, what's going on everybody? It's Bro, hope you're doing well, and in this video I'm going to explain loop control statements in Python, so sit back, relax, and enjoy the show. Alright, ladies and gentlemen, let's talk about loop control statements. These are used to change a loop's execution from its normal sequence. And there are 3 we're going to discuss: break, continue, and pass. Let's begin with break. Break is used to terminate the loop entirely. Now here's a good example of where a break would be useful. Let's say while true, we're going to continually ask for somebody's name. If they don't type in anything, then we'll continue the while loop over and over again. So let's say name equals input, enter your name. Now, if name does not equal a set of quotes, that means they don't type in anything, then we will break out of this while loop. And let's test it. Enter your name. Nah, I don't think so. I'm too lazy to enter my name. Alright, I can see that I'm not going to escape this while loop, so I'm going to type in my name because I give up and hit enter. Therefore, I will break and exit out of this while loop. So a break is used to terminate the loop entirely when it's encountered. Next, we have continue. Continue skips to the next iteration of the loop. Now let's say we have a phone number, phone underscore number, and I will set this equal to, let's say, a random phone number, including dashes, 123-456-7890. What I would like to do is to display this number within the console window without these dashes. This is how to do that using a continue control statement. For I in phone number. So for each character within our string of phone number, what we'll do is check to see if we encounter a dash character. If I is our index, is equal to a dash, then we want to continue and skip over this iteration of the loop. So continue. Then I would like to print whatever our indexes, whatever character we're working on. So if I were to run this as it is, it's going to print each digit on a new line. So with print statements, they will add a new line character to the end of your string. And you can actually change that by adding to the end, comma, end equals, and then a set of quotes. So this will print my phone number without any dashes, 12345678890. So that's a use of the continue control statement. It skips to the next iteration of the loop. Last but not least, we have pass. Pass does nothing. It acts as a placeholder. Let's say that I would like to print the numbers 1 through 20 using a for loop. For I in range 1 through 21. And remember that the second digit is exclusive. So this will iterate once through the digits of 1 through 20. Let's pretend that I'm highly superstitious and I don't want to print the number 13 because 13 is considered an unlucky number. If I is equal to 13, what we'll do is pass, and pass acts as a placeholder and it won't do anything. Else, print I. That's 1. I. There we go. This will print the numbers 1 through 20 and skip 13 because we used the pass control statement, which does nothing. It acts as a placeholder. So everybody, those are loop control statements. They change a loop's execution from its normal sequence. We have break, continue, and pass. So if you would like a copy of all this code, I will post all of this in the comments section down below. But yeah, those are a few loop control statements in Python. What's going on, everybody? It's Bro. Hope you're doing well. And in this video, I'm going to explain lists in Python. So sit back, relax, and enjoy the show. All right, ladies and gentlemen, let's get down to business. I got to explain lists to you all. Now, a list is used to store multiple items within a single variable. For example, let's say we have a variable called food, and I will store a string value of pizza because I like pizza. What we could do is that we can store multiple items within this variable by turning this variable into a list. And in order to do so, we're going to surround all of the values that we would like to add to our list with a set of square brackets. And boom, there you have it. We now have a list called food. It is no longer a variable. So what we could do is add multiple items to this list of food. So let's add some other food items that we might like. Let's see, I also like maybe some hamburgers and a hot dog and maybe some spaghetti. I think I spelled spaghetti right. Okay, so we now have a list called food. Now what happens if we attempt to print this list of food? So print food. So this will print all of the elements found in this list. Each item in a list is referred to as an element. If we need to access a certain element of this list, we have to list the index. So next to our list, we'll add a set of square brackets again, and we need to list the numbered index of the element that we're trying to access. Now computers, they always start with 0, so the first element in our list would be element number 0, the next one would be 1, 2, and 3. So if we need to access element 0, which is in the first position, we would say food, square brackets, and then within here, list the index. So the first position is 0, and this will now print the first element of our list, which is pizza. Let's attempt to access some of these other elements. So the element at index 1 would be, you guessed it, hamburger. 2 would be hot dog, and 3 would be spaghetti. Now what happens if we attempt to access the element at index 4? Well, currently that's out of range because we did not assign a value. So we're experiencing an error, an index out of range error. But if I were to add another element, let's say pudding. All right, well then the element at index 4 would be pudding then. One important concept with lists is that you can always update and change the elements found within a list later on in the program after you declare one. So let's say we would like to immediately change one of these elements. Let's say food. At index 0, I want to replace with maybe sushi because sushi is great. So if I were to print the element at index 0, this would no longer be pizza because we updated element 0 to be sushi then, and this prints sushi. Now, if you need to display all of the elements found within a list, you can easily do so with a standard for loop. What we'll do is say for x in the name of our list, which is food, print x. And let me turn this line into a comment. All right, so this for loop will print all of the elements found within our list of food. And the results are sushi, hamburger, hot dog, spaghetti, and pudding. All right, people, for this next portion, I'm going to demonstrate a few useful functions of lists. And to access some of these functions, type the name of your list, dot, and there's a bunch to choose from here. Let's begin with append. We can add an element to this list. Let's say at the end, I would like to add ice cream. So then if I were to display my list, we now have ice cream at the end because we appended this value to my list of food. So let's go over a few others. So we can also remove a value, food.remove. Let's say I would like to remove hot dog. So I'm going to type that within my function, and this will remove hot dog, and that is no longer here. Next, we can pop. Food.pop. Pop will remove the last element, so this will remove pudding. We can insert a value at a given index. Food.insert. We need to list an index. Let's say 0. That would be the first position. Technically, that's where pizza is currently. And I would like to add cake. And at index 0, we now have cake. So next up, we have sort. Food.sort. This will sort a list alphabetically. So in the first position, we have hamburger, hot dog, pudding, spaghetti, then sushi. We can also clear a list. Food.clear. And this will remove all of the elements of a list. So this will not print anything because we cleared the list. Well, everyone, in conclusion, a list is really just a variable that can store multiple values. Think of it that way. So if you would like a copy of all the code that we have written here today, I will post all of this in the comments down below. But yeah, that's how lists work in Python. How's it going, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to explain 2D lists in Python. So sit back, relax, and enjoy the show. I have a super quick video for you all today on 2D lists, also referred to as multi-dimensional lists. All it is a list of separate lists. So let's begin by creating a few separate lists. Let's say we have a list called drinks, and let's assign a few values. Let's say we have coffee as well as soda and maybe some tea. All right, so we currently have one list. Let's make maybe two more. Let's make a list called dinner. And maybe in here we'll place pizza, then hamburger, and hot dog. Okay, then let's create one more for this example. Let's say dessert. And maybe we'll add 2 items. They all don't need the same amount of items or elements. So we have cake and ice cream. All right, so we have 3 lists, one called drinks, dinner, and dessert. So what we can do is add all of these lists to one list, and let's create a list called food. Food equals, and for each of these elements, we're going to place our lists. So we have drinks, dinner, and dessert. Check this out. What if I were to print my 2D list of food? So what ends up happening is that this will print all of the elements found within each individual list, and they're all grouped together. So this first portion is my drinks list, which contains coffee, soda, tea. This next element is my dinner list, which contains pizza, hamburger, hot dog, and the last element, dessert, contains cake and ice cream. If I need to access just one of these lists, I will add an index after my food 2D list and set an index number. So index 0 is referring to my first list of drinks, and this will display all of the elements found within my first list. And if I need just one of these elements, I will add a second set of square brackets and list the index of the item that I'm trying to access. So this very first item, coffee, would be index 0 and then index 0 again. So we need 2 sets of square brackets. And if I were to print this, this will display coffee. So if I go down the list, the next element would be soda and then tea. If I were to change the index within this first set of square brackets, well, now we're working with a different list. This time we're working with our dinner list. So the element at index 1, index 2, that would be our dinner list, and this will display the element of hot dog. If I change this to the next list, which would be dessert, well, we're going to receive an index out of range error because we only have 2 values within this list, cake and ice cream. There is no element at index 2 because we only added 2 elements to this list of dessert. All right, everybody, so that is 2D lists, also referred to as multidimensional lists. It's a list of separate lists. If you need to access one of the elements within your 2D list, you need 2 sets of square brackets. So if you would like a copy of this code, I will post this in the comments down below. But yeah, that's how 2D lists work in Python. Hey, what's going on, people? It's your bro. Hope you're doing well. And in this video, I'm going to explain tuples in Python. So sit back, relax, and enjoy the show. So tuples, they are collections which are ordered and unchangeable. They're very similar to lists, but they're ordered and we can't change them. They're useful for grouping together related data. Let's say we would like to create some sort of student record. So we can create a tuple to take care of that for us. So let's say we would like to create a tuple called student. The process of creating a tuple is very similar to lists, but instead of using a set of square brackets to place all of the values within, we're going to use a set of parentheses. And now we can add a bunch of values related to this collection of student. So let's add some student information. Let's say that this student's name is Bro. Let's give him an age as well as a gender. All right, so there you have it. We now have a tuple called student. And let's take a look at some of the functions related to tuples. And you can access them by typing student dot, and then there are a few here, not as many as lists. We have count and we have index. So we can find the count of how many times a value appears. Let's count how many times the value of bro appears. So we'll need to put this within a print statement so we can actually see it. So bro appears 1 time within this tuple. There is also an index method as well. So type the name of your tuple dot, and we will use the index method. We can find the index of a certain value. Let's say we would like to find the index of male, and then I will just print this to the console window. So the index of the value male would be at 2, 0, 1, 2. That's it for the methods available to tuples. A few tricks that you can do with tuples is that you can display all of the contents within a tuple using a for loop. Let's say for x in student, we will print x. So this will iterate once through all the values found within our tuple of student. And we can also check to see if a certain value exists within our tuple using an if statement. Let's say if bro in student, if this is true, then what do we want to do? Let's say print bro is here. All right, so since bro is within here, this will be true, and this will print our statement of bro is here. All right, everybody, like I said, this is a super quick video on tuples. They're very similar to lists, except they are ordered and unchangeable. If you'd like a copy of all this code, I will post all of this in the comments down below. And don't forget to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to explain what a set is in Python. So sit back, relax, and enjoy the show. A set is a collection which is unordered as well as being unindexed. They do not allow any duplicate values. For example, let's create a set of silverware. So in order to create a set, we need a name for this set. Let's call it utensils equals. And in order to create a set, we need to surround all values with a set of curly braces. Now let's add a few utensils to the set called utensils. Let's add a fork, a spoon, and maybe a knife, and that should be good. And let's display all of the values. For x in utensils, print x. Now with sets, they're different from lists because they're unordered as well as being unindexed. If I were to print all of the elements in utensils, they might not necessarily be in the same order in which we placed them. For example, when we printed all of the elements found within utensils, first we had a knife, a fork, and then a spoon. If I were to run this again, they might be in a different order, kind of like that. So a set is actually faster than a list if you need to check to see if something is within a set compared to a list, and they do not allow any duplicate values. Let me add a bunch of knives and let's see what happens. So I'll have a total of 3 knives, but when we print all of the elements of this set, only 1 knife appears. So here's a few useful methods of sets. The first method is that we can add an item to our set. So type in the name of the set, in this case it's utensils, dot, and here's a bunch of methods that you can use. I am looking for add, and we can add an element to the set. I would like to add a napkin. And then if we were to print the set, we do have a napkin within the set. We can also remove an element. Utensils dot remove. And I would like to remove the fork. And now our fork is gone. We can also clear. Utensils dot clear. And all of the elements within our set should be gone. So let me turn these lines into a comment. All right, for this next example, we'll need a second set. Let's create a second set called dishes. And then we need a set of curly braces. And let's add a bowl, a plate, and a cup. Our next method is that we're going to add one set to another by using the update method. Let's say we would like to add our dishes set to our utensil set. So let's type utensils dot and use the update method. And within this method, we will pass in the set that we would like to add. So utensils update dishes. This will add all of the elements found within dishes to our utensil set. And you can see that when we print our utensils, we have a bowl, a plate, and a cup in here as well. And then if I were to switch these around, let's say dishes update utensils. And then I will print everything found within dishes. Now there's a fork, a spoon, and a knife in here as well. We can also join 2 sets together and create a new set entirely. So let's create a set called dinner table, like we're setting up a dinner table and we need a fork, a spoon, a knife, a bowl, a plate, and a cup. So we have a dinner table set. We're going to set this equal to either utensils dot union dishes, or we could do dishes union utensils. Either way would work. And let's display all of the elements found within dinner table, and we should now have elements from both sets, utensils and dishes as well. There are also some methods in which we can compare the similarities as well as the differences between the elements found within 2 sets. Let's say I would like to check to see what utensils has that dishes doesn't. And for this example, I think I'll add a knife to my dishes set, just so that they have at least one thing in common. So I would like to see what utensils has that dishes doesn't. So we can do so using the difference method, and I will print the result with a print statement. So I'm going to compare utensils against dishes. Utensils dot difference dishes. And this will print what utensils has that dishes doesn't, which is a fork as well as a spoon. And we can reverse the roles too. We could say dishes, difference, utensils. What do dishes have that utensils doesn't? And dishes has a cup, a bowl, and a plate. They both have knives, so that's why knife isn't appearing. We can also check to see if there's anything that they have in common using the intersection method. So I'll turn this line into a comment. We'll print utensils dot intersection dishes, and this will return whatever element that they have in common, which is a knife. Alright everybody, in conclusion, a set is a collection which is unordered as well as being unindexed. They do not allow any duplicate values, and you can do things like compare two sets, see if there's anything that they have in common, any differences, and we can add or remove elements to a set. If you'd like a copy of all this code, I will post all of this in the comments down below. Don't be afraid to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain how dictionaries work in Python, so sit back, relax, and enjoy the show. Alright, let's get down to business. A dictionary is a changeable, unordered collection of unique key value pairs. They're fast because they use hashing, and they allow us to access a value quickly. Now, to create a dictionary, it's very similar to creating a set based on the last video, except we're going to store unique key value pairs. Let's create a dictionary of countries and their capitals. We can store those as key value pairs. So let's call this dictionary capitals. Capitals equals, then we need a set of curly braces, much like what we use with sets. Now we need a key and a value. Let's say we have the USA as a key, and the capital of the USA would be Washington, D.C. So in order to associate a value with a key, we'll follow the key with a colon and then add some value. And the data type really doesn't matter, but in this case, we're just using strings. So the capital of the USA would be Washington, D.C. And to add another key value pair, we'll separate each with a comma, and let's add a few others for good measure. So let's say we have India next as a key, and the value would be New Delhi. And we'll add two more. Let's say we have China, and the capital of China is Beijing. And lastly, let's add Russia. And the capital of Russia is Moscow. And there you have it, ladies and gentlemen. We now have a dictionary called capitals that has unique key value pairs. So remember, with dictionaries, they are unordered. In order to access one of these values, instead of using a numbered index, we're going to use the associated key with that value. Here's an example. Let's say I would like to print the capital of Russia. So I need to use this key of Russia. So in order to do this, type in the name of the dictionary, followed by a set of straight brackets, and then instead of an index number like 0 or 1, 2, 3, I'm going to use the key. So I would like to print the value that's stored or associated with the key of Russia. So when I run this, this will print that value, which is Moscow. So this isn't always safe. Let's say we have a key that doesn't exist, like Germany. Germany is not currently within my dictionary. So if I were to run this, well then my program is going to encounter an error, and this will interrupt the normal flow of my program. A much safer way to access a key to check to see if it's there or not is to use the get method of dictionaries. So I'm going to turn this line into a comment, and let's try this again, but this time we'll use the get method. So type in the name of the dictionary dot get and list the key that you want to use. So I would like to see if Germany is within my dictionary. Currently there isn't, so this will return none, and we will not encounter an error. So this is a much safer way of checking to see if there is a key within your dictionary. Here's a few other useful methods. There is a method to print only the keys. So we type in the name of the dictionary, capitals, and here's a listing of all of the methods that we have access to. I'm looking for the keys method, and this will print only the keys and not the values. We can also print just the values and not the keys. So type in the name of the dictionary again, capitals, dot, values. And this will print only the values. Or you could print everything, both the keys and the values. And you do so by using the items method. Capitals, dot, items. And this will print your entire dictionary. One other way in which we can display all of the key value pairs in a dictionary is to use a for loop. So at the end, let's create a for loop. For key, comma value in capitals dot items. This is going to iterate once for each key value pair in my dictionary. For each key value in capitals dot items, print key, comma, value. And this will print my entire dictionary. A feature of dictionaries is that they are mutable. That means we can change them or alter them after the program is already running. So one way in which we can do that is to use the update method of dictionaries. So let's add Germany as a key and give it a value of Berlin. So type in the name of the dictionary, capitals, and we'll use the update method. And within the parentheses of this method, we'll add a set of curly braces. And now we can add a new key value pair. So let's add Germany and a value of Berlin. So if I were to run this and display all of the key value pairs found within my dictionary, we now have Germany as a key and Berlin as its value. Not only can you use the update method to add a new key value pair, but you can update an existing one. Let's say we would like to change the capital of the USA. So capitals dot update parentheses curly braces list the key USA colon, and then we can give the USA a new value. Let's pretend that the United States government has decided to relocate their capital to Las Vegas. So this will now update our key of USA with a new value. And if I were to print all of the key value pairs found within my dictionary of capitals, the USA has a new value of Las Vegas. So the last two methods I'm going to cover are both pop and clear. You can use the pop method to remove a key value pair. So capitals dot pop parentheses and list the key of the key value pair that you would like to remove. So let's say we would like to remove China. So we'll list that key, and then when we use the pop method, that will remove this key value pair from my dictionary. And then of course we have clear as well, which will just remove everything. Capitals dot clear. And this will clear my dictionary. All right, everybody. So in conclusion, a dictionary is a changeable, unordered collection of unique key value pairs. They're fast because they use hashing, and they allow us to access a value quickly. Well, that's the basics of dictionaries in Python. If you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that's how dictionaries work in Python. Hey, what's going on, everybody? It's Bro. Hope you're doing well. And in this video, I'm going to teach you guys all about the index operator in Python. So sit back, relax, and enjoy the show. All right, people, let's begin. I'm going to be explaining the index operator, which is represented by a set of square brackets. Now, they give access to a sequence's elements. They include, but are not limited to, strings, lists, and tuples. For this example, we're going to be working with strings because strings are easy to work with. Let's say we have a name, and name equals whatever your first and last name is. We can use the index operator to access an element of the sequence, our string. So let's check to see if the first letter in our name is lowercase. And I should probably change that to lowercase for this example. So within an if statement, if name, and we can add a set of square brackets after our sequence, which is a string, and we can check a given element of our sequence. Let's check to see if the first letter is lowercase. Now, with computers, they always start at 0. If you need to access the first element in a sequence, that would be index 0. And then the next sequence, well, the next element in the sequence would be 1, then 2, then you follow that pattern. So I would like to check to see if name at index 0, that would be the first character, is lowercase. So there is a method to check that. Dot is lower. This will return true or false. If the first letter is lowercase, then our if statement is going to be resolved to true. And what I could do is that I can perhaps change it to uppercase then. So let's reassign name to equal name dot, and there is a capitalize function here. And then let's print our name. Print name. So when we run this, the first letter in my name is now capitalized. So if you need to access an element within a sequence, a string or a list or a tuple, you would add a set of square brackets afterwards, and then you list an integer of the element that you're trying to access. So here's a few other examples. I'm going to turn this as well as this into a comment. And let's say we would like to create some substrings, and we can do so using our index operator. So I would like to create a substring from the first part of my name. So what I'll do is create a new variable, first name equals name index operator. So you can specify a range for an index operator. So you would set the starting position on the left-hand side, followed by a colon, and then your ending position. So I would like this substring to begin at index 0 and end at 3. So that would be 0, colon, then 3. All right. And then I would like to make this all uppercase for some reason. And then let's print my first name. So with the index operator, we specified a range. We would like to access elements 0 through 3, turn them uppercase, and assign them to a new variable of first name. Here's a shortcut that you might find useful. If the index for your range begins with 0, you can actually delete that. You don't even necessarily need that 0. Now we just have colon 3, and this would work the same as it did before. So that's a useful shortcut, and we're going to bring it up later if we need to access the last element in a sequence. This time, let's create a substring of last name. So last name equals name index operator. This time, I would like to access the element at index, let's see, 0, 1, 2, 3, 4. All right, so I'm going to say 4, colon, and we're not really sure where our name, our last name, is going to end. So what you could do is just say colon and then leave the next index blank. So that will be the index beginning at 4 and everything afterwards. And let's say 2 lower to make this all lowercase for some reason. So let's print our last name. Print last name. So this should take everything starting at index 4 and after that and turn it into its own substring of last name. Now you can access the last element in a sequence by using what's called negative indexing. So let's add a exclamation point to the end of our name. So let's say we have a new variable called last character. And I would like to store the last character in my name to this new variable, this new substring. So to access the last element in a sequence within the index operator, we can use negative indexing. So the last element would be -1. All right. And then let's print whatever our last character is. So this should print an exclamation point. Yep, which it did. So then if this was -2, that would be the second to last element in a sequence. So now that would be E, because E is in the second to last element in my sequence. All right, everybody, so that's the basics of the index operator. You can add a set of square brackets after a string, a list, or a tuple, and then list an integer or a range of the elements that you're trying to access. So if you would like a copy of all this code, I will post everything in the comments down below. Don't be afraid to help me out and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video I'm going to explain how functions work in Python, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Okay, let's do this thing. A function is a block of code which is executed only when it is called. This process is also known as invoking a function. With programming, we try not to repeat code if we don't have to. That's why functions are useful, because our function can perform some specific task for us, some block of code for us, whenever it is called. So we only need to write that block of code once, and if we need to repeat it, we just call this function one more time. So let's define and create a function. We'll create a function called hello, And in order to define a function, we'll type def and then a unique function name. So let's call this function hello. And with functions, they always end with a set of parentheses. And lastly, to finish defining this function, we'll add a colon at the end. So if you go down to the next line, take notice that my cursor is now indented. Any code underneath a function that is indented belongs to that specific function and will only execute whenever that function is called. So for now, we need to type in something. If you don't know what you want your function to do, you can always type pass for now. But let's print something. Print the word hello. And in order to call this function, all we need to do within our program is type the name of the function, which is hello, and then add a set of parentheses because functions always end with a set of parentheses. So what this will do is execute my function once and perform this block of code whenever it is called. If I were to remove this, well, our program currently isn't going to do anything because functions only execute their block of code only when it is called. So this time, let's print the word hello 3 times. So I will call this function 3 separate times. Hello, hello, hello. So when I run this, our hello function will be called 3 separate times. Now, with functions, they are not limited to just one line. This is an entire block of code, so maybe we can do something else too. Let's print, have a nice day. Now, if I were to run this, my hello function is going to execute this entire block of code 3 separate times. Hello, have a nice day. Now, an important feature of functions is that we can send our function some information, and our function can do something with that information that it receives. Let's say this time I would like to print hello plus somebody's name. Currently, name is an unresolved reference. What we can do when we call this function is send our function some information. This can be a value, a variable, a collection, all sorts of different things. So if you need to send your function some information, within the parentheses when you call that function, just list the data that you want to send your function. So let's say I would like to send my function a string value of bro, whatever your first name is. When you send information to a function, these are called arguments. They are the information that you're sending to a function. And when you define that function, you need a matching set of what is known as parameters. So our hello function is going to receive one argument, a string value. We need a matching number of parameters. Currently, this isn't going to work. You can see here that hello takes 0 positional arguments, but 1 was given. Our function needs a matching number of parameters. So think of it this way. When we receive this value, we're going to give a nickname to this value. So when we receive the string value, what do we want to call it? Well, let's call it name. So in order to add parameters to your function, just list the parameters within the parentheses of that function. And well, this should work now. We have a matching set of arguments and parameters. When we call the hello function, this time we are sending one argument over, and when our hello function receives this argument, we're going to give it a temporary nickname of name, or you can call this whatever you want to. And then we can use this value for whatever we want within our function. Now, if we were to run this, this will print, hello bro, have a nice day. Now I can send maybe a different value. Let's say hello, and then I will send a string value of dude. Hello dude, have a nice day. So this isn't limited to just values, we can send variables too. Let's say we have a variable called name equals bro. And this time I'm going to send this variable over, hello, and then send name. So these don't need to be the exact same. Let's say this is my name, and I'm going to send my name over, and I will temporarily give this value a nickname of just name. And then I can use this variable for something. Hello bro, have a nice day. Now, with arguments, you can send more than one value over. Let's say this time I would like to send 2 values over. So let's send bro, maybe for a first name, and code for a second name, but you can use your first name and last name. So this isn't going to work because we do not have a matching set of arguments and parameters. we're sending 2 arguments over, but our function is only designed to accept 1 argument because we have 1 parameter. So let's rename name as first name, and we need 2 parameters this time. So what are we going to call this value when we receive it? Let's call this last name. So this time we are going to receive 2 values. They will be nicknamed first name and last name. So this time let's print hello first name. Maybe I'll add a space plus last name. And this is now valid. Hello bro code, have a nice day. With arguments, you can mix and match the data types that you're sending as arguments. So currently we're sending 2 string values as arguments. This time, let's send an integer value. Let's say we would like to send an age over to our hello function. So I'll just send maybe the value of 21. So currently this isn't going to work because the hello function takes 2 positional arguments, but 3 were given. When we call this hello function, we're sending this argument over, but our function doesn't know what to do with this argument. So we need a matching parameter for this value that it receives. So let's call this value, maybe age, as a temporary nickname, and then we can do something with this value when we receive it. So let's print an additional message. Perhaps you are plus age plus years old. So if you need to display an integer or number along with the string, you do need to convert it to a string. So let's just cast our age as a string when we display this. So this should work now. We now have a matching number of arguments and parameters. So this will display, hello bro code, you are 21 years old, have a nice day. So ladies and gentlemen, in conclusion, a function is a block of code which is executed only when it is called. If I were to remove this function call, well then our program is just going to completely ignore this function and this block of code would not be executed. When we call this function, we can pass information known as arguments, but we need a matching number of parameters set up to receive these arguments. There are a few advanced features of parameters, but I'll hopefully get to that in future videos. We'll just stick with the basics for now of functions. So that's the basics of functions. If you would like a copy of this code, I will post this in the comments down below. But yeah, that is how functions work in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain the return statement in Python, so sit back, relax, and enjoy the show. Alright people, let's begin. The return statement is used within functions to send Python values or objects back to the caller. These values or objects are known as the function's return value. So do you know how with functions we can pass arguments to a function, and then our function can do something with those arguments? Well, not only that, but our function can pass some value or object back to the caller. So what we'll do for this example is create a function that will simply multiply 2 numbers together and return the result back to the caller. So let's define a function called multiply, and we'll set up 2 parameters for this function. Let's say number 1 and number 2. And what we'll do is say result equals number 1 times number 2. And then at the end, we can return something. What do we want to return? Let's return whatever the result is. Now, when we call this function, we will pass in 2 values as arguments. Let's say we would like to multiply 6 times 8. So when we run this, while we can't actually see anything, when we return the result after multiplying numbers 1 and 2, it's going to return the result back to the caller. In order to see the value that is returned back to the caller, one way in which we can do this is to print the value that is returned within a print statement. So what we'll do is print the value that is returned after calling the multiply function. So 6 times 8 is really great. 6 times 8 is 48. Now, one other thing that we can do is store the returned value within a variable. So let's say x equals multiply 6 times 8, and then we will print whatever x is. So the result is still the same of 48. Now, with the return value, there is another way in which we could write this that uses less lines of code. So we'll delete this first line, And instead of returning a variable called result, what we'll do is just return number1 times number2. And this would work the same as it does before, but it's written in less lines of code. So that's another way in which you could write this. All right, everybody, so that is the return statement. Functions can send Python values or objects back to the caller. These values or objects are known as the function's return value. You can either print this value directly to the console window, or you can store it within a variable or some other location. And well, ladies and gentlemen, that is how the return statement works in Python. What's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to explain keyword arguments in Python. So sit back, relax, and enjoy the show. All right, everybody, let's discuss keyword arguments. These are arguments that are preceded by an identifier when we pass them to a function. The order of the arguments doesn't matter, unlike positional arguments, which do matter, and we've been working with positional arguments already. And Python knows the names of the arguments that our function receives when we use keyword arguments. Here's an example of us using positional arguments, and then I'll demonstrate the benefits of keyword arguments. Let's say we have a function called hello that accepts 3 arguments, a first name, a middle name, and a last name, and the output will be hello, first name, middle name, last name. So if I were to run this, this will display hello, bro, dude, code. So we're using positional arguments. The order of the arguments does matter. What do you think is going to happen if I were to replace some of these values? Let's say I will swap the first argument with the third argument. So let's try it again. Hello, code, dude, bro. So obviously the order of the arguments matters. And now if we were to use keyword arguments, then the order of the arguments doesn't matter, but with each argument, we need to precede each argument with a unique identifier. And that identifier is the name of the parameter we want to associate each argument with. So for my intended last name, I will use an identifier of last to match this parameter. So dude will be middle, middle equals dude, and bro will be first, even though they're not in the correct order. So let's try this again. And my output is hello, bro, dude, code. So that's all about keyword arguments. They are arguments preceded with an identifier when we pass them to a function. The order of the arguments doesn't matter, unlike positional arguments, which do matter. And then Python knows the names of the arguments that our function receives when we use keyword arguments. So that's it for keyword arguments. If you would like a copy of this code, I will post this in the comment section down below. But yeah, that's how keyword arguments work in Python. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to explain nested function calls in Python. So sit back, relax, and enjoy the show. All right, people, nested function calls. These are function calls inside of other function calls. And this is possible because certain functions will return a value, and we can immediately use that value as an argument for the next function. So here's an example. Let's say that we have this small program where we will ask a user to type in a whole positive number. And let's say I don't. Let's say I type in -3.14, and then I'm storing that value within a variable named num. What I'm going to do is convert that number to a floating point number because currently it's a string. When you accept user input, I will find the absolute value of num and then round it to the nearest whole number and then print the value. So we can actually do this using less lines of code with nested function calls. So let's start with the first function, which will be accepting some user input, the input function. So this will be in the very center of our nested function calls. And then the next function we would like to apply to the variable that is returned, the value that is returned, we will pass in as an argument to our next function of casting this data type to a float. So we'll surround our function with another function and use the float function. And then we'll just keep on adding layers to this. So we have the absolute value function next. So we'll add another layer. And we have the round function. So we'll add a layer to that. And lastly, we're going to print, and that'll be the outermost layer. So this program will do the exact same thing. Let's say -3.14, except we've written this with one line of code. So basically, we start with the innermost function and resolve that first. Whatever value is returned, we use as an argument to the next outermost function. And in this case, it would be float. Then we resolve that, then move on to absolute value, then round, and then print. So it's just another way of writing code that takes up less lines, but this is more of an extreme example. You probably won't see like 4 or 5 nested functions. Well, everybody, those are nested function calls. If you would like a copy of this code, I will post all of this to the comment section down below. But yeah, those are nested function calls in Python. Hey, what's going on, people? It's your bro. Hope you're doing well. And in this video, I'm going to show you how variable scope works in Python. So sit back, relax, and enjoy the show. Alright, let's do a thing, people. Let's discuss the scope of a variable. Now, the scope of a variable is the region that a variable is recognized. A variable is only available from inside the region that it is created. Let's say that we have a function, and I just gave this function a name of display name. I created a variable inside of this function named name, and you can assign this a value of whatever your name is, preferably a last name for this example. And what I'll do is just print whatever my name is. So this variable is known to have a local scope because it's declared inside of a function. And a variable is only recognized inside of the region that it is created. This variable of name, since it's created inside of this function, it is known as a local variable that has a local scope. It's only available inside of this function that it's created. Now let's attempt to access this variable from outside of our function. So I'm going to print my name variable, but we'll have an issue though. So name is not defined. So local variables are declared inside of a function and they have a local scope. They are only available inside of this function in which they're created. On the other hand, a global variable is a variable that is declared outside of any function, but within your module that you're working with. A global variable is known to have a global scope. They are available inside and outside of any functions. Now, if I was to print my name variable, this is going to print bro, or whatever your first name is. And it is entirely possible to have both a global and local version of the same named variable. So we have both a global version of name as well as a local version of name. If I was to print my name variable from outside of this function, it's going to print my global version. However, if I print my version of name inside of that function in which it's created, we're going to first use the local version before the global version of name. And let's try that. So I'm going to call my display name function, and this will print my last name, code, and then my first name of bro. So it is possible to have a global and local version of the same named variable. Now, if I was to remove this line where we declare a local version of name, well then the next best available name to us would be the global version of name. So if you use a variable inside of a function, you'll first use a local version of that variable if it's available. If not, you'll use a global version instead. And Python will follow this rule known as the LEGB rule. You use any local variables first, then enclosed variables, then global, and then any built-in variables in that order. So that's the main difference between local scope and global scope. The scope of a variable is the region in which it's available, and it's limited to the region in which it's created. A local scope is available only inside of the function in which that variable is created. A global scoped variable is a variable that is available inside and outside of any functions, but within your module that you're working with. So that's variable scope in Python. If you would like a copy of this code, I will post this code to the comment section down below. And well, yeah, that's how variable scope works in Python. Hey, what's going on, everybody? It's bro. Hope you're doing well. And in this video, I'm going to explain the args parameter in Python. So sit back, relax, and enjoy the show. Alright guys and gals, let's talk about args. Now args is a parameter that will pack all arguments into a tuple. It's useful so that a function can accept a varying amount of arguments. Here's an example of why it would be useful. Let's say we have a function called add that will accept two numbers as arguments and add them together and return the sum. So this works as intended, right? As long as we pass in only two numbers. But what if we need to pass in three numbers as arguments? Well, we can no longer use this add function because we have two parameters set up, but we're passing in 3 arguments. You can see here within my console window that we have a type error. Add takes 2 positional arguments, but 3 were given. And one way in which we can solve this issue is to use this args parameter. So what we're going to do is replace all of our parameters with asterisk args. And actually, the args portion isn't as important as the asterisk. Args is short for arguments, and you can really name this whatever you want. Just be sure that you have this asterisk, because with this asterisk, we're doing a form of packing. What we're doing is passing all of these arguments and packing them into a tuple. So let's rewrite this program. So let's say maybe sum equals 0, and then we will need to iterate through all of the items within our tuple because tuples are iterable. So let's say for I in args. What we'll do is say sum plus equals whatever I is, and at the end, when we escape the for loop, we will return our sum. So let's try it again and see if it works. Well, would you look at that? It works. Let's pass in a few other arguments for good measure. Let's pass in 6 arguments this time. All right, look at that. This does in fact work. So you can actually name this whatever you want. The important thing is to have this asterisk. So let's rename this as, I don't know, stuff. And let's try this again. Yep, it still works. With tuples, they are ordered and unchangeable. Let's attempt to edit one of these values. So let's say stuff at index 0 is equal to 0. And let's try and change it. So you can see that tuple object does not support item assignment. If you need to change one of the values within your tuple after you pack all of these arguments, you might need to convert this to a different collection. One way in which we can do that is to cast it. Let's say stuff equals, and we'll cast our tuple as a list, because a list can be changeable, it's mutable. So let's attempt this again. We'll cast our tuple as a list, and then edit one of the values, and then add all the values together. So to change one of the values, say the name of your collection, stuff in this case, let's say at index 0, this now equals 0. So now if we were to add all these items together, they should equal 20. There we go. So yeah, that's basically the args parameter. The name isn't as important as the asterisk because you can really name it whatever you want. A common convention is to just name this args. It's a parameter that will pack all arguments into a tuple. It's useful so that a function can accept a varying amount of arguments. Well, that is all about args. If you would like a copy of this code, I will post this in the comment section down below. But yeah, that is how the args parameter works in Python. Hey, what's going on everybody? It's Bro, hope you're doing well, and in this video I'm going to be explaining kwargs in Python, so sit back, relax, and enjoy the show. Alright everybody, let's talk about kwargs. Now, this is a parameter that will pack all arguments into a dictionary. It's useful so that a function can accept a varying amount of keyword arguments. It's identical to args, except with args will accept a varying amount of positional arguments and pack them into a tuple. With kwargs, this will accept a varying amount of keyword arguments and pack them into a dictionary. So here's an example of why this would be useful. Let's say we have a function called hello that accepts 2 keyword arguments, a first name and a last name. All this will do is output hello, your first name and last name. But what if somebody has more than 2 names? Let's say somebody has a middle name. And for this example, I'll just say my middle name is Dude. So if I were to run this, well, this hello function is no longer going to work. As you can see in the console window, we have a type error. The hello function got an unexpected keyword argument middle. One way in which we can solve this, we can use this kwargs parameter so we can accept a varying amount of keyword arguments. So what we'll do is replace our parameters with 2 asterisks, then kwargs. Now, if I would like the same output as I had before, I'm going to need to change a few things around. In order to access a value within a dictionary, you type the name of the dictionary, square brackets, and then within quotes, list your key. So I would like to access the value at this key first. And let's repeat the process for last name. So the key is going to be last. We'll access this value at this key. And this should work the same as it did before. Now let's take this a step further. Let's say we would like to display somebody's full name based on the amount of keyword arguments that they pass into this function. Well, there's a few different ways in which we could do this. One easy way is that we could write our program like this. let's print the word hello, and we will need to iterate once through each key value pair within this dictionary, and we can use a for loop to do that. So to iterate once through each key value pair in your dictionary, we'll type for key value in the name of our dictionary, Quargs in this case, dot items, and then we will print each value. So there's one more thing that we need to do. This kind of works as intended, but it's going to print each value, including our word hello, on a new line. So with a standard print statement, this will print a new line character after each print statement as if we're hitting enter. We can actually change that. So after your string, add end equals, and we can replace that new line character with something else, maybe a space. And let's do the same thing for our for loop. So value, comma, end, and then just add a space. Now this will print all of your names all in the same line. Hello, bro, dude, code. And now we can pass in a varying amount of keyword arguments based on how long our name is. Perhaps we have like a title. Title equals Mr. And we can print that as well. Hello, Mr. Bro, dude, code. Here's a fun fact of the day. You don't necessarily need to name this parameter as Quargs. The important thing is to have these double asterisks that precede it. Quargs is just a common naming convention. It's short for keyword arguments. You could name this as something else, perhaps something more descriptive like names, since we're passing in a bunch of names. So the name of our dictionary is now names, and this would work the same as it did before. The important thing is to have these double asterisks that precede the name of your dictionary, but Quargs is the common naming convention. Well, everybody, that's all about Quargs. It's a parameter that will pack a varying amount of keyword arguments into a dictionary. If you would like a copy of all this code, I will post this in the comments section down below. But yeah, that is how Quargs works in Python. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys all about the format method in Python. So sit back, relax, and enjoy the show. Okay, ladies and gentlemen, let's begin. The format method is a method available to strings. It's optional, and it gives users more control when displaying output. To best demonstrate this, I'm going to use a line from a popular nursery rhyme titled Hey Diddle Diddle because, well, you know, I'm a mature adult like that. I'll be printing this line to my console window. The cow jumped over the moon. Let's do so using a standard print statement, and then I'll show you the benefits of using the format method later. For this example, I have two variables, a variable called animal, and I'm going to store a string of cow and item, and I'll be storing an item name, which is moon. When we compile and run this, as you would expect, the output is the cow jumped over the moon. There's a more elegant way of writing this line of code, and that is by using the format method available to strings. I'm going to turn this line into a comment, and we're instead going to produce the same output, but use the format method instead. So we need a standard print statement like usual, and then a string that we would like to format. So we're going to write the same thing, but in place of the variables, we're going to add a placeholder. Instead of the variable name or value name, I'm going to add a set of curly braces. So that functions as a placeholder for a value or a variable. This should be cow, jumped over and I'm going to insert another placeholder. Now this is a string. We can format the string by following this string with dot format parentheses, and within the parentheses of the format method, we can insert some values or variables. Let's begin with some values. I would like to insert cow as well as moon. So this will produce the same output, but it's written a little more elegantly. We can also replace these with variables because they store these values. So I'm going to replace cow with animal and moon with item, and this will create the same output as it did before. These curly braces are what's known as format fields. They function as a placeholder for a value or a variable, and they work in order. The first format field will insert the first value at this location. If you have another set or more sets of this format field, you'll insert the next value that's listed within the format method. So if we were to switch these around, we'll switch the position of animal with item. Well, then the first format field is going to insert our item, and the second format field will insert our animal. This time, the moon jumped over the cow. An additional way of inserting values at a given placeholder would be to use what's referred to as a positional argument. Within these format fields, we will list the index of the value that we would like to insert at this location. If you need to insert the first value, well, that has an index of 0 because computers always start with 0. And following that pattern, the next index would be 1. If you had, let's say, 3 values that you need to insert, if you had another placeholder, that would be 2 then. So you would just follow that pattern. So there's going to be no visible change. But what we could do is reverse the positional arguments of these placeholders. So what do you think would happen if I switched 1 with 0 at these locations? Well, this format field is going to insert the value found at index 1. This first value is index 0, and the second one is index 1. So now the roles are reversed. This time, the moon jumped over the cow. Our last way of inserting some values at a given format field would be to use what's referred to as a keyword argument. Within the format method, we're going to list some keyword argument pairs. We need a keyword name followed by a value. So let's say animal is going to be the keyword. We're going to say equals some value. Animal equals cow, and item equals moon. And you may have noticed that the color of your text might have changed. So we no longer need these variables actually, but I'm going to comment out these two print statements because we will get an error then. So these are in keyword argument pairs. And within our format field, instead of keeping these empty or using an index, we can use the keyword name. At my first format field, I'm going to insert my keyword of animal. And at my second format field, I would like to insert the item keyword. So the result is going to be the cow jumped over the moon. So let's reverse these now. We'll place our item keyword here, and then at the second format field, we will insert our animal. And this time, the moon jumped over the cow. Here's an important concept that I'd like to bring to your attention. With these values found within the format method, you can actually reuse some of these more than once. So let's say we would like to state the animal jumped over the animal. We're going to use this animal keyword twice, and our output is going to be the cow jumped over the cow. If we're doing the same thing with positional arguments, we can reuse the same index. This time, let's say that the moon jumped over the moon. So our item has an index of 1. So within our first format field, we'll state the index will be 1, and our second format field will also be 1. So our output's going to be the moon jumped over the moon. All right, let's take things up a level. There's an even more elegant way in which we could write all of this. What we'll do is store our string that we would like to format within a variable. Let's turn this line into a comment, and let's create a variable called text. Text equals the string that we would like to format, which is the format field jumped over the format field. And if we need to format this variable, we can just call the format method on it. So within a print statement, let's say text dot, and then use the format method and pass in the values that we would like to insert at these placeholders. So we're going to insert animal as well as item. So our result, as you would imagine, is the cow jumped over the moon. In this next section, I'm going to explain how we can add some padding to a string when we display it using the format method. Let's say we have a name variable and assign this a value of whatever your name is. So I would like to display my name along with a custom message. Let's say, hello, my name is, and then I'll use a format field here. So let's follow this string by using the format method, and I would like to insert my name at this location. So currently this will display, hello, my name is bro, or whatever else your name is. So we can add some padding either before our name, after, or we can add some padding to the left and the right hand side of our value that we have. So what we'll do to begin is let's add some padding to the right hand side of our name that we have. So within our format field, if we need to add some padding, within the format field add colon,
and then the amount of space you would like to allocate to displaying your value. So let's say 10. So I'm going to allocate 10 spaces worth of room to display my name. You can't really see it right now, but let's take a look. So I can't move my cursor past this line at the end of my name, but with my second line, I have all of this room to work with. So if I were to change my string that I have, let's say, nice to meet you, well then all of this padding that I have is going to be more evident. So we can add a number preceding with a colon to add some padding to a value, and then you can left align this, right align it, or center align it. So what I'll do is copy this line that I have. If you need to left align it, you use the less than sign, but there's going to be no visible change because that's already the default. If you need to right align, precede your number with a greater than sign, so your value is going to be right aligned. If you need to center this value, then use the caret. So this will center align your value within the padding that you have allotted. One question that you might have for me, and I'll try and answer that now because it's relevant. What if we need to add a positional argument or a keyword argument to our format field if there's already some text within here? So what you would do before the colon, you would just precede the colon with either your positional argument or your keyword argument, followed by colon and then whatever you want to add afterwards to format your value that you have. All right, ladies and gentlemen, we are near the end, and I promise that this is the last section. How can we format some numbers? Let's say we have a number variable, and this will equal the first few digits of pi, 3.14159. Let's pretend that we would like to display only the first two digits after the decimal. So we can do so using the format method. Let's print the number pi is, and then I'll use a format field here, and we will call the format method and insert our number that we have. So if I need to display only the first two digits after the decimal within the format field, I will add colon dot to f. F is for floating point numbers. That's anything with a decimal portion. So the result is that this will display only the first two digits after my decimal because we placed 2 within the format field. So if this was 3.3f, this would display 3 digits after the decimal portion. Oh, and apparently this will round your number, so that's something that you should keep in mind. So this time, let's change our number to something larger like 1000. And I will copy this line and make a few changes. Let's say the number is, and I would like to add a comma at the thousands place. So after the colon within the format field, I will add a comma. So this will automatically add a comma to all 1000th places. Another cool thing that you can do is that you can display your number as binary. So within the format field, add :b. This will display a binary representation of your number. You can do the same thing with octal by adding :o. So our number is now being displayed as an octal number, and you can do the same thing with hexadecimal, lowercase x for lowercase or uppercase x for all uppercase. So my number 1000 is now in hexadecimal. And lastly, we can display this number in scientific notation using either lowercase e for lowercase or capital E for uppercase. And my number 1000 is now in scientific notation. All right, everybody, so that's a few things that you can do with the format method. It's an optional method that gives users more control when displaying output. If you would like a copy of all the code that we've written here today, I will post everything in the comments down below. Don't be afraid to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro.
Hey, what's going on, everybody? It's your bro. Hope you're doing well, and in this video I'm going to explain a few useful methods of the random module, so sit back, relax, and enjoy the show. Okay, people, in this video I'm going to explain how we can generate some random numbers as well as a few other useful methods of the random module. Now, we're not going to be creating true random numbers, but something called pseudo-random numbers, which are fairly darn close. So the first step is to import the random module at the top. Import random. We now have access to everything that the random module has to offer.
Let's begin by generating a random number between 1 and 6, like we're rolling a dice. So what I'm going to do is say x equals random dot rand int, and we can generate a random integer between a certain range. If I want 1 through 6, I will state 1, 6, and then we can generate a random number between 1 and 6 like we're rolling a dice. So if I were to print the value of x, then we will get a random number between 1 and 6. For example, I just got a 1, a 2, a 3, and a 6. All right, we can also generate a random floating point number too. Let's say y equals random dot random. So this will give us a random number between 0 and 1. This time I'm going to print y. So we have 0.49 and some change, 0.145, and 0.858. We can also generate a random choice from a list or other collection. Let's say we're playing a game of rock, paper, scissors. So let's create a list. I'll just call this my list equals square brackets, and we will have 3 choices: rock, paper, and scissors. So let's say z will be the random string that we generate. Z equals random dot choice, and we will pass in my list. And let's print z. So this will generate a random choice from my list called my list. So we got scissors, paper, and rock. We can also use the shuffle method of the random module to shuffle a list or other collection. Let's say we're working with a deck of cards. Cards equals, let's say 1 through 9. And we have a jack, a queen, a king, and an ace. This won't be a full deck of cards, it'll just be one suit. So we can actually shuffle this list by using the shuffle method. Random dot shuffle. What do we want to shuffle? We want to shuffle our cards. And I will display my cards with a print statement. So the shuffle method will shuffle a list or other collection for you. Well, everybody, that's a few useful methods of the random module. If you would like a copy of all this code, I will post this in the comments down below. Don't be afraid to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro.
Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video I'm going to explain exception handling in Python, so sit back, relax, and enjoy the show. Well, everyone, let's talk about exceptions. An exception is an event detected during execution that interrupts the normal flow of a program. Here's a program that I've written, and we're intentionally going to cause an exception. So this program that I've written, we will accept a numerator and a denominator from the user. We'll divide the numerator by the denominator, we'll get a result, and print the result. So what if I were to divide a number such as 5 divided by 0, which we cannot mathematically do? Well, this will cause an exception, an event detected during execution that interrupts the flow of a program. So our program was interrupted, and within our console window we have this traceback message, which states what went wrong and a name for this exception that occurred. This specific exception that occurred is a 0 division error. So this video is all about handling these exceptions so they do not interrupt the normal flow of a program. Now, a very basic form of exception handling is to surround any code that is considered dangerous, as in it might cause an exception within a try block. Anytime you accept user input would be a good indicator too. So this code is considered dangerous because we don't know what the user is going to type in. So we will try all of this code. If an exception occurs, we can catch it and handle it. So to do that, we'll add an except block, except, and then we will catch exception. Normally, having this block by itself isn't considered good practice, but I'll explain why later. So this except exception block will catch all sorts of different exceptions, and it will prevent our program from being interrupted, and we can do something else entirely, such as print a message. Something went wrong. So let's try this again. We will divide 5 by 0, which we cannot do. We no longer have that traceback message within our console window. We caught the exception and we did something else. We printed something went wrong. Like I said before, it's not considered good practice to have a single except block that will handle all exceptions. It's much better to first handle specific exceptions when they occur, and we can do so by writing additional except blocks. So let's create an additional except block that will catch any zero division error exceptions. That occurs when somebody attempts to divide by zero. So if this exception occurs, how do we want to handle it? Let's just print a message. Let's print you can't divide by 0, idiot. And let's try this again. So 5 divided by 0. You can't divide by 0, idiot. Here's another one. I'm going to turn this except block into a comment so we can take a look at something. What if I divide by something that's not a number? Like we take 5 and divide it by the word pizza. Well, pizza's not a number, and we ran into a value error exception. So we should probably handle this too. So let's create another except block that will handle that. Except value error. And how do we want to handle this? Let's print something. Enter only numbers, please. Okay, let's try this again and see if this exception is caught. 5 divided by the word pizza. Enter only numbers, please. Not only that, but you can also add the exception block at the very end, just in case there's something you won't anticipate. But it's always considered good practice to first catch any specific exceptions and let the user know exactly what went wrong. An additional way in which we can handle these exceptions is that we could display the exception that occurs, although it is completely optional. So to do that, what we'll do is that after each of these except block definitions, let's add as e. So we're calling the exception as e. That's just standard practice, although it's not necessary. So let's do that for each of these except blocks. And then we can print whatever e is. So let's add that to each of these blocks. So it should now look something like this. So when we encounter an exception, we can display what exception occurred to as well. So let's divide 5 by pizza. Invalid literal for int with base 10. Pizza. Enter only numbers, please. So like I said, this is an additional way in which you could handle an exception, although it's entirely optional. Another thing that you can do is that you can add an else statement to the end of your except blocks. So what's happening here is that we're going to try all of this code. If an exception happens, then catch it and handle it. If not, then do something else. So why don't we print our result only if there are no exceptions that occur? So if there are no exceptions, we will execute this else statement. If not, then we won't. So let's divide 5 by an actual number this time, like 2. So there are no exceptions that occurred, so we executed this else statement, whatever code is within our else block, and this printed the result of 2.5. But if an exception were to occur, like we divide 5 by 0, then we will catch our exception and handle it, and we do not execute whatever block of code is within our else statement. There is one other clause that you should be aware of. That is the finally clause. This is always at the end. How this works is that whether or not we catch an exception, we will always execute any code that is within the block of code for our finally clause. So this is a good opportunity if you open files to close them within the finally block. But we haven't dealt with opening files yet, so we won't do that. All we'll do is just print something. Print this will always execute. So whether or not we encounter an exception, this finally block will always execute at the end. So let's try this again. So this time, let's cause an exception. Let's divide 5 by 0. You can't divide by 0. This will always execute. And this time, let's take this seriously and divide 5 by another number such as 3. So this will give us a result. And like I said, the finally clause, the code within the finally clause will always execute. But we won't really be working with this until we get to the section on file handling. Well, everybody, those are exceptions in Python. They are events detected during execution that interrupt the flow of a program. And we can handle these exceptions by using try and except blocks. So if you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that is how exceptions work in Python. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video we're going to be covering some basic file detection using Python, so sit back, relax, and enjoy the show. Welcome, ladies and gentlemen, to the beginning of a mini-series involving doing stuff with files using Python, and in this video we're going to be doing some basic file detection. And in order to do so, I recommend importing the OS module. It's already included with the standard Python library. All you need to do is import it. All we'll be doing is checking to see if a file exists someplace on our computer. So we'll probably need a file to work with. What I'm going to do is go to my desktop for convenience and just create a new text document. I will call this test.txt. Now, I probably need the file location, so I'm going to copy that, and then we can use this. So let's create a variable called path that will include the path to the file that I would like to detect. So that was test.txt. Now, if you have backslashes in your file path, you'll probably need double backslashes because that's the escape sequence for a backslash within a string. So we now have this variable path that we can work with. Now I would like to check to see if this location exists on my computer. So if os.path.exists, and you can see that we can pass in our path as an argument. So I will pass in my path, and if this returns true, if that location exists, I will print that location exists. So this will not tell me if this is a file or not. We'll be covering that later. Else, let's print that location doesn't exist. All right, so if this location exists, this will return true. If not, this will execute our else statement. That location exists. So what if I were to delete this file and we run this program again? That location doesn't exist. Now, this won't tell you if the location you're dealing with is a file or not. There is a separate function for that. It is if os.path.isFile. What we'll do is pass in our path and print that is a file. All right, so let's create another file because I deleted the previous one. Test.txt, it's in the same location. Let's run this again. That location exists. That is a file. Now, what if this was a folder? So I'm going to create a new folder. I will call this folder. I will delete my test document. And let's change the location to folder. That location exists, but it is not a file. You can check to see if a location is a directory. So let's write an else if statement. os.path.isDirectory, and we will pass in our path. And let's print that is a directory. All right, so we have our folder. We're going to check to see if this location exists and if it's a file or a directory. That location exists. That is a directory. Well, everyone, that is the basics of file detection. We'll be building upon this concept in future videos. So if you would like a copy of this code, I will post this in the comment section down below. But yeah, that is the basics of simple file detection using Python. Hey, what's going on, everybody? It's Bro. Hope you're doing well. And in this video, we're going to be reading a file in Python. So sit back, relax, and enjoy the show. Welcome back, guys and gals. In this video, I'm going to explain how we can read the contents of a file using Python. So we'll probably need some sort of file to work with. I created a plain text file called test.txt. It's a plain text file, and all this says is, OMG, you can read this. Have a nice day. Like, comment, and subscribe. So what I would like to do is to read the contents of that file line by line and print it to the console window. And here's how. And honestly, we only need 2 lines of code to do this. So what we'll do is type with open, then within the open function, list the name of your file or the file path. This file of mine is within my project folder, so I only need to list the file name. If this was someplace else, you'll probably need the file path. So let's say this was on my desktop. Well, I'll probably need to list the file path of where that file is located, and I'll need to use double backslashes because that's the escape sequence for a backslash. But since this file is within my project folder, I only need to list the file name. So with open, then the name of your file or the file path as file, then what we're going to do is print file dot read. And that is it. So let's test it. And it works. OMG, you can read this. Have a nice day. Like, comment, and subscribe. So this will actually close files automatically after opening them, so that's kind of convenient. And let's just test that theory. So I'm going to print file.closed. If my file is in fact closed, this will print true. If it's still open, this will print false. So normally when you read a file, it's normally open and you need to close it manually, but if you write your program this way, with open, this will close the file automatically for you. So using with open will close any files automatically for you after they've been opened. However, this does not catch and handle any exceptions that might occur, like if we cannot locate this file. So let's say that I mistype the extension for this file. Let's say that I type in test.tx. That's kind of funny because tx is the abbreviation for Texas. It's a Texas file. So this will cause a file not found error, and this will interrupt the flow of our program, and we would probably like to prevent that. So what we could do is write a try and an except block. So we will try all of this code. If we cannot find this file, we can handle this exception, file not found error. So we'll place all of this code within the try block. Then if an exception happens, we will catch that exception. Except we would like to catch any file not found error exceptions. And let's handle this by printing that file was not found. So if I were to run this again, we will catch and handle this exception, and this will not interrupt the normal flow of our program. Well, everybody, that's how to open and read a file in Python. If you would like a copy of all this code, I will post this in the comment section down below. But yeah, that's how to open and read a file using Python. Hey, what's going on everybody? It's Bro, hope you're doing well, and in this video we're going to be writing files in Python, so sit back, relax, and enjoy the show. So to begin, it's kind of similar to the last video on reading files. With open, within the open function, list the file name or the file path. So what do you want to call this file? I will call this file test.txt. Now normally with the open function, there is a mode, and you can actually change that. There's a second argument that you can pass in. By default, this is R for read, but if you want to write a file, this would be W. So now we're going to write a file called test.txt. So to finish, with open as file, what are we going to do? File.write. And within the write function, we can write some text. So let's create a text variable and we will add a string. So let's say text equals yo. And if you need to go down to a new line, be sure to use the new line character. So after this new line character, the text that comes after is going to be on the next line as if we're hitting enter. So yo, this is some text. Have a good one. Alright, so after I run this program, we should have a file, a text file within our project folder that appears. And it is right here, and it says, yo, this is some text. Have a good one. Now, this is in write mode. If this text was something else, it will actually overwrite your current file. So if I were to change this to, this text has been overwritten, well then this will overwrite the text that we have. This text has been overwritten. So you can actually append a file by changing the mode to A for append. So let me change this back. We will rewrite this. This will save over our current file. Now we can append some text. So let's add maybe a new line. Have a nice day. See ya. So I would like to append some text to this file. I'm going to change the mode to A for append. And we can now append some text onto the end of this file. Well everybody, that's how to write to a file and or append a file. If you would like a copy of this code, I will post this in the comment section down below. But yeah, that's how to write to and or append a file in Python. Hey, what's going on everybody? It's Bro, hope you're doing well, and in this video we're going to be copying files in Python, so sit back, relax, and enjoy the show. Welcome back to another video regarding doing stuff with files using Python, and in this video we're going to be copying some files. And in order to do so, I recommend importing the shuttle module. There's other ways of doing this too, but I tend to like using the shuttle module. Now, with this module, there are three basic functions to copy a file. Starting at the top, they are copy file, copy, and copy to. So copy file is what we'll be working with. This will copy the contents of a file. Copy will do everything that copy file does, plus copy the permissions mode, and the destination can be a directory. And lastly, copy to. This will do everything that copy does, plus it copies the metadata of that file, including the file's creation and modification times. So depending on the project or the program you're working with, you may need to use copy or copy to, but in this video, we're going to be using copy file just to copy the contents of a file. Now, after you import the shuttle module, this is all you need to do to copy a file. Shuttle dot, then use the appropriate function that you need to copy your file. We're going to be using copy file. Copy file, and within this function there are two arguments, a source and a destination. So within my project folder I have a plain text file called test.txt. All this says is, yo, this is some text. See ya. What I would like to do is copy this file because it's cool. Now, since this file is within my project folder, I only have to list the file name. Otherwise, if this is someplace else, I would list the file path here. So this file is test.txt. This is the source file, and now I need a destination. So the second argument will be separated with a comma. I'm going to list a destination. So you can actually rename this too. I would like to name this as copy.txt. So the destination is my project folder. So when I create a copy of this file, test.txt, this copy will appear in my project folder and say the same thing. So after running this, we now have a file named copy.txt that says the same thing as my test file. And remember what I said, you can copy this file to a different location on your computer, so you could list the file path. So this file path would go to my desktop, and then when I run this, this will copy my original file, my source, and then copy it to wherever my destination is. Oh, and I almost forgot. So if you need to use copy or copy to, the arguments are exactly the same. So if you needed to use copy, this would be shuttle.copy instead of copy file. Then copy to is shuttle.copy to. The arguments are exactly the same, but each of these functions will copy different things depending on what you need for your own program or project. All right, everybody, so that's the basics of copying files in Python. I will post this in the comment section down below. But yeah, that is how to copy files using Python. Hey, what's going on everybody? It's Bro, hope you're doing well, and in this video I'm going to explain how we can move files using Python, so sit back, relax, and enjoy the show. Welcome back everybody to another video regarding that thing that we do called programming, and in this video we're going to be moving files using Python, and in order to do so I recommend importing the OS module. This is included with the standard Python library. All you need to do is import it. And now let's create two variables. A variable called source that will hold the location of where our source file is located, as well as a variable called destination to function as well, the destination. Now for this video, I'm going to move a file within my project folder to my desktop. So to do so, I'm going to create a new file. I will name this test.txt, but take the liberty to name this whatever you want. So I'm going to list the location of where my test file is located. Since this is within my project folder, I only need the file name. If this was someplace else on your computer, you would probably need the file path. And now, where would I like to move this file to? I would like to move this file to my desktop, so I just need the file path. So I'm going to go to my desktop, right-click, go to Properties. I'm going to copy this location and paste it within my destination. And I will add /desktop/test.txt. You can also rename this too if you want. I will just keep it the same. Now, if you have single backslashes, you'll likely need to change these to double backslashes, because that is the escape sequence to print a backslash within a string. So we have a source location as well as a destination location. Now we can begin. I would recommend writing our code within a try and except block to handle any exceptions. So I would like to handle any file not found error exceptions, just in case our program cannot locate our source file. So let's print a message if that is the case. Perhaps source plus was not found. Now within our try block, let's check to see if there is already a file at this destination, because I would not like to save over it if there's already a file there. So let's do some basic file detection. If os.path.exists, and I will pass in my destination as an argument to the exists function. So if there is already a file here, I should probably let the user know. Print, there is already a file there. Else, we can replace our files. Honestly, if you do not care about saving over any files, you can omit this part. So else os.replace, and we will pass in our source and our destination as arguments. And let's print a message to the console window to let the user know that source plus was moved. All right, let's try this. Oh, I accidentally deleted my file, test.txt. All right, now this should disappear in 3, 2, 1, and it's gone. Test.txt was moved, and it should now be on my desktop, which it is. Now you can also use this to move a directory as well. I'm going to create a new directory. I will name this folder, and I will change source to folder, and the destination from test.txt to folder. And now this should move my folder. There is already a file there. Oh, let's delete that. Okay, folder was moved. All right, everybody, so that is how to move a file and or directory using Python. If you would like a copy of this code, I will post this in the comment section down below. But yeah, that is how to move a file and or directory using Python. Hey, what's going on, everybody? It's Bro, hope you're doing well, and in this video I'm going to teach you guys how we can delete files using Python, so sit back, relax, and enjoy the show. Alright everybody, so in this video we're going to be deleting files using Python, and in order to do so I recommend importing the OS module. This is already included with the standard Python library. All you need to do is import it. And now we need a file to work with, so let's right click on our projects folder and go to new, file. I will name this test.txt, and we now have a file that we can work with. But you know what, I would like to delete this file because it's lame, so let's do that. In order to delete this file, let's type os.remove, and we're going to list the file path here. Since this file is within my project folder, I only need to list the file path, test.txt. If this was someplace else on my computer, I would probably need the file path like that, but since this file is within my project folder, I only need the file name. Another thing that you can do too, at least what I like to do, is that I like to pass in a variable called path. I will make this a variable and assign it a string value of whatever the path to my file is. So I will assign path, the name to my file, test.txt. Now when I run this, this will delete my file test.txt, and you can see that it's no longer there. Now what if we attempt to delete a file that doesn't exist? Well, we'll encounter an exception. So if you want, this is optional, we can do some exception handling. So let's write the remove function within a try block, and we will catch this exception, file not found error. And let's print something. Print that file was not found. Now, if you attempt to delete a file that doesn't exist, your program will not be interrupted, and instead you'll print something, that file was not found. Now, this function does not remove empty folders. This is how to do so. And actually, let's test that. So let's create a new directory. I'll call this empty underscore folder. Now I will attempt to delete this empty folder. Empty folder. We encountered a permission error. Access is denied. So let's create an accept block for that. Accept permission error. Print, I don't know, you do not have permission to delete that. All right, to delete an empty folder, there is a different function, os.rmdir, short for remove directory. We're going to list the file path and pass that in as an argument. And let's create an else block as well because we can. Else, if there are no exceptions, let's print path plus was deleted. All right, so rmdir, remove directory, will delete an empty directory. Empty folder was deleted. Now, this function will not delete a folder that contains files. And let's try that. So let's create a new directory. I'll just call this folder. And within this folder, I will create a new file, test.txt. All right, let's attempt to delete this folder. I will probably need to change the file name. Let's change that to folder. And we encountered an OS error. That directory is not empty. So let's handle this exception. We don't need to, but I like to. Except OS error, print, you cannot delete that using that function. Okay, to delete a folder that contains files, we'll need the shuttle module. Import shuttle, and the function that we're looking for is shuttle.rmTree, short for remove tree, and we will pass in our path. Now be careful with this function, it is considered dangerous because it will delete a directory and all files contained within. So now we can delete a folder that contains files. Folder was deleted. In conclusion, these are three basic functions to delete a file or directory. They are remove, which deletes a file, rmdir, which is an abbreviation for remove directory, which will delete an empty directory, and lastly, rmTree, which is an abbreviation for remove tree, and this is of the shuttle module, and this will delete a directory containing files. So if you would like a copy of all this code, I will post this in the comments section down below. But yeah, that is how to delete files and or directories using Python. Yo, what's going on everybody? It's your bro, hope you're doing well, and in today's video I'm going to be discussing modules in Python, so sit back, relax, and enjoy the show. Alright, well, welcome back. We're talking about modules today. A module is a file containing Python code. It may contain functions, classes, etc. It's used with modular programming, which is this concept of separating a program into useful different parts. We're currently working within our main module, and mine is named Hello YouTube. This is how to create a separate module. Right-click on your project folder, go to New, Python file. I think I'll create a module filled with maybe message functions. So I'll call this Messages, and click Python file. Alright, we have two tabs, one for our main module, mine is called Hello YouTube, and a separate module for Messages. And I can write whatever I want within here, since we're using modular programming. I'll place a bunch of useful functions within this module, and I'll import them to the main module that we're currently working with. Let's define a function called hello. All this will do is print hello. Have a nice day. And I'll create a second function for good measure. Let's call this bye. Let's say bye, have a wonderful time. Now, if we would like access to this module, we need to import it. I will head back to my main module, and at the top, write this. Import, then the name of the module. And for this example, we used the name of Messages for our separate module. And to use a function from that module, type the name of the module, dot, and then the name of the function. So messages.hello will call the hello function found within the messages module. And I can also call the bye function as well. Messages.bye, and that will print bye, have a wonderful time. Now, it can be somewhat tedious to have to write the name of the module followed by the function name. What we could do to shorten things up is to give our messages module an alias, also known as a nickname. So at the top, write import messages as, and what sort of nickname should we give messages? Let's say MSG for short. So we'll replace messages with MSG. MSG hello, and MSG bye, and this would work the same, and it involves less typing. There's also an additional way of importing a module, and it goes a little something like this. From the name of the module, import, and then list all of the functions or classes you would like to import. I would like to import hello, comma, bye. And we no longer need the module name before calling one of these functions. I can simply just call hello and bye directly. Another way in which this could be written is from messages, import asterisk. That means to import all, and I actually would not recommend using this if you're working on a large program or something that contains many modules, because you can run into a naming conflict, because some of these modules may have the same named function names or variables. So if you're working on a small program, I really don't think it's a big deal, but if you have multiple modules, I would actually refrain from using import all. It's much safer to write the name of the module followed by the name of the function that you want to use. Now, another cool thing is that Python has a bunch of pre-written modules that you have access to. If you would like a comprehensive list of them, type help and pass in the word modules. And within my console window, this will populate a listing of all the modules available to us. Here they are. Let's see if math is in here. Yep, there it is. So yeah, feel free to take a look through some of these modules because there's some fairly useful tools within some of these modules. I suppose you can also go to Python's official documentation and search for the Python module index, and here's a listing of all the different modules too that you have access to. Well everyone, those are modules. They are files containing Python code, and they may contain functions, classes, etc. If you would like a copy of all this code, I will post all of this to the comment section down below. But yeah, those are modules in Python. I guess there's a module called Pickle. Hey, what's going on everybody? It's Bro, hope you're doing well, and in this video we're going to be creating a basic game of rock, paper, scissors in Python, so sit back, relax, and enjoy the show. Let's begin by importing the random module, because we're going to need the computer to pick a random choice. And we'll create a list of possible choices. So we have 3 strings within here: rock, paper, and scissors. I think I spelled scissors wrong. There we go. Okay, and we will have our computer pick a random dot choice from our list of choices. And let's test it by printing whatever the computer picks. So the computer picked paper, paper, scissors, and scissors. Okay, what about the player choice? Let's say player equals input rock, paper, or scissors. And let's print what the player has. Print player. And let's print the computer too. Maybe I'll add a string before these. So let's say computer, colon space, whatever the computer chooses. And the same thing with the player. Player. Alright, let's see if this works. Rock, paper, or scissors. Let's say rock. The computer picks paper and I pick rock, so I would technically lose this round. Now, what if the player doesn't pick rock, paper, or scissors? What if they type in gun? So we would like some way to prevent that. So let's put our input for our player within a while loop. While player not in choices. So we're going to need to initialize player because right now it's an unresolved reference. So let's say player equals none for the time being. Okay, now let's test our choices, our player choices. Rock, paper, or scissors. I pick the gun. And it's going to keep on asking me until I pick something from my list of choices. So if I type in that, still won't accept it. Now let's type in rock again. There we go. Now, what if somebody types in one of these choices, either all caps or capitalized? Well, that technically wouldn't be in choices because these strings are case sensitive. So why don't we take our user input and make it lowercase? And I'll just add on dot lower and use the lower method. So therefore, we can now type in any input that is either all caps or uppercase, and then that will still be accepted because we're going to take our player input and then make it lowercase so that it matches one of these choices. Okay, let's work on the win conditions next. So first, let's check to see if we encountered a tie. If player is equal to computer, that means that we both chose the same thing. So let's print whatever the computer picked, what we picked, and we will print tie. Now let's write an else if statement. ELIF player equals rock. So if we pick rock, and then we will create a nested if statement. If computer equals paper, that means we lose. So let's print everything we have here, except we're going to change tie to you lose. Now if the computer picks, let's say scissors, then we win. So scissors, and you win. Okay, then let's just repeat this process for scissors and paper. So this will be another else if statement. If we pick scissors and the computer picks rock, then we lose. If the computer picks paper, then you win. And lastly, we have paper as the player choice. So, else if player equals paper and the computer picks scissors, then we lose. If the computer picks rock, well then paper covers rock and we win. Now let's test it. Rock, paper, or scissors. Again, I'll try and pick the gun, which I can't. Let's take this seriously. I will pick rock. The computer picked rock, so it's a tie. I'm feeling like paper today. Oh, it's another tie, I guess. And how about scissors? Okay, so I win this round. I picked scissors, and the computer picked paper, therefore I win. Let's try and lose this time, just to verify it. So I won again. Let's try rock again. Okay, so I lost that round. So we know that the win conditions are working now. How about we add a feature where we will ask the player if they would like to play again, play another round. I think the best way to do that would be to write all of this code within a while loop. So at the top, let's write while true. And we'll need to indent everything so that it's within the while loop. So let's just indent everything here. Now at the bottom, we will ask the user if they would like to play again, and I will store this within a variable named play again. Play again equals input, and the prompt will be play again. Yes/no. And depending on their input, let's just make it all lowercase. If play again does not equal yes, that means they would like to quit. So let's use a break statement to break out of our while loop that we're in. And at the end, let's print bye. And pay attention to the indentation. This input and this if statement should be within the while loop, so they should have at least one indentation. And our print statement here will just say bye. And you can see that there is no indentation, so that is outside of the while loop. Okay, let's test this one last time. Rock, paper, or scissors. I'm going to pick the cannon. Okay, that's not valid input. How about rock? Okay, the computer picks rock. I pick rock, so it's a tie. Do I want to play again? I'm going to select, actually, yes, all caps. That should still be acceptable. How about paper this time? It's a tie again. Man, the computer's really good at this game. I'd like to play again. I'll pick scissors. Okay, so I lose. I would like to play again. And I want to win this time. Okay, computer picks scissors. I pick rock. You win. Do you want to play again? Nah. And it will print bye. Well, everybody, that's a simple game of rock, paper, scissors. I'll post all of this code to the comment section down below. And well, yeah, that's a basic game of rock, paper, scissors in Python. Hey, what's going on everybody? It's your bro, hope you're doing well. And in this video I'm going to show you guys how we can build a basic quiz game in Python. So sit back, relax, and enjoy the show. To begin this project, I think it would be wise for us to create a skeletal structure for how this program is going to operate, and then we'll fill in the gaps later as we go along. So to begin, let's define all of the functions that we'll need. We'll need 4. We'll create a function that is named newGame. Whenever we call this function, it will create a new quiz game for us. And for the time being, let's write pass just as a placeholder. We'll have a total of 4 functions. newGame, a function to check our answer, a function to display our score, and lastly, a function to play again. All right. Now I'm just going to add some comments here just to separate each of these functions that we have, just so that it's a little bit easier to read, although this part is not really necessary. So I just want to separate each of these functions for some readability. Okay, those are all the functions that we'll need. What we'll need now is some sort of collection to hold all of the questions and answers that we have, and I think a dictionary would be perfect for this. So what I did is that I created a dictionary named questions. A dictionary has key value pairs. Each key is a question that I would like to ask, and each question has an associated value. We'll have the user guess between answers of A, B, C, or D. So these would be all of the correct answers, all of the values within this dictionary. So here are some of the questions that I want to ask. Feel free to come up with your own questions. If you would like, you can copy the questions that I have. They should be posted in the comment section down below. So the questions that I'm going to ask are, who created Python? What year was Python created? Python is attributed to which comedy group? And lastly, is the Earth round? I couldn't think of a 4th question, so I just threw in a random stupid question. And the correct answers to all of these questions in order would be A, B, C, and A. But feel free to come up with your own. Well, we have our questions, but we'll need some sort of collection to hold all of the different possible answers to each of these questions. And I think a 2D list would work perfect for this. So I have a list of lists. A list of tuples could work too, I suppose. So here are all of the answers for the first question. And the correct answer is A. I believe his name is Guido van Rossum. Hey, if you're listening, man, I'm sorry if I'm mispronouncing your name. I'm really trying here. The second list corresponds to the second question. What year was Python created? It was created in 1991, at least according to Wikipedia. Python is attributed to which comedy group? The answer is C, Monty Python, like Monty Python and the Holy Grail. Good movie, by the way. And lastly, is the Earth round? This is a highly debated topic, but the answer is A. The Earth is in fact round. So I have a list of lists. Each list corresponds to a key value pair within my dictionary of questions. And this is a lot to type. If you want, you can just copy the code that I posted in the comments down below. Just copy and paste it and you'll have all of this. Or if you want, you can pause the video and type it. I don't care. So now that you have your questions and your options, we're ready to begin. So the first thing that we'll do within our program is to call the newGame function to begin a new game. So after we have our questions and options created, let's create a new game by calling the newGame function. Now, when we run this program, we'll generate our dictionary of questions and our 2D list of different options for each question, and then we will call the newGame function to begin a new game. So let's head to the newGame function and fill in everything within our newGame function. So at the top, let's declare a few things. Let's say we have a list named guesses, and guesses will be an empty list for now. I will declare a variable called correct guesses, set it equal to 0 because we haven't guessed anything yet, and we will set a current question number and set this equal to 1 to represent the first question. Okay, now we need to display all of the questions within our dictionary of questions, and we can use a for loop for that. So for key in questions, I'm going to print my key. And let's just test this. Okay, yeah, here's all my questions. I think what I'll do is actually print something to separate each question. Let's say one of these lines. I think it would look better with them. Okay, I'll print this line, and then we'll move on to a question. Alright, now after rerunning this, we have each question, and I added just a line break between each of these to make it look kind of fancy. Now, I need to display all of the different options for each question, and we can do that with a nested for loop. So if I were to write for I in options, print I, let me show you what happens. Now, with the way this for loop is written now, it's going to display all of the different options available to us for the entire quiz game. What I would like instead is to display only the first list for the first question, and then the second list for the second question, and follow that pattern. So we're going to change our for loop around. For I in options, and we'll set an index for options. The index is going to be our question number, -1. Now, remember what I said in previous videos where different collections, including lists, tuples, etc., the first element in a collection has an index of 0 because computers always start with 0. Then the next element would therefore have an index of 1, then 2, 3, then you follow that pattern. We're using this question number variable as some sort of counter, and since we initially set this to 1, I'm just going to subtract 1 so that we effectively receive 0 as the index. And now we just need to increment our question number after each iteration. So let's do that. I will add that to the end here after we finish displaying all of the options. Let's increment question number by 1 by typing question num plus equals 1. And if I were to run this currently, we'll display all of the different options for each question. Who created Python? Here's all of the associated options. What year was Python created? Python is attributed to which comedy group? And lastly, is the Earth round? Now it's time for some user input, so I'm going to create a variable called guess. And make sure you don't put it within your inner for loop, it should be within the outer for loop. Guess equals input, and I'll create a prompt. Enter A, B, C, or D. Here's something to consider. We would like the user to type in either capital A, B, C, or D. With strings, they're case sensitive. What if the user typed in one of these letters but lowercase? If they're correct, we would still like to give them their point. Why don't we take our guess and make it uppercase? So guess equals guess, and we can make this uppercase using the upper method of strings. At the end of this game, I'm going to compare our guesses to the correct answers. So we have an empty list named guesses, and I'm going to append our current guess that we're working on to our list of guesses. So guesses dot append, and we will append our guess this round. Now that we have our guess and we've appended our guess to our list of guesses, let's check to see if it's the correct answer or not. So we're just about to fill in this check answer function next. So we are going to call this function and pass in a few items as arguments. So let's use the check answer function, and we'll pass in the key for the current question that we're on. So the key is the correct answer. So that would be our questions dot get key. This would be the answer, and we'll also pass in our guess. And we are going to fill in the check answer function, but we need to set up the parameters. We're receiving effectively our answer as well as our guess. So I'm going to name these as answer and guess. And we are going to check to see if our answer is equal to our guess. If answer is equal to guess, let's print something. Print correct. And I think we should give the user a point. We'll have our check answer function return 1 for 1 point. Return 1. Else, if this is not the correct answer, let's print wrong, and we will return 0. They do not get a point. And since this is returning a value, we should assign that. So let's assign the point we may or may not receive to our variable of correct guesses, which is initially set to 0. So we'll type correct guesses plus equals check answer, and check answer will return 1 if we scored a point or 0 if we did not score a point. And make sure you have plus equals, because if you just set this to equals, then we cannot score more than 1 point. It will either be 0 or 1. So we are effectively incrementing our correct guesses by 1 for each point that we score. And now we're going to work on the display score function, and we'll call that at the end after we finish all of our questions that we have. So make sure that you do not write this within the for loop. It should be outside of it, because once we finish iterating through all of our questions, we're going to display a final score. So let's call the display score function, and we'll need to pass in some arguments, our correct guesses, as well as our list of guesses. Okay, let's head to the display score function. So we have, as parameters, correct guesses, as well as guesses. I need to remove this pass. I'm going to add one of these fancy lines in just to separate the questions from the results. And I will print results. And maybe another one of these lines. Okay, so I need to print all of the answers. Answers. And I do not want to end on a new line, so I'm going to set end equal to nothing. And I need to display all of the values within our dictionary, all of the answers. I will do that using a for loop. For I in questions, print questions dot get I, and I do not want to end on a new line, so I'm going to set end equal to nothing effectively. And then I'll print a new line. Okay, let's work on the guesses. I think I'm just going to copy all of this and make some changes. I'll replace answers with guesses. For I in guesses, print I. Okay, let's just be sure that everything's working. We're not calculating a score quite yet. So I'm just going to answer A, then B, C, and D. On second thought, after printing each of these answers and guesses, I'm going to add a space after each of these. So within each of these for loops, at the end, I will add a space. Let me try that again. A, B, C, D. Okay, not too bad. Now let's calculate the final score. And we're still within our display score function. Let's set score equal to correct guesses divided by the length of our questions. And let me add a set of parentheses around here. Then I'm going to multiply our score by 100. And if you don't want a decimal portion, because we'll display a percentage, we can cast this as an int. Okay, that all looks good. And we'll print the final score. Print your score is plus, we need to cast our score to a string because we're using string concatenation, plus I'll add a %sign. Alright, let's try it. I'm intentionally going to get the last question wrong, so we should have a 75% if we have 4 questions. So that would be A, B, C. Is the Earth round? What's Earth? I'm gonna guess D. Answers A, B, C, A. Your guess is A, B, C, D. Your score is 75%. Okay, let's test it, but getting all wrong answers. D, 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 D. Your score is 0%. Congratulations. And we'll test it one more time, but get all the right answers. We just want to be sure that we have 100%. That's A, B, C, A. Your score is 100%. Now, the last thing that you can add is that we can play again if we want, and I have a separate function for that. If you would like to add this option, here's how to do so. Let's remove that pass. Let's set a variable named response equal to some input. Do you want to play again? Let's ask for yes or no. Actually, let me remove that. Okay. And depending on the user's response, it might be lowercase, so let's make it uppercase. Response equals response, and use the upper method. If response is equal to yes, all caps, if response is equal to yes, then return true. Else, we will return false. And that is it for this function. The last thing we need to do is to create a while loop that will continue to ask the player if they want to play again. This will be after we call the new game function. While play again, and remember this will return either true or false, depending on the user's response. While play again, new game, and call the new game function to create a new game for us. If we escape the while loop, that means the user doesn't want to play again, so let's print a message. Such as, bye. Alright, let's test it. I'm going to get all of the correct answers this time. A, B, C, A. Alright, your score is 100%. Do you want to play again? I'm going to type yes. Alright, then we can play again. D, 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 D. Your score is 0%. Do you want to play again? No, I think I mastered this game. Bye. Alright everybody, so that's how you can use Python to create a simple quiz game. I will post all of this code to the comment section down below. But, well, yeah, that's a basic quiz game in Python for you all. Hey, what's going on everybody? It's Bro, hope you're doing well, and in this video I'm going to explain object-oriented programming in Python, so sit back, relax, and enjoy the show. Welcome to today's topic on Python object-oriented programming, also known as POOP, and in today's video we're going to be creating objects. An object is an instance of a class. By using programming, we can create representations of real-life objects. So look around you wherever you're sitting or standing right now. You are surrounded by objects. Next to me I have a phone, a television, some snacks, and I'm talking into a microphone. Point being, we can use programming to mimic real-world objects by assigning a combination of attributes, what an object is or has, and methods, what an object can do. Now, in order to create an object, we'll need to create a class. A class can function as a blueprint that will describe what attributes and methods that our distinct type of object will have. You can either create your class within your main module, or you could create a separate file dedicated solely for your class. Now, to create a class, we would type class and then the name of the object that we would like to create. So today I would like to create some car objects because I like cars. So we would type car. And a common naming convention with class names is that they should be capital. So car is going to have a capital C. And for the time being, we need to type in something. I'll just type in pass as a placeholder. So if you have a small program, it may be better to write your class within your main module. But if your class is fairly large, you may want to consider placing your class within a separate module. So if you were to take that route, we would go to File, New, Python file, and we would name this car, click Python file, and we would declare our class within the separate module. So class, car, and for now, I'll type in pass. Then we just need to import this class. So within our main module, we would type from the name of the module, import the name of the class. From car, import car. Now, objects can have some combination of attributes and methods. Attributes describe what an object is or has. So what are a few attributes that cars might have? They might have a make, so let's create a few variables. For the time being, I'm just going to use none as a placeholder. Cars can have a model, a year, and a color. Now, objects can also have methods. What kinds of methods could cars perform? Perhaps a drive method and a stop method. So let's define those. DEF, let's say drive, and we'll have one argument, self. Self refers to the object that is using this method. Now, what do we want to do when we call this method? Let's say this car is driving. Let's create a stop method as well. def stop, and we will print this car is stopped. We now have all of the different attributes and methods we would like our car objects to have, but there is one more thing that we need. It is a special method called the init method that will construct objects for us. In other programming languages, this is known as the constructor. So we need a special method that will create objects for us. So we need to define this method, def, and the syntax on this is somewhat strange. It is 2 underscores, init. It's short for initialize, 2 underscores again, and then we need at least self as an argument. And then we can actually assign our car objects unique variables. So take all of these attributes that we have, and we're going to place them within this init method. Now we can receive arguments when we create car objects, but we need to pass them in as arguments to our init method. So we need to set up some parameters. Let's say in order to create a car object, we need a make, a model, a year, and a color. Then when we receive these arguments, we can actually assign them to each car's specific attributes, but we need to precede each of these with self. Self is referring to the object that we're currently working on or creating. So self.make, self.model, self.year, and self.color. And then when we assign these, we're going to say self.make equals whatever make that we receive when it's passed in as an argument, self.model equals model, and continue that pattern for year and color. All right, that is all we need for our class car. We have a constructor. We're assigning arguments that we receive to the attributes of our car object, and we also have 2 methods, one for drive and one for stop. Now we can start creating some car objects. So going back to my main file here, to create an object, we need a unique name for it. Let's call this first car just car1 equals the name of the class, car, then a set of parentheses. Now, in order to construct a car object, we need to pass in a matching set of arguments. You can see here that we need to pass in a make, a model, a year, and a color. So what kind of car should we make? Let's say that the make is going to be Chevy. We need a model, perhaps Corvette. A year, 2021 is good. And a color, let's say blue. All right, now let's actually access some of these cars' attributes. And I should probably put this within a print statement. So print car1's make, and this should print Chevy. Then we can do the same thing for model, year, and color. So let's change some of these around. Model, year, and color. Yep, this object is a Chevy Corvette 2021, and the color is blue. And we should have 2 methods as well. So car1, I would like this car to use its drive method. This car is driving, and let's have this car use its stop method. Car1 dot stop. This car is stopped. There's one thing that I should mention real quick because I forgot to mention it earlier. So within our init method, you can see that we need 5 arguments in order to construct a car object: self, make, model, year, and color. But when we pass in our arguments, we're not passing in anything for self. We only have 4 arguments here. That's because with Python, we do not need to pass in self. That's done automatically for us. We're referring to the object that we're dealing with. As you can see with our drive and stop method, we need to pass in self in order to execute our method. But when we call this method, we do not need to do so. So just remember with Python, with self, we do not need to pass in anything for this argument. That is all. Now, the nice thing about this is that we can reuse this class as a blueprint to create more car objects. We just call that init method that constructor. So this time, let's create a second car called car2. And this will be a different kind of car. What kinds of arguments should we pass in? Let's say this is a Ford Mustang. The year will be 2022, and the color will be red. All right, let's check car2's attributes. And let's have car2 use its drive and stop method. This is a Ford Mustang. The year is 2022. The color is red. This car is driving, and this car is stopped. One other thing that we can do too is that within our methods here, let's replace car with the name of the model that we're working with. So this plus self.model plus is driving. Now this self keyword, think of it as you're replacing self with the name of the object that we're working on. If car1 is using its drive method, replace self with car1. If this is car2 that called this method, then replace self with car2. Think of it that way. And let's do the same thing for stop. This plus self.model plus is stopped. All right, probably don't need these anymore. So let's have car1 use its drive and stop method. This Corvette is driving, this Corvette is stopped. Let's try this with car2. This Mustang is driving, this Mustang is stopped. Now you can have them do things independently too. Let's have car1 use its drive method and car2 use its stop method. This Corvette is driving and this Mustang is stopped. In conclusion, a class can function as a blueprint to create objects. We can assign attributes, what describe an object is or has, and methods, what each object can do. And then within our class, we have a special method called the init method. We can pass in some arguments and assign these arguments to each object's attributes. And then we can reuse this class as if it was a blueprint, so we can create more objects out of it. So that is the basics of object-oriented programming in Python. If you would like a copy of all this code, I will post this in the comment section down below. But yeah, that's the basics of object-oriented programming in Python. Hey, what's going on everybody? It's your bro. Hope you're doing well. And in this video, I'm going to explain the basics of class variables in Python. So sit back, relax, and enjoy the show. Here's a super quick video on the differences between class and instance variables. For this example, let's say we have two car objects named car1 and car2, and I'm just passing in a bunch of values to each of these car constructors. Now within my class car, I have my init method, also known as the constructor, and what I'm doing is assigning all of these values to the variables found within my car constructor. These variables declared inside of the constructor are known as instance variables, and each object can have their own unique values assigned to each of these variables. Now, where a class variable is different is that a class variable is declared inside the class, but outside of the constructor. And what we can do is set some default values for some variables. Let's say we would like to add an additional variable. Let's say wheels. Wheels equals, and we can set a default value for all instances of this class for each car object that we create. So we set wheels to equal 4. This is an example of a class variable. Whenever we create a car object, we can pass in a unique make, model, year, and color. But by default, they will all have 4 wheels. Now, if I was to print the amount of wheels that car1 and car2 have, they will both have 4 wheels. It's as if we're setting a default value. If I change this to 2 wheels, well then these cars have 2 wheels. Maybe they're motorcycles or something. Now you can actually change these values. Each object will have their own copy of this variable, but you can set it to a default value. So let's say car1 is a motorcycle. Car1.wheels equals 2. So if I were to print car1's wheels along with car2, car1 will have 2 wheels, but car2 is still using that default amount of wheels, which is 4. Now, there's another way in which you can access a class variable. You don't necessarily need to create an object to do so. You can just use the name of the class. So what I'm going to do is turn all of these lines into comments, and I will print the amount of wheels that our class has. So type in the name of the class, car with a capital C. It should be the same name as your class name, followed by the name of the class variable, car.wheels. But make sure you spell it right. Alright, so this will display 4 wheels. Now, what if we decide to change the class variable through our class? Well, that will affect all instances of our class. So let's say car.wheels equals 2. It's as if we change our mind and we have decided to create motorcycles instead of cars. Well, if we were to change the wheels class variable through the use of our car class, well then it's going to affect it for all instances of this class. You can see that both car1 and car2 now have 2 wheels. When we just changed car1's wheels, it did not affect car2 at all. So that's the main difference between a class variable and an instance variable. An instance variable is declared inside of a constructor, and they can be given unique values. With class variables, they are declared within a class, but outside of the constructor, and you can set a default value for all instances of this class, for all unique objects that are created, and then you can change those values later too. So if you would like a copy of all this code, I will post all of this in the comment section down below. But yeah, that is the basics of class variables in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain inheritance in Python, so sit back, relax, and enjoy the show. Let's talk about inheritance. The term inherit means to receive, derive, or be left with, and we can apply this concept to programming. Classes can inherit something, usually attributes and methods, from another class. These classes can form parent-child relationships, where a child will receive everything that the parent class has, much like you inherit genes from your parents, and classes can have children and give whatever they own to their children. And in today's video, we'll be creating a parent class called animal, and children of the animal class will inherit the common attributes and methods that all animals might have. To kick off this video, I think what we'll do is keep all of our classes within the same file, just so that it's easier for us to read and understand. Let's begin by creating a class called animal. So at the top, type class animal. And what are some attributes and methods that all animals should have? Let's say we have a class variable called alive, and we'll set this to true. If you're an animal, you begin by being alive. And what are some methods? How about an eat and sleep method? So let's define those. DEF, eat. What are we going to do when we call this method? Let's print something. Let's print this animal is eating. Let's also create a sleep method. DEF, sleep. What are we going to do when we call this method? Let's print something as well. This animal is sleeping. And we now have our animal class. Now let's create separate classes for specific types of animals. Let's say a class for rabbit, a fish, and a hawk, so we can make objects of those classes. So let's begin with a rabbit class. Class, rabbit. Now to use inheritance, with the class that you intend to be the child class, after the class name, add a set of parentheses, and then pass in the name of the parent class. In this case, it's going to be animal. So we will add that to the parentheses. So now rabbit is the child class and animal is the parent class. So the child class is going to inherit everything that the animal class has. So for the time being, I'm going to type pass. So this rabbit class will have access to a class variable called alive and an eat and sleep method. So let's define a fish and hawk class. And I'm just going to copy what I have here and just change rabbit to fish, and then do so again and change rabbit to hawk. This is our family tree. Animal is the parent class, and it has 3 children, a rabbit class, a fish class, and a hawk class. And for the time being, we're just going to write pass as a placeholder. So I bet we can create objects from these classes. So let's do so. Let's say we have an object called rabbit. Rabbit equals rabbit. Let's do the same thing for fish and hawk. All right, we now have 3 objects, rabbit, fish, and hawk. And let's take a look at their class variables. I bet they have an alive variable. Let's check that. So I would like to print rabbit dot, oh, would you look at that? This rabbit class has a class variable called alive, even though there's nothing within this class. Well, that's because we used inheritance. So each of these 3 children classes inherit everything from their parents, all of these attributes and methods. I bet they have eat and sleep functions as well, so let's check that. With fish, let's have fish use its eat method, and hawk will use its sleep method, hawk.sleep. So the rabbit is alive, the fish is eating, and the hawk is sleeping. Now, even though we have nothing written within each of these specific types of animal classes, all of these animals have access to these attributes and methods because of inheritance. And another benefit of inheritance is that we don't need to keep on copying and pasting this code. For example, let's say we were not using inheritance, so we would not need an animal class. We could write our code this way, where we would just copy and paste everything underneath each of our classes. So what if we need to make a change to one of these methods, as in your boss says, you know what, let's change sleep to slumber, okay? Well, we would have to go to each of these classes and make the change manually. It's not too bad if you have like 3 classes, but what if you have hundreds? That's going to take a lot of effort. So wouldn't it be nice if we just list everything that each of these classes has in common, and then have all of these classes inherit from one common class. And then if you need to make any changes, you can do so just within this class. And this change will apply to all of the different child classes. So that's another benefit of inheritance. And not only does it make any changes easier, but each class can have their own unique attributes and methods as well, along with the attributes and methods that they inherit from their parents. So for rabbit, fish, and hawk, let's have each of these classes have their own unique method as well. So for rabbit, let's define a run method. If you're a rabbit, then you can run. So let's print this rabbit is running. And I'm just going to fix some of the spacing here. All right, if you're a fish, then you can swim. DEF, swim. Let's print this fish is swimming. And lastly, we have hawk. If you're a hawk, then you can fly. DEF, fly. Let's print this hawk is flying. Like I said before, not only do these specific types of animals have access to all of the attributes and methods that they inherit from their parents, but they can have their own attributes and methods as well. So let's test some of these methods. So we have our rabbit, fish, and hawk objects. Let's have rabbit use its run method. Fish will use its swim method. And hawk will use its fly method. And here we go. This rabbit is running, this fish is swimming, and this hawk is flying. So in conclusion, classes can have children. The children classes will inherit everything that their parent class has, all of the parent's attributes and methods. But not only that, the children classes can implement their own unique attributes and methods as well. So that is inheritance. If you would like a copy of this code, I will post all of this in the comment section down below. But yeah, that's the basics of inheritance using Python. Yo, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain how multi-level inheritance works in Python, so sit back, relax, and enjoy the show. Alright, welcome back everybody. Let's talk about multi-level inheritance. This is a concept where a derived class, also known as a child class, inherits from another derived class. Here's an example. Let's say we have a hierarchy of classes. There will be 3 levels to this. We'll create a family tree of living organisms. So at the very top, we're going to have a class called organism. Any class that inherits from the organism parent class will receive one attribute, one variable named alive, and this will be set to true. So if you are an organism, you begin by being alive. Now let's say we have a child class that will inherit from the organism parent class. Let's say animal. Class animal inherits from organism. So any animal that we create will have this alive attribute set to true. And all animals eat, so let's define a function that does that. At least I believe all animals eat. Let's pretend that they do. So this animal is eating. And now, why stop there? Let's create a class for a specific type of animal. I like dogs, so let's create a dog class. Class dog inherits from the animal class. And all dogs should be able to bark, so let's create a function to do that. And we'll print this dog is barking. Okay, so what we just did here is multi-level inheritance. We had a derived child class inherit from another child class. So it's kind of like this dog class is the child, animal class is the parent, and then the parent of the parent class would be like a grandparent, right? And then if you added another layer on top of that to this hierarchy, well then the parent of the grandparent would be like a great-grandparent. That's how I think of it at least. Now let's create a dog object just to verify that everything's working. So let's call our dog, dog, and our dog object should have access to an attribute named alive. And our dog object receives that attribute from the organism class. And this will print true if I were to print whatever this attribute contains. And our dog should be able to eat because it receives this method from the animal parent class. And lastly, our dog should be able to bark, and that method is defined within its own class. So that's how multi-level inheritance works. It's a concept where a child class will inherit from another child class. I like to think of it like a family tree, where a child class will have a parent, and the parent of that parent would be like a grandparent basically. So if you would like a copy of this code, I will post all of this to the comment section down below. But yeah, that is how multi-level inheritance works in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to show you all how multiple inheritance works in Python, so sit back, relax, and enjoy the show. Alright people, multiple inheritance. Multiple inheritance is the concept where a child class is derived from more than one parent class. Here's an example. Let's say that all of our children classes are going to be certain types of animals, and we would like our animal classes to inherit from either the prey parent class, the predator parent class, or both depending on what type of animal it is, because some animals in the animal kingdom can be both prey and predators. And one example that comes to mind would be fish. Fish will eat smaller fish, but also can get eaten by larger fish. So here we have two classes, prey and predator. Each has a dedicated method. If a class inherits from the prey parent class, they will have access to a flee method, which will print this animal flees. If a class inherits from the predator parent class, that class will have access to a hunt method that will print this animal is hunting. And it's possible that some animals can do both. They can both flee and hunt, but they'll need to inherit both of these classes, both prey and predator. And that's where multiple inheritance comes in. Now let's create some classes based on certain types of animals. Let's say we have class rabbit, and rabbit will inherit from the prey class because rabbits are typically prey and not predators. But I don't know, there could be some killer rabbits out there. Haven't run into any yet. Let's have class hawk inherit from the predator class. And lastly, fish. And fish can be both prey and predators, so they will inherit from both classes, and we just separate each class with a comma. So prey, comma, predator. And it's as simple as that. Now let's create an object from each of these classes. We have rabbit equals rabbit, hawk equals hawk, and fish equals fish. Now let's just verify all of the different methods that each of these objects inherited. So our rabbit should have access to a flee method, but no hunt method. And let's just test that. Yep, this animal flees. And my hawk object should have access to a hunt method, but no flee method. This animal is hunting. And lastly, my fish object has access to both a flee and a hunt method. And if you take a look on the right-hand side of this pop-up window, it shows the class that it inherited this method from. So flee comes from the parent class of prey, and hunt comes from the parent class of predator. So my fish can both flee and hunt, because it's typically considered both prey and predators. This animal flees, this animal is hunting. So that's basically what multiple inheritance is. It's a concept where a child class is derived from more than one parent class. So that's basically multiple inheritance. I'll post all of this code to the comment section down below, and well, yeah, that's how multiple inheritance works in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys about method overriding in Python, so sit back, relax, and enjoy the show. Here's a super quick video on method overriding. I have two classes, a class called animal and a class called rabbit. Rabbit inherits from the animal class, therefore rabbit is the child class and animal is the parent class. Within the animal class, there is one method, a method called eat, and when you call this method, all this will do is print this animal is eating. The rabbit class inherits from the animal class, therefore rabbit has access to this eat method. And if I were to create a rabbit object and this rabbit used its eat method, well then this is going to print this animal is eating. Now method overriding is the ability of an object-oriented programming language to allow a subclass, also known as a child class, to provide a specific implementation of a method that is already provided by one of its parents. In this case, we're going to override the eat method, and what we can do is provide a more specific implementation for the rabbit class. And now to override a method, what we'll do is that within the child class, we need to define a method with the same matching method signature. That is the combination of a method's name plus its parameters. Both of these together are known as a method signature. Within the child class, we will define an eat method with the same parameters, def, eat, and in this case, the only parameter is self, just to keep this simple. And what we'll do is that we'll provide a more specific implementation of the eat method specifically for rabbits. So let's print something more closely associated with rabbits, such as this rabbit is eating a carrot. Now, if I were to run this program again, we will instead use this implementation of the eat method instead of the one that it inherits from its parent class of animal. Basically speaking, an object will use a method that is more closely associated with itself first before relying on a method that it may inherit from a parent class. In this example, we're using this version of the eat method specifically for rabbits instead of the version that we inherit from the parent class of animal. That is the basics of method overriding. I will post this code in the comment section down below. And well, yeah, that's how to override a method using Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys all about method chaining in Python, so sit back, relax, and enjoy the show. Alright everybody, let's talk about method chaining. Method chaining is used to call multiple methods sequentially, and each call performs an action on the same object and returns self. Here's an example of how method chaining would be useful. Let's say we have a class named car. Car has 4 methods: turn on, drive, brake, and turn off. They will all just print a simple message beginning with turn on. Turn on will print, you start the engine. Drive will print, you drive the car. Brake will print, you step on the brakes. And turn off will print, you turn off the engine. Let's say we have a car object. Car equals car. And I would like my car object to use its turn on method immediately followed by the drive method. With how we've been coding things previously, we may write something such as the name of the object, in this case car, dot, and then the method to use. I would like my car to use the turn on method, followed by car dot drive. So currently this will take 2 lines of code, but this will print you start the engine and you drive the car. Now with method chaining, we can call multiple methods sequentially. Now the format on this is going to be a little bit different. And if we were to write the same code using method chaining, it might look a little something like this. After the first method call, we would add dot, and then an additional method that we would like to call. So for example, after the turn on method, we'll immediately call the drive method. But there's one more thing that we need to add when we're using Python to do method chaining. So normally this by itself will not work. When we call a method in Python, if there is nothing that is returned, Python will return none. So as you can see here, attribute error, none type object has no attribute of drive. So we need to return self under each method that we're using method chaining with. So let's add return self to each of these methods. So let's do that for drive, brake, and the turn off method. And this should work now. You start the engine, you drive the car. So think of it like this. After we finish calling this method, Python is going to return self. So it's going to return car. So then we'll immediately use car.drive. Now here's another example. Let's say I would like to call the brake method followed by the turn off method. So that would be car.brake, parentheses, followed by dot turn off. So this will print, you step on the brakes, you turn off the engine. Now here's an extreme example. Let's say we would like to call all 4 methods in order. So that would be car dot turn on, followed by dot drive, dot brake, dot turn off. So this will call all 4 methods in order, starting with the leftmost method. You start the engine, you drive the car, you step on the brakes, you turn off the engine. Now, if you have one long method chain like this, it might become difficult to read after a while. So what I would recommend if you're doing a lot of method chaining is that after each method call, just hit enter to move each method call down to a new line. So it'll look something like that. And this backslash might be inserted. This is a line continuation character. So this is a little more readable, but it still does the same thing basically. All right, everybody, so that is method chaining. It's used to call multiple methods sequentially, and each call performs an action on the same object and returns self. If you would like a copy of this code, I will post all of this in the comments section down below. But yeah, that is how to do a method chaining in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain the super function in Python, so sit back, relax, and enjoy the show. Well then, since you clicked on this video, I should probably discuss the super function. Now, the super function is used to give access to the methods of a parent class. It returns a temporary object of a parent class when used. Here's an example of why the super function would be useful. Let's take this program that I've written. There's three classes, a class called rectangle, which is the parent class to two children classes, square and cube. And all we're doing is creating a square object and a cube object, but we need to pass in a length and a width for squares, and a length, width, and height for cubes. Now with programming, we don't like to repeat code, we like to reuse code, and if you take a look within my init methods for both square and cube, we're repeating self.length equals length and self.width equals width twice for our init methods. So one thing that we can do, any similarities between the square and cube class, we can place within the rectangle class and then reuse this code. So what I'm going to do is copy this init method within our square class and paste it within our rectangle parent class. And then in order to access this init method, we can use the super function. So we no longer need these two lines of code. What I'm going to do is ask the rectangle class to use its init method. So we're going to type super parentheses dot and then the name or the function of the parent class that we would like to use. And I would like to use the init method, but I need to send a length and a width because it requires that. So let's send these. So we're going to pass in our length and our width. And now we can do the same thing for our cube init method. So I will copy this line of code. We no longer need these two lines of code because we will be reusing our init method within the parent class of rectangle, but we'll still need to keep this line in to assign the height because that's a difference between our square and cube class. And now we can just reuse this init method within the rectangle parent class. Now I'm thinking that we should probably test to see if length and width are assigned to these attributes, and one way that I think would be fun would be to create an area method for squares and a volume method for cubes. So let's define an area method within the square class, def area, and I would like to return self.length times self.width. And we can create a volume method within cubes. So let's do that. Def, let's change this to volume. We'll multiply length times width times height. But we need to type self.height. And we can call these methods to get the area of a square or the volume of a cube. Let's print square dot area and then cube dot volume. So if our init method is actually being used, we should have a length and the width assigned to these attributes. And it looks like we do. In conclusion, the super function is used to give access to the methods of a parent class. It returns a temporary object of a parent class when used in order to access the methods of the parent class, also known as a superclass. And in this example, within the init methods of both square and cube, we immediately called the init method of the parent class to pass in some arguments that both of these classes have in common. So if you would like a copy of this code, I will post all of this in the comment section down below. But yeah, that is how the super function works in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain how abstract classes work in Python, so sit back, relax, and enjoy the show. Hey, what's good everybody? Let's talk about abstract classes. Now, abstract classes prevent a user from creating an object of that class. Think of an abstract class more as a template. It's an idea, it's not real. It's like a ghost class, basically. Plus, an abstract class compels a user to override any abstract methods within a child class. So it's also a form of checks and balances as well, which we'll discuss later. Now, here's a small program that I've written. Let's say we have three classes, class vehicle, car, and motorcycle. Car and motorcycle are the children classes of the vehicle class. Now, within this vehicle class, we have a go method, but I'm currently only defining it, not actually implementing it, so I'm just writing pass. Now, within car and motorcycle, we're overriding this method and creating our own implementation of this go method that we inherit. The go method for the car will print, you drive the car, and the go method for the motorcycle class will print, you ride the motorcycle. Now currently, I'm creating an object of each of these classes. I have a generic vehicle object, car object, and motorcycle object. Now, after running this program, currently the go method within our vehicle class is not being implemented, so this won't print anything, but the go method within our car class will print you drive the car, and the go method within our motorcycle class will print you ride the motorcycle. With that being said, let's pretend that we're coding the next Need for Speed game, and we would like a user to create an object from a specific kind of vehicle, whether it's a car from the car class or a motorcycle from the motorcycle class. We would like to prevent a user from creating an object of the vehicle class because the vehicle class is too generic. We do not have all of the implementations set up for a vehicle. It would be like somebody unlocked the ghost car or the invisible car, which doesn't actually exist and is missing a lot of features. We need a user to create an object from a child class because these are fully fleshed out. And one way in which we can prevent a user from creating an object of this class is, well, to turn this class into an abstract class, which is what this video is all about. Go figure. Now, the first step to creating an abstract class is that we'll need some imports. So at the top of your program, write this: from ABC. ABC is an acronym for Abstract Base Class. ABC. From ABC, import ABC, all capital, comma, abstract method. All right, now with our vehicle class, the class that you intend to be the abstract class, add a set of parentheses, and our vehicle class will inherit from the ABC class. And now with any methods within your vehicle class, you're going to add this decorator at the top, at abstract method. All right, we should now be prevented from creating a vehicle object. Our vehicle class is now an abstract class, and we cannot give it a physical form, a physical manifestation. And if we attempt to, you can see here that we have a type error. Can't instantiate abstract class from vehicle with abstract methods go. So an abstract class is a class which contains one or more abstract methods. And an abstract method is a method that has a declaration but does not have an implementation. Now, by definition, an abstract class contains one or more abstract methods. If I remove this one abstract method within our vehicle class, well, we could still create a vehicle object. And I'm just going to turn this vehicle.go line into a comment because we don't have a go method anymore. As you can see, we can still create a vehicle object, which we would like to prevent a user from doing. So we need at least one abstract method within our vehicle class. So I'm going to go ahead and add this go method back in. An additional feature of abstract classes is that they compel a user to override any abstract methods within a child class. A method that is abstract has a declaration but does not have an implementation. So let's say that we create our vehicle class, our abstract vehicle class, and now we're creating the children classes of car and motorcycle. And let's say I'm not paying attention and I forget to add a go method. So if I just write pass within my motorcycle class, I'm currently missing a go method within my motorcycle class. Well, Python is going to prevent me from running this because we have a type error. Can't instantiate abstract class vehicle with abstract methods of go. So by inheriting from an abstract class, it's a good form of checks and balances to be sure that your children classes are not missing any implementations of any methods that they inherit. Here's an additional way of thinking of this. Our vehicle class is telling its children, if you're going to inherit from me, then you need to override this abstract method of mine, and if you don't, well, I'm not going to let you be instantiated. So, in order for us to create a car and motorcycle class, we need to override the go method that they inherit from its parent class of vehicle and provide its own implementation. Now let's say we create an additional method. Let's say we have a stop method. So let's define that. def stop. For the time being, I'll write pass, and to make this an abstract method, add this decorator, at abstract method. Now, car and motorcycle both need to implement that method of stop. It's currently missing it. As you can see here, class car must implement all abstract methods, and the same thing applies for motorcycle as well. So we need to override this method and provide its own implementation. So let's remove that decorator, and let's print something. Let's print this car is stopped. And I'll do the same thing for motorcycle. So def stop. Let's say this motorcycle is stopped. and we'll call the stop method for each of these types of vehicles, car.stop and motorcycle.stop. All right, and we can now create a car and motorcycle object because we are overriding both of these abstract methods found within the parent class of vehicle. All right, everybody, so that's the basics of abstract classes. It's a class which contains one or more abstract methods, and an abstract method is a method that has a declaration but does not have an implementation. And the benefits of using an abstract class is that they prevent a user from creating an object of that class. Plus, it compels a user to override any abstract methods found within a child class. So, if you would like a copy of this code, I will post all of this in the comments section down below. But yeah, that is how abstract classes work in Python. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video I'm going to explain how we can pass objects as arguments. So sit back, relax, and enjoy the show. Ladies and gentlemen, in today's video I'm going to be demonstrating how we can pass objects as arguments. For this example, let's say we have a class car, and there is one class variable called color. Color equals none. What we'll be doing is calling a function that accepts an object as an argument as well as a color. So let's create a function named changeColor. Now make sure when you define this function it's not within the car class, then technically this would be a method of the car class. What we would like is a separate function outside of the car class. Now we need to set up some parameters. We would like to accept a car object as well as a color. So for the first parameter, let's say car, and make sure this is in uppercase or capital because Python doesn't like that. Argument names should be lowercase. So when we pass in a car, we will give it a nickname of car. And we would also like to pass in a color. So let's set up a parameter called color. Now when we pass in a car, we will assign that car's color with whatever color that we receive. So car.color equals color. And now let's create some car objects. So let's say car1 equals car, car2 equals car, and car3 equals car. Currently, if I were to print their colors, this is what we'll see. Print car1.color and repeat the steps for 2 and 3. And we're not calling this function yet, so all of these colors should be set to none. They are basically cars with no color. They're, I don't know, iron or something. Whatever cars are made out of, aluminum, plastic, stuff like that. Okay, so now let's call this function changeColor, perhaps right here. So in order to call this function, we need to pass in a car object as well as a color. So let's pass in car1 and a color, perhaps red. And we'll repeat the steps for 2 and 3. So let's say car2 will be white and car3 will be blue. Now after calling this function, we have a car object and a color, and we're assigning the color of our car to whatever color that we receive. Now, these cars, in order, car 1, 2, and 3, are red, white, and blue. Now, one thing that you should know is that the name of this parameter that accepts our object doesn't necessarily need the same name as the class name that created the object that we're passing in. We could name this something else entirely, perhaps vehicle. You'll just want to be sure that this is at least descriptive of the kind of object that you would like to pass in. And we're not limited to just passing in car objects. We can pass in all sorts of objects, but we need to pass in an object as well as a color. So this time, let's create a class called motorcycle. Class motorcycle. And this class will also have a color set to none. So what we're doing is actually reusing this function for all sorts of different kinds of vehicles. Now let's create a vehicle. I'll just name this bike1 for short. Bike1 equals motorcycle. Now let's call the changeColor function, and we can pass in an object as well as color. This time, we will pass in our bike object as well as a color. I think black counts as a color. And let's print bike1's color. And this should work. We have red, white, blue, and black. In conclusion, we can pass objects as arguments to a function, much like what we've been doing with variables. However, the type of objects that we pass in may be limited based on the required attributes and methods that that given class or object might have, and we'll get more into this on the next video on duck typing. So if you would like a copy of all of this code, I will post all of this in the comments section down below. But yeah, that is how to pass objects as arguments using Python. Hey, what's going on everybody? It's bro, hope you're doing well, and in this video I'm going to explain duck typing in Python, so sit back, relax, and enjoy the show. I hope you all like ducks because that's the topic of this video. Duck typing is the concept where the class of an object is less important than the methods and or attributes that that class might have. The class type is not checked if the minimum methods and or attributes are present. It's based off of a popular phrase, if it walks like a duck and it quacks like a duck, then it must be a duck. Here's an example. I have two classes, class duck and class chicken. Both duck and chicken have walk and talk methods, but they print something different. With the duck class, the walk method will print, this duck is walking, and the duck talk method will print, this duck is quacking. The chicken class has the same named methods, walk and talk, but they print something slightly different, a slightly different variation. The print method will print, this chicken is walking, and the talk method will print, this chicken is clucking. Now let's say we have a third class, a class called person. Now there is one method within our person class. Let's say we're attempting to catch a duck. We'll pass in self, and we need to pass in a duck object as an argument. So let's type duck. Now within this method, we'll have our duck use its walk method as well as its talk method, duck.walk and duck.talk. And then maybe we'll print something such as, you caught the critter. Now let's create an object from each of these classes. Let's create a duck object. Duck equals duck. A chicken object, chicken equals chicken, and lastly person. Person equals person. Now, if we would like our person to use the catch method, we need to pass in a duck as an argument. So with our person, let's type person.catch, and we need to send a duck object because that's a required parameter here. So we're passing in our duck object that we created, and as soon as we catch the duck, it's going to use its walk and talk method, and then we'll print, you caught the critter. So as you would expect, this will print, this duck is walking, this duck is quacking, you caught the critter. Now, with duck typing, we can pass in a different type of object as long as it has the same methods and or attributes as our duck. We could pass in a chicken because a chicken can also walk and talk. So this time, let's pass in our chicken as an argument. And this will still work even though our parameter is set up to take a duck object. This chicken is walking, this chicken is clucking, you caught the critter. In layman's terms, think of it like this. Python is examining this chicken object, it's using its walk method, it's using its talk method, which are required, and Python is saying, well, that's close enough. Remember, if it walks like a duck and it quacks like a duck, then it must be a duck. So duck typing is the concept where the class of an object is less important than the methods and or attributes that it might have. The class type is not checked if the minimum methods and or attributes are present. Now let's say with our chicken object, our chicken can no longer walk. Well, we cannot pass in our chicken object anymore. We have an attribute error. Chicken object has no attribute walk. So Python took a look at this chicken and noticed that it does not have a walk method. Well, it's not walking like a duck, but it's talking like a duck, so it doesn't count as a duck because it doesn't have its walk method. In conclusion, the class type of an object is not as important as the methods and or attributes that that class might have when using duck typing. The class type will not be checked if the minimum methods and or attributes are present. Since chickens can both walk and talk like ducks, then they can be a substitute for ducks when we pass in our duck object to this method. So if you would like a copy of this code, I will post all of this in the comment section down below. But yeah, that is the basics of duck typing in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to discuss the walrus operator in Python, so sit back, relax, and enjoy the show. Alright people, I hope you like walruses, because that's the topic of this video. We'll be discussing the walrus operator, also known as an assignment expression. It's a colon followed by an equal sign, and it kind of looks like a walrus on its side. Now this is a new feature for Python 3.8. What it does is that it assigns values to variables as part of a larger expression. Here's an example of why the walrus operator would be useful. Let's say we have a variable named happy. Happy equals true. If you're not happy or you're feeling so-so, you can set this to false if you want. So let's print the value contained within happy. So this will print true to the console window. Now, wouldn't it be cool if we could combine both of these statements together? So we would want to say something such as happy equals true, and then print it to the console window using one line of code. Well, normally we can't do this using the standard assignment operator. Now, one thing that we can do is use the walrus operator. This assigns a value to a variable as part of a larger expression. So this would technically be allowed if this assignment operator was instead an assignment expression. The walrus operator, happy, walrus, true. And when they're all within a print statement, we can assign a value to a variable and use it as a part of a larger expression. So as you can see, this new variable of happy was assigned and used in one expression. Now here's a more practical example of why the walrus operator would be useful. Let's say we have this small program. What this will do is consistently ask you what food do you like and put it into a list called foods. Foods equals list, while true, food equals input. What food do you like? If food equals quit, break, then append our list of foods with this new food item that we have. Okay, let's run this then. So this while loop will continue as long as I don't type in quit, and it will consistently ask me what food do I like and place that food item into a list named foods. So let's begin. What food do I like? Well, I do like pizza, I like sushi, and I like ice cream. And that should be enough for me. I'm going to type in quit to exit this program. Now let's write the same program, but instead use a walrus operator so that we can write this program using less lines of code. Now, if I were to use the walrus operator, this is how I would write the same program. We would still need our list. Foods equals list. Now for my while loop, it's going to look something like this. While, food, walrus operator, input, what food do you like? Alright, this is the assignment portion. Now we can use this assignment portion within a larger expression. So let's also check to see if our input does not equal quit. Alright, so then after each iteration of this while loop, we will take our list foods dot append food. And that is it. So we have written the same program in about half the lines of code that we did previously. So let's test it. What food do you like? Pizza, sushi, ice cream, and quit. Well, everybody, that is the basics of the walrus operator, also known as an assignment expression. It's a new feature for Python 3.8 and beyond, so if this doesn't work for you, I would check to see what version of Python you're using first. It assigns values to variables as part of a larger expression. If you would like a copy of this code, I will post all of this in the comment section down below. But yeah, that is how the walrus operator works in Python. Hello, what's going on everybody? It's Bro, hope you're doing well. And in this video, I'm going to show you guys how we can assign a function to a variable in Python. So sit back, relax, and enjoy the show. Hey all, in today's video I will show you all how we can assign a function to a variable. This video will be a prerequisite for a few videos I have coming up regarding functions. Now let's say we have a function named hello, and all we'll do is print the word hello. And as you know, to call this function you would type the name of the function followed by a set of parentheses, and this will print the word hello. The set of parentheses that comes after a function's name is the portion that will call the function. If you were to remove that set of parentheses afterwards, we would not in fact call that function. Now with Python, Python will pretty much treat everything as objects, including functions. So there's something I want to show you guys. If I was to print the name of my function hello, what will be displayed is the memory address of this function. This is the memory address of where this function is located within my computer's memory, and it's in hexadecimal. Think of it like a street address, such as 123 Fake Street. This is the address of where this function is within my computer's memory. And each time that I run this program, this number can change, as you can see here. Now, one thing that we could do, we could assign this address to a variable. Let's say hi equals hello, and be sure that you're not adding that set of parentheses afterwards, because then you would be calling the hello function and returning the result to hi. So hi equals hello, no parentheses. And if I was to print hi, well, the address of hello and hi will be at the same memory address. Both of these numbers are the same. Now, what do you imagine would happen if I was to call the hi function after we assign the memory address of hello to hi? Well, then what we'll end up doing is calling the hello function, even though we're listing that we would like to call the hi function, even though it doesn't exist. So it's as if this hello function has two names. You can either use hello or you can use hi. And let me demonstrate that. So you can call either hello, hi, or both for this example. That's because we're assigning the memory address of hello to this variable of hi. So we could treat hi as a function. It's kind of like an alias where this function has two names. Now here's another demonstration. Let's say that we would like to assign our built-in print function to a variable. So let's say, maybe say equals print. And when I say print, I'm referring to the print function. And be sure you're not adding that set of parentheses afterwards. Now, if I need to print something to the console window, I can either use print, like what we've previously been doing, or I could use say, because say has the same memory address. Let's say, perhaps, whoa, I can't believe this works. Surprised face. All right, so we can call the print function by saying the word say. Say all of this text. And this will print all of this text, well, say all of this text to the console window. Under normal circumstances, I'm not sure why or when you would need to assign the print function to a variable, but you can, and well, that's kind of cool, so I thought I'd show you guys that. So everybody, that's how to assign a function to a variable. Like I said, we'll be building upon this topic, so you want to be sure that you understand this. Alright then, well, if you would like a copy of this code, I will post all of this to the comments section down below, but yeah, that's how to assign a function to a variable in Python. Hey, what's going on everybody? It's Bro, hope you're doing well, and in today's video I'm going to explain higher order functions in Python, so sit back, relax, and enjoy the show. Alright, ladies and gentlemen, let's talk about higher order functions. These are functions that do one of two things. One, they either accept a function as an argument, or two, they return a function as output. And in Python, this is totally allowed because functions are also treated as objects. I'll give you guys an example of both of these, but let's begin with number one. Here's an example of number one. Let's say that I have two functions named loud and quiet. Both of these functions will accept a string as an argument. Loud will return that string all uppercase, as if we're shouting something. Quiet will return that text all lowercase, as if we're whispering something. Now I'm going to create a third function called hello. And this will be the higher order function. It accepts a function as an argument. I'm not sure if we're going to be passing in loud or quiet. Whatever it is, I'm going to give it a name of func, short for function. Each of these functions will return some text, either all uppercase or lowercase. I'm going to assign that to text. Text equals the name of our function. We're not sure what it's going to be, and I will pass in some text in order to call one of these functions. I will pass in just the word hello, that's capitalized. And at the end, I will print whatever text that we have. In order to call this function of hello, I need to pass in a function as an argument. Do I want to pass in loud or quiet? Do I want the loud variety of hello, where all of the text will be uppercase, or the quiet variety of hello, where all the text will be lowercase? I would like to pass in loud because I want to make my text all uppercase. So I'm typing the name of the higher order function and passing in a function as an argument. And the result is that the word hello will be printed to the console window all uppercase. Now here's a rundown of what just happened. We're calling the hello function and we're passing in loud as an argument. We're naming loud as func while we're within this hello function. Text equals loud, and we're sending a string of text that says hello. We're returning that text all uppercase, assigning it to a variable called text, and printing that text to the console window. Now, if I would like to use the quiet variety of hello, then I'm going to pass in quiet as an argument. So quiet will make all of this text lowercase. Alright people, so that's example one of a higher order function. A higher order function is a function that accepts a function as an argument. This hello function is an example of a higher order function because we're accepting either loud or quiet as arguments. All right, people, let's move on to the second part of this definition for higher order functions. A higher order function is a function that returns a function. I'm going to give a different example this time. Let's say we have a pair of nested functions. The outer function will be named divisor, and we will accept a number as an argument that we will call x. A divisor is a number that is used to divide another number when using division. And inside this function, we have an inner function named dividend. Dividend is the number that's going to be divided, and we will call the argument that is passed in y. All we'll do is return y divided by x. We're dividing the dividend by the divisor, y divided by x. Now, within the outer function, but not within the inner function, we're going to return our dividend function. So a higher order function is a function that returns a function. Divisor is a higher order function because we're returning dividend. Now, if I would like to access this nested dividend function, I first need to call the outside divisor function and pass in a number as an argument to serve as the divisor. The divisor function is going to return my dividend function, which we can then assign to a variable. So the variable I'm going to name divide. Divide equals, and I need to call divisor and set a divisor. Let's say that I would like to divide all numbers by 2. So I will set x to be 2. And now, for the dividend, I will print, call the divide variable, and pass in a number as the dividend, the number that's going to be divided. And let's say I would like to divide 10 by 2. And this will work. As you can see, we have 5 in the console window. So let me explain what just happened here. So our program begins here. Divisor, and we're passing in 2. X will be 2, and it will stay that way until we finish this program or until we reassign x. Now, x equals 2. We're skipping this function because we did not call it yet. We're returning dividend and assigning it to a variable, and we can call a variable if it has the memory address of a function, which is what we're doing in this line. Now we're calling dividend and passing in 10. So y equals 10 and x still equals 2. We're returning 10 divided by 2 and printing it to the console window. Well, everyone, in conclusion, a higher order function is a function that either 1. Accepts a function as an argument, or 2. They return a function. The format is a little bit strange and we're not quite used to it yet, but in future videos we'll have more practice with higher order functions. If you would like a copy of all this code, I will post all of this to the comment section down below. But yeah, that is how higher order functions work in Python. Yo, what's going on, everybody? It's your bro, hope you're doing well. In today's video, I'm going to explain Lambda functions in Python, so sit back, relax, and enjoy the show. Alright, ladies and gentlemen, let's talk about Lambda functions. These are functions that are written in one line and use this Lambda keyword. They accept any number of arguments, but they only have one expression. Think of it as a shortcut. They're useful if you need a function for only one use or a short period of time, and then you're just planning on throwing away that function afterwards. Here's the syntax for a Lambda function. You type lambda, you add the parameters, followed by a colon, and then your expression. Let's say we have this function named double. Double accepts one argument that we will name x. We're returning x times 2, effectively doubling it. So if I need to call this function, I would type double, and then pass in a number as an argument. So the result, if I pass in 5, would be 10. Now let's write the same function, but instead write it as a lambda function. So let me turn these lines into comments. Now the first step is to type lambda, then our parameters. We only have one parameter, and that is x, colon, and then our expression. We would like to return x times 2. Now this lambda function is going to return a function object, and we can assign that much like what we do with variables. Let's say double equals lambda x colon x times 2. And in order to call this lambda function, we're going to type double, then a set of parentheses to call this function, and then pass in our arguments. So let's say that x equals 5, and then we're going to double it, and the result is 10. So that's the syntax for a lambda function. You type lambda, your parameters, colon, and then your expression. This time, let's say that we have two parameters. We have two numbers that we want to multiply by each other. So let's say that this function will be called multiply. Multiply equals lambda x comma y, because we have two parameters, colon, followed by our expression. we would like to multiply x times y, and that is it. Now in order to call multiply, we need to pass in 2 arguments. If I were to pass in just 1, well, we'll have a type error. So let's pass in 5 and maybe 6. And the result is 30. Now let's try 3 parameters. Let's say we would like to add 3 numbers together. Let's say add lambda x, comma y, comma z. So we have all of our parameters. We have our colon here, and then we need our expression x plus y plus z. And let's add 5, 6, and 7 together. The result is 18. Now let's try something a little more complex. Let's pass in some strings this time. I'll create a function named fullName. FullName equals lambda, first name, comma, last name. The expression is going to be first name plus perhaps a space plus last name. Now I need to pass in a first name and a last name. Full name, and you can use your own name for this example if you want. Let's say bro, comma, code. Yep, this will print your first name and your last name to the console window. Now let's take it a step further. Let's say we would like to check somebody's age once using a lambda function. We would like to check to see if they're 18 or older because they're signing up for something perhaps. Let's say a credit card. So let's create a function object, age check equals lambda. We have 1 parameter, somebody's age, colon, and then our expression. Let's type true if age is greater than or equal to 18, else false. To call this age check function, we need to pass in an age. Let's say the user is 12 and they're trying to sign up for a credit card. Well, this will return false. Let's say they're 18 now, and this will return true. So that's a lambda function. It's a function that is written in 1 line using this lambda keyword. They accept any number of arguments, but they only have 1 expression. Think of it like a shortcut, and they're useful if you need to use a function only once and then you're just planning on throwing it away afterwards. So if you would like a copy of all this code, I will post all of this to the comment section down below. But yeah, those are lambda functions in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to show you all how we can sort iterables in Python, so sit back, relax, and enjoy the show. Well, welcome back everybody. In this video I'm going to show you all how we can sort data using Python. We'll begin with the sort method, which is used with lists, and the sort function, which is used with iterables, and that would include lists. Let's start with something very basic, and then we'll crank up the difficulty 1 step at a time. I have a list named students, and I have a bunch of student names within this list. We have Squidward, Sandy, Patrick, SpongeBob, and Mr. Krabs. Let's say that all of these students are taking a college course, perhaps on marine biology. What I would like to do is to sort this list in alphabetical order, and to do that, we have a method that is built in with lists. So type the name of your list, students, dot, sort. And it's easy as that. And to display this list, I think I'll use a for loop. For I in students, print I. And there you go. That's how to sort a list. Starting with the top, we have Mr. Krabs, then Patrick, Sandy, SpongeBob, and Squidward. The sort method of lists can accept keyword arguments. There are 2 optional keyword arguments that we can pass in. We can pass in key and or reverse. We'll cover key a little bit later. If we set reverse to true, then our list will be sorted by reverse alphabetical order, beginning with Squidward, SpongeBob, Sandy, Patrick, then Mr. Krabs. Now, the sort method does not work with other iterables. It's a built-in method for lists. If our list of students was instead, let's say, a tuple, well then the sort method is not going to work. You can see here that we have an attribute error. Tuple object has no attribute of sort. That's where the sort function would come in because that's useful for other iterables. You can also use this for a list too, I suppose. The sort function will return a sorted list. So let's use the sort function this time, and we'll assign the result to a list called sorted students equals sorted, and then we need to pass in an iterable, and we have the option of passing in a key and or reverse. The iterable that we'll pass in as an argument is our tuple named students. So this line will be sorted students equals sorted students. Sorted students is a list. The sorted function will return a list, but it accepts an iterable as an argument. And to display this, we should change for I in students to for I in sorted students. And now this function will accept our iterable, our tuple, and create a sorted list. And all of these are in alphabetical order. And to reverse this, we can pass in the keyword argument of reverse equals true. And now our list is sorted in reverse alphabetical order. All right, we're going to take it up a level. Welcome to level 2. Sometimes data isn't always as simple. Here we have a list of tuples. Each tuple has a corresponding student record. We have a name, a letter grade for their college course, and the student's age. Now, how can we sort this list of tuples by either the student's name, their grade, or their age? Well, that's where the keyword argument is going to come in with sorting. If you take a look at this list of tuples, it somewhat resembles a spreadsheet. There's rows and then there's columns. The first column corresponds to student names, the second column are grades, and the third column are all the ages of the students. So by default, sorting by the first column is actually really easy. That's the default. So if we need to sort alphabetically, that would be the same process as before. We would type the name of the list, students, dot sort. But if we were to print this iterable for I in students, instead of just the individual student names, we're going to get each tuple that we have. So now all of these tuples are arranged in alphabetical order, starting with the first column that we have, which are all the student names. Now, how can we sort these iterables by their second column? For this case, it would be student grades, or even the third column, which would be the student ages. Well, that's where the keyword argument is going to come in. This is a keyword argument, and we set key equal to a function that's going to return the index of that specific column that we have. So let's say key equals grade. Grade is going to be a function object. Grade equals, and we can easily use a lambda expression for this. Lambda, let's say grades, colon, grades, and we will set an index of 1. Now the first index is 0. That's the first column because computers always start with 0. Column 2 would have an index of 1, and then column 3 would have an index of 2. So grade equals lambda grades, colon, grades, index 1. You can also rename these if you want. So students.sort, we're setting the key equal to grade, and grade is a function object via a lambda function. And now all of these students will be sorted by their grades, starting with Sandy, then SpongeBob, Mr. Krabs, Patrick, then Squidward. If this needs to be in reverse order, we can pass in that other keyword argument of reverse equals true. And for practice, if you wanted to sort all of this data by each student's age, then we would change grade to, let's say, age. Age equals lambda. We'll change grades to maybe ages, colon, ages, and the index would then be 2, because the first column here is 0, then 1, then 2, and change key to our function object of age. Now each student is sorted numerically, beginning with the smallest age, well, the youngest person, starting with SpongeBob, Sandy, Patrick, Squidward, then Mr. Krabs. And like I said before, if you want your data arranged in reverse order, you can set that keyword argument of reverse to true within the sort method. And all of our student data is sorted beginning with the eldest student, which is Mr. Krabs, then Squidward, Patrick, Sandy, and then SpongeBob. And for the last part of this video, let's say that we're working with some other iterable. Let's say we have a tuple of tuples instead. Well, we can no longer use this sort method because that only belongs to lists. You can also use the sort function with lists, and it will generate a new sorted list without changing the placement of the original. So let's say we have a tuple of tuples, and this will create a new sorted list. Let's call this list sorted students equals, then we'll use the sorted function. We need to pass in an iterable, and we can pass in both a key and or the reverse keyword argument. So the iterable would be students, and let's set the key equal to age. And I will not reverse it. We can keep it as it is. But let's change for I in students to sorted students. And that's how to use the sorted function to sort an iterable, including a list. Well, alright everyone, that's how to sort iterables in Python. If you would like a copy of all this code, I will post all of this to the comments section down below. But yeah, that's a basic way to sort iterables in Python. Hey, what's going on everybody? It's your bro, hope you're doing well. In today's video, I'm going to show you all how the map function works in Python. So sit back, relax, and enjoy the show. What up everybody? Let's discuss the map function. The map function will apply a function to each item in an iterable. That would include lists, tuples, things like that. And the map function accepts two arguments, our iterable as well as the function we would like to apply to each item within our iterable. For example, let's say that we have an online store. To represent this, I have a list of tuples named store. Each tuple within this list corresponds to an item for sale within our store. There's shirts, pants, jackets, and socks, and each item has a price in US dollars, let's say. Now what I would like to do is to convert all of the prices within my store to euros, and currently the conversion rate as of the filming of this video is $1 to 0.82 euros. So let's begin. We can easily convert dollars to euros with a lambda function. So let's say 2 euros equals lambda, the parameter will be data, colon, and the next part's a little bit tricky. Within a set of parentheses, to represent a tuple, we'll take data at index 0, that corresponds to the first column, comma, data at index 1. This represents the index of our prices. We're going to take data at index 1 times 0.82, and that's it. The first column will be left untouched, but the data in column 1 will be multiplied by 0.82. Now our map function is going to create a map object, but we can easily cast that to a different type of iterable. So let's say that store underscore euros equals map parentheses, and then we can pass in our function as well as our iterable. Our function is our 2 euros function, comma, and our iterable is our store. And that is it. Now, if you want to convert this map object to an iterable, you can easily surround this with a cast. I would like to convert this map object to a list, and we will now have a new store named store euros, which will have all of the different prices of our store in euros. And to display this, I'll use a for loop. For I in store euros, print I. And let's try it. Yep, that seems about right. All of the prices in our store are now in euros. Let's pretend that these prices are already in euros and we would like to convert these to American dollars. So we will use the same conversion rate but divide by 0.82. So let's create a separate lambda function. $2 equals, I think I'll just copy this. But we are going to divide the first index of data by 0.82. And let's say store dollars to represent our store in dollars because we're pretending now that it's currently in euros. And we will display for I in store dollars. So if all of these prices are in euros, we are now converting them to American dollars. But you may want to do some rounding, I suppose, to the nearest cent. Well everyone, that is the map function. It applies a function to each item in an iterable. Those include lists, tuples, the like. You pass in your iterable and your function as an argument to the map function. So if you would like a copy of all this code, I will post all of this to the comment section down below. But yeah, that is how the map function works in Python. Yo, what's going on everybody? It's your bro, hope you're doing well, and in today's video I'm going to show you all how the filter function works in Python. So sit back, relax, and enjoy the show. Alright, let's discuss the filter function. The filter function creates a collection of elements from an iterable for which a function returns true. Now what the heck does that mean? Let me explain. Let's say that we have a list of tuples named friends. Each tuple has the name of a friend as well as their age. I just made up some ages for all of these friends. What I would like to do is to create a separate list for all the friends that are 18 or older. So let's say that we're all going out drinking and I would like to create a list of my drinking buddies because they're of drinking age. I'm in the United States and the drinking age is currently 21, but I think worldwide it's 18, so let's go with 18 for this example since I have a worldwide audience. All right, now with this filter function, we have to pass in our iterable as well as a function to get anybody's age that is over 18. So let's begin by writing a lambda function for this expression here, our filter function. So let's say age equals lambda, data will be the parameter, colon, data at index 1. So the first index, the first column in this chart here would be 0 for all the names. The next index of 1 would be all the ages. Data at index 1 is greater than or equal to 18. And that is it. That is our lambda function. And now we're going to filter our iterable by this function of age. So let's write filter, pass in our function, which is age, comma, and our iterable of friends. Now this filter function will return a filter object. You can easily cast this. I would like to cast my friends list back into a list. And I will assign this to a new list. Let's say drinking buddies equals list, filter, age, and friends. And I should be able to print all of the friends that are 18 or older for I in drinking buddies. Print I. And we have Rachel, Monica, Chandler, and Ross. Well, everyone, that is the filter function. It creates a collection of elements from an iterable for which a function returns true. I like to think of it as the search results. We're searching for any results that meet this criteria, where age is greater than or equal to 18. And then you can create a separate collection or other list if you want from the results. But yeah, that is how the filter function works in Python. Yo, what's going on everybody? It's your bro, hope you're doing well, and in today's video I'm going to show you how the reduce function works in Python, so sit back, relax, and enjoy the show. Well, I suppose we're on the reduce function today. The reduce function applies a function of our choosing to an iterable, and reduces that iterable to a single cumulative value. The way this works is that the reduce function performs our function on the first two elements of our iterable, and repeats the process until only one value remains. I kind of like to think of it like we're recycling elements within an iterable until a single value remains, our finished product. So how is this useful? Let's say that we're playing a game of Scrabble and we have a bunch of different letters within an iterable. A list is a type of iterable. So I have a list named letters and we have all of the letters we need to spell a word. What I would like to do is to reduce all of these individual elements into a single cumulative value until only one value remains. So we can do that using the reduce function. You can also do this with the for loop too. There's multiple ways of doing this. So using the reduce function, we're going to import functools. And now let's say we have our cumulative value stored within a variable named word. Word equals functools dot reduce. Now the reduce function has two arguments. The function we would like to apply to the first two elements and then our iterable. The iterable is easy, that is just letters. So let's put that in, letters. And for the function, we can easily write a lambda function for this. Lambda, and now this function needs two parameters. Let's say x and y. Now what kind of function do we want to perform on the first two elements of our iterable? Let's combine them together. So let's say x plus y. And now let's print our single cumulative value of word. So this should print the word hello. I'm fairly confident that the word hello is worth like 20 points in Scrabble. Now let me explain what happened step by step. Our reduce function applies our function to the first two elements within our iterable. It performs this expression that we set, x plus y, but really we can write anything here. So we perform this expression on the first two elements. Then we repeat the process again using the result from the first time we use this expression and the next element. So we're combining x plus y again. And then we're just going to repeat this process until only one value remains. It's kind of like we're recycling all of these letters and creating a finished product out of all of these. That's how I think of it, at least. Here's a different example. Let's say that I would like to find the factorial of 5. So I have the numbers 5 through 1 within a list named factorial. So if I was to find the factorial of 5 via the reduce function, I would probably write something like this. So let me change word to, let's say, result. Result equals functools, reduce. Now our lambda function will be x times y, because with factorials we multiply the next two numbers together, then we take that result and then multiply the next one in this list. So the iterable will be factorial, and let's print what our result is. So the factorial of 5 should be 120. Now let's walk through this. We're taking the first two elements of this iterable, 5 and 4, multiplying together in this case. In the last example, we concatenated the strings together of x and y. In this example, we're multiplying them together. So we take the first two elements, 5 times 4, we take the result and apply it to the next iteration of x times y again. So 20 times 3 is 60. We repeat this process again. 60 times 2 is 120, and 120 times 1 is 120. So that's kind of how the reduce function works. It applies a function of our choosing to the first two elements of an iterable and repeats that process until only a single cumulative value remains. So that is the reduce function. If you would like a copy of all of this code, I will post all of this to the comment section down below. But yeah, that is how the reduce function works in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to show you all how list comprehensions work in Python, so sit back, relax, and enjoy the show. Alright everybody, so list comprehensions. A list comprehension is a way to create a new list with less syntax. You can also use a list comprehension to mimic certain lambda functions, such as in the previous videos where we used the map and the filter functions. And not only that, but a list comprehension is easier to read than a lambda function. But there is a formula that we're going to follow. When we create our list, within our list, we're going to write an expression for item in iterable. Now let me give you an example of where a list comprehension would be useful. Let's take this program that will create a list of all the numbers 1 through 10 squared. So if I were to print this, we'll get the numbers 1 through 10, whatever their square is, right? So we have 1 through 10, and the square of 10 is 100. So we wrote this program in 3 lines of code. We're creating an empty list, we're creating a for loop, and then we're writing an expression for what we want each loop iteration to do. Now let's write the same program but used a list comprehension, and we can write the same program with less syntax. So I would write something like this, and we're going to follow this formula. So our list is going to be named squares equals, then within a set of straight brackets, we're going to write our expression, which is this portion, I times I, for item, so that would be for I, in our iterable, that would be range 1 through 11, because remember 11's exclusive. And then let's print our squares. Print squares. And there you go. We made the exact same program using a list comprehension. So basically speaking, you just follow this formula. You set your list equal to your expression, and our expression for this example is I times I, for item, for I, in your iterable, in range 1 through 11. So this took 3 lines of code, well if you exclude us printing our list, and this program took 1 line of code. Now we can also use a list comprehension to mimic certain lambda functions. I wrote a program where we will be filtering a list of student grades. Let's pretend that all of these students took some sort of exam. So we have one student that received a 100%, 90, 80, 70, 60, 50, 40, 30, and then one student got a 0 because they didn't show up. So what I would like to do is to filter all of these student grades into a list that only contains students that passed. And the criteria for a passing grade will be a 60% or above. So I would like to filter all passing students. And if I was to write this program using the filter function, I would probably write something like this. So I need a function and then my list that I'm working with. Lambda x colon x is greater than or equal to 60. We'll filter all of the results and then convert it to a list named past students. So the result will look something like this. I have 5 student grades in here with 100%, 90, 80, 70, and 60. Now let's write the same program using a list comprehension. Now there's just one portion to this formula for our list comprehension that we're going to add. At the end, we're going to add if conditional. We can check some sort of condition after each iteration. So let's write the same program using a list comprehension following this new updated formula that we have. So we need our list, which will be named past students equals, first comes our expression, and it's just I for this example, for item I in our iterable of students, and then if we can check our conditional, if I is greater than or equal to 60. And this will have the same effect as our previous program, but instead it uses a list comprehension. Now, if your program has multiple output, if you need an else statement within your conditional, you're actually going to move this portion of the if conditional within our formula to right after the expression. So let's write an if else statement here. So let's say that instead of just excluding any student that didn't pass, we'll replace their grade with the word failed, and we can do that using an if else statement. So let's do this again. I'm going to copy what we have here, paste it, and we'll move our conditional from the end to just after the expression portion. If I is greater than or equal to 60, and you can see here that we need to add an else statement. Else will return the word failed. So we're replacing each instance of a failing grade with the word failed instead. So if your condition returns whatever I is, you can just add that to the end. If you need an if-else statement, you're going to add it right after the expression. So everybody, in conclusion, a list comprehension is a way to create a new list with less syntax. You can even mimic certain Lambda functions, which we did with the filter function, and it has the added benefit of being easier to read than a Lambda function. So you just follow one of these formulas depending on what you're trying to do. So you need at least list equals your expression for item in your iterable. If you have a condition that you want to check, you just add that to the end of your list comprehension. If you have an if-else statement, then you'll add that to right after the expression. So you just follow one of these formulas depending on how you want to write your program. So that is a list comprehension. If you would like a copy of this code, I will post all of this to the comments section down below. And well, yeah, that's how list comprehensions work in Python. Yo, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain dictionary comprehensions in Python, so sit back, relax, and enjoy the show. Okay people, dictionary comprehensions. They're very similar to list comprehensions, except they're with dictionaries. That's it, video over. Okay, but seriously, a dictionary comprehension is a way to create dictionaries using an expression, and they can replace for loops and certain Lambda functions. And all we have to do is follow this formula. Dictionary equals key, colon, our expression for key value in iterable. So let's go over a few examples. Our first example, we're going to take this dictionary named cities in F. F is short for Fahrenheit. I have different city names as keys and relative temperatures as values in Fahrenheit. So New York is 32 degrees Fahrenheit, Boston is 75, Los Angeles is 100, and Chicago is 50. And what we'll be doing is creating a separate dictionary where all of these temperatures will be in Celsius using a dictionary comprehension. So let's follow this formula. Let's create a new name for this dictionary. Let's say cities in C, short for Celsius, equals, and we will follow this pattern. First our key, colon, then our expression. We'll go back to this in just a moment. For key, comma, value in our iterable of cities in F. And since we're working with a dictionary, we're going to use the items method. Now we just need to fill in this expression. There is a formula to convert Fahrenheit to Celsius, and it should be on the screen right about now. So let's follow this formula. So we'll take our value minus 32, and just for good measure, I'm going to put these within parentheses, and we will multiply all of this by 5 divided by 9. And that is it. So we have our key, our expression to convert Fahrenheit to Celsius for key value in our iterable of cities in F, our previous dictionary. And let's test this by printing our new dictionary, cities in C. Actually, I think I'm going to round these numbers, just so it's more readable. So let's round all of this. There we go. So New York in Celsius is 0, Boston is 24, Los Angeles is 38, and Chicago is 10. So we created a new dictionary using a dictionary comprehension. Now with these dictionary comprehensions, you can add an if conditional to the end of this. So let's say that we have a separate dictionary of weather, like a description of the weather in each city. New York is snowing, Boston is sunny, Los Angeles is sunny, and Chicago is cloudy. Let's say that we would like to create a separate dictionary with a dictionary comprehension that only has cities where the weather is sunny. So I would write something like this. Let's say sunny weather will be the name of our dictionary, equals, and we'll follow this formula, and then we just tack on our conditional to the end. So it's kind of the same as before, really. So key, colon, and we don't really have an expression here, so let's just say value, then for key, comma, value in our iterable of weather dot items, then our conditional if value equals sunny, because we are only looking for sunny weather. And let's print this. Print our dictionary of sunny weather. And let me just make this more readable for you guys. And our new dictionary comprehension will create a dictionary of key values where the value is sunny, using an if conditional at the end of our dictionary comprehension. Here's a third example for you all. If you have an if-else condition, you can add that to where the expression is within your dictionary comprehension. So I'm going to reuse the previous dictionary for the first example where we have cities and their temperatures as values. So we're going to replace each temperature with a description of the weather. Is it warm or is it cold? So let's do that using a dictionary comprehension that contains an if-else statement. So let's say we have a new dictionary named desk, short for description, cities. It's a brief description of each city's temperature. So we follow this formula, key, then our if-else conditional for key value and iterable. Actually, I probably can copy all this just to save some time. Okay, so our iterable will be cities dot items, and our conditional is going to be we will return warm if our value is greater than or equal to, let's say, 40, else cold. And we will print our new dictionary of desk cities, description of cities. So New York is cold because it's 32, that's below 40. Boston is warm, Los Angeles is warm, and Chicago is warm. Now, if your condition gets somewhat complex, you can even call a separate function to keep your code more organized. So key, then we can call a function and pass in a value for key value in iterable. So I'm going to, again, reuse our city names and our temperatures, and this time we are going to call a function instead. I think I'll reuse this code from the previous example where we have a separate dictionary named desk cities, and I'm going to replace this if-else statement with a function. So let's say we have a function that is named check temp, and we will pass in our value, and we just need to define this function. So let's define that here. So let's define check temp, and our parameter is our value that we're currently working on within our dictionary value. Then we'll write if value is greater than or equal to, let's say anything above, how about 70, will return the word hot. Then else if, let's say 69 greater than or equal to value, and then value is greater than or equal to, how about 40, then we will return the word warm. And lastly, else return cold. And let me just fix some of the spacing. Now, depending on the temperature that is stored within each value of our dictionary, we will call a function that will return one of a few different outputs. So it's kind of like we're using the map function, the map lambda function. So let's print our description of cities. And we should get a short description of the temperature in each city after we call the check temperature function and then pass in each value from our dictionary. So New York is cold because it's 32 degrees Fahrenheit. Boston is hot because it's above 70. Los Angeles is hot because it's 100. And then Chicago is warm because that is 50, which is between 69 and 40 within our function. So that is a dictionary comprehension. It's a shortcut where you can create dictionaries using an expression, and they can replace for loops and certain lambda functions. So if you would like a copy of all this code, I will post all of this to the comment section down below. And well, yeah, that's how dictionary comprehensions work in Python. Hey, what's going on everybody? It's Bro, hope you're doing well, and in today's video I'm going to show you how the zip function works in Python, so sit back, relax, and enjoy the show. Alright, ladies and gentlemen, welcome back. We're talking about the zip function today. The zip function will aggregate elements from 2 or more iterables. Iterables are those things like lists, tuples, sets, etc. And the zip function will create a zip object with paired elements from each iterable stored in a tuple for each element within our zip object. Here's an example. Let's say that we have 2 different types of iterables. I have a list of usernames, and a few usernames within here are dude, bro, and mister. And I have a tuple of passwords, and I have some very secure passwords, such as password, ABC123, and guest. What I would like to do is to zip elements from each iterable together so that they're in pairs, and each pair is going to be stored as a tuple within a zip object. And here's how we can do that. Let's say that we will create a zip object called users, and we will use the zip function. The zip function will take a varying amount of iterables. We're going to pass in our usernames and passwords and zip them together. So let's pass in usernames as well as passwords. And now our zip object of users is actually iterable. Zip objects are iterable, so we can use them within a for loop. So let's type for I in users and print I. And what we get is that we have a zip object of tuples, and each tuple is storing each pair of elements from our 2 iterables. Now, users is a zip object, and if you don't believe me, let me prove it. I'm going to print the type of users, and this will print that users is indeed a zip object, but you can easily convert this to a different type of iterable by using a cast. Let's say that we would like to convert our zip object into a list. So we'll surround the zip function with a cast to a list. And now the data type of users is now a list. What we have is a list of tuples, and each tuple is storing a pair of elements from our 2 iterables of usernames and passwords. Now currently, since we're passing in only 2 different iterables, we can easily make this a dictionary so that these are key value pairs. So let's cast our zip object as a dictionary, and to display all of the elements within our dictionary, all the key value pairs, we're going to change our for loop to this. For key value in users dot, and we will use the items method, print key, comma, value. Actually, I think I'm going to separate each of these with a colon just to make it more readable. And now when we zip these 2 iterables together, we end up with a dictionary of usernames and passwords, and the name of this dictionary is users. Now, you're not limited to just 2 iterables. You can add a 3rd iterable or more. So this time, let's create maybe a list of last login dates, and I'll just call this login date equals, and why not make a list? And let's make up some dates. Let's say 1-1-2021, 1-2-2021, and 1-3-2021. Okay, so let's create a zip object of users, and we're going to zip usernames, passwords, and login date. And let's iterate over this. For I in users, print I. Now we have a tuple for each element, and instead of a pair, we now have a trio, I guess, of all of the different elements from each iterable. So in conclusion, the zip function will aggregate elements from 2 or more iterables and create a zip object with paired or grouped together elements stored in a tuple for each element within our zip object. So that is the zip function. If you would like a copy of this code, I will post this to the comments section down below. And well, yeah, that's how the zip function works in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and I'm going to explain the purpose of if name equals main in Python, so sit back, relax, and enjoy the show. During your programming journey, you may have encountered this strange statement of if name equals main. Now, what the heck does that mean? So, with Python files, also referred to as modules, by including this statement, it gives our modules some flexibility. One, a module that has the statement can be run as a standalone program, or 2, this module can be imported and used by other modules if there's some sort of useful functions or other resources within this module to be imported. By including the statement of if name equals main, we're checking to see if a user is running this module as either a standalone program or they're importing it from another module. Behind the scenes, the Python interpreter will set special variables, one of which is double_name. It's a variable, and Python will assign the name variable a value of main if it's the initial module being run. And we can actually test that by printing double_name. So since this is the initial module being run, module 1 for my example, name is going to be assigned a value, a string, of main. Now check this out, I have 2 modules. What if I were to import module 2 and check the name variable of module 2? Let's try it. Import module 2. In order to access a variable from another module, I need to type the name of the module, module2 dot, and I would like to check the special name variable of module 2 and print it. So when you import a module, this name variable is going to be assigned the name of the module, in this case, module 2. This time, what if we change the roles around? I'm going to copy all of this text and paste it within module 2. We're going to import from module 1. We will print that special name variable of this module, module 2. And then print the name variable of module 1, which is being imported. Now, when I run this program, I'm going to instead run from module 2. Now, this time, that special name variable of module 2 is main, and the special name variable of module 1 is module 1, the name of the module. So by including a statement such as if name equals main, we're checking to see if this module is being run directly or indirectly. So let's test it. Within this statement of if name equals main, let's print running this module directly. Else, that must mean that we're running this module indirectly. So let's print running other module indirectly. Okay, so I'm going to go to module 1 and run from here. Running this module directly. Now, let's do the same thing with module 2, but we need to import module 1. And let's run from module 2. Running other module indirectly. For the time being, I'm just going to write pass within our if name equals main as a placeholder and get rid of our if statement. So let's say within module 1, there's a useful function or resource we would like to access from module 2. So let's say we have a function named hello, and all this will do is print the word hello. Let's just pretend that it's a useful function. Not really, but let's pretend. So in order to use this function from module 2, I need to import module 1, then type module 1 dot, and then the name of the function. So I'm going to run from module 2. And this will print hello. But what if I run this program from module 1? So right now, module 1 cannot be run directly as a standalone program, so I cannot print the word hello. So what I could do is within if name equals main, I can call that hello function directly. So let's run from module 1. Hello. One other thing that you might see too within the if statement if name equals main, there might be a call for a main function, and you can write the main body of your program within a main function. So everybody, in conclusion, the reason that people may include this statement if name equals main is that it allows our modules to have some flexibility. They can be run as a standalone program, or they can be imported and used by other modules. And this is because the Python interpreter sets that special variable of name with a value of main if it's the initial module being run. If you would like a copy of my code and my notes, I will post all of this to the comment section down below. But yeah, that's the purpose of if name equals main in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to show you all a few useful functions related to times and dates using the time module in Python, so sit back, relax, and enjoy the show. Alright everybody, so the time module. Let's begin by importing time, and the first thing that I'm going to explain to you all is how we can find our computer's epoch, also pronounced as epoch. So this is a date and time in which your computer thinks time began. Think of it that way at least. So we use our epoch as a reference point. So to find your computer's epoch, it's going to vary based on your computer and your operating system. So to find your computer's epoch, type time.ctime, and as an argument we will pass in 0. Now what this method will do is that this method will convert a time expressed in seconds and convert it to a readable string. So if I was to pass in 0 and print it, well then this will display the date and time, which is my epoch, our reference point. So for me, my epoch is Wednesday, December 31st, 6 p.m., 1969. So I've just added a note that the ctime method will convert a time expressed in seconds since epoch and convert it to a readable string, a readable date and time. So for practice, let's pass in perhaps 1 million seconds and see what date and time that we receive. So our ctime method will return a date and time 1 million seconds past this epoch here. So that would be, for me, Monday, January 12th, about 7 a.m., 1970. Our next method is the time method of the time module. Let's print time.time method. And what this method will do is return the current seconds that have passed since our epoch using our computer's clock. So the number that I end up with is just over 1.6 billion, and this is in seconds. So for me, 1.6 billion seconds has passed since that date, which is my epoch. I believe it was December 31st, 1969. And every time that I rerun this program, you can see that the amount of seconds that has passed is actually increasing. So that is the time method. It will return the current seconds since your epoch using your computer's clock. And you know what? Just for fun, let's change the date and time on our clock and see what happens. So let's change the year to, how about the year 2000? Change and close. So let's see what number we get with the time method now. So we get just under 1,948,000,000 seconds have passed. And now if you need to retrieve the current date and time, well, there's one of a few ways in which you could retrieve that. But one way is that we can combine both of these methods of the ctime method and the time method of the time module. So let's print time.ctime, and we're going to pass in an amount of seconds into the ctime method as an argument. So within the ctime method, we're going to call the time method. So the time method will return an amount of seconds since our epoch, and the ctime method will convert that amount of seconds to a readable date and time. So the current date and time is Saturday, January 23rd, about 3 p.m., 2021. Now, there is more than one way to get the current date and time. Another way is to use the local time method, and the local time method will create a time object based on the current time. So what I'm going to do is create a variable called time object, and I just need to explain a few things about time objects. So to best explain this, I'm going to print our time object. Now, a time object is also referred to as a struct time object. It is made up of different keyword arguments. There's a year, a month, day, hour, minutes, seconds, day of the week, day of the year, and this keyword argument here has something to do with daylight savings time. So there's quite a few uses with time objects, and one way is that we can format them however we want, because right now, this time object is not in a readable format. So to convert this time object into a readable string, we'll need the help of a separate function, and that is the strf time function. str is short for string, f for format, and time, well, for time, I guess. So this function needs two arguments, a format and a time object. So our strf time function will accept a format and a time object as an argument. So our format is really just a string of different directives, and to best explain these, I'm going to head to Python's official documentation on this subject. So here I am on Python's website regarding the time module, and underneath this section on the strf time function, there are different directives that we can embed within our format string that we pass in as an argument. Depending on the directive that we add, we can display a certain format of our date and time. So for example, if I was to pass in, let's say %, lowercase a, then we will display the time object's weekday name. And you're not limited to just one directive, you can add any combination of directives. So if I was to add %m, well, we would display the month of our date time object as a number 1 through 12. So there's a bunch of directives here, and I'm going to be using some of these. So within a string for the format argument, I'm going to pass in %B for the name of the month, %D for the day, %Y for the year, %H for the hour, and to format this, I'm going to add a colon to separate hours and minutes, %M for minutes, colon, %S for seconds. And then we are going to assign all of this to a variable. Let's say local time, and local time will be a string. So let's print our local time, and the current time is January 23rd, 2021, about 3 p.m. Oh, and I almost forgot, you can also get the UTC time. That is the Coordinated Universal Time, if you know how that works. So if you need that, you would just use the GM time method for the UTC time, Coordinated Universal Time. Okay, next up we have the strp time function. And this function will parse a string representation of a time and or date and return a time object. So we need to pass in a string representing the date and or time, as well as a format string. So let's create a time string, and this variable is going to be a string representation of a date. Let's say 20th of April, 2020. And what we can do is take this string representation of a time and or date and parse it to a time object. So we're going to pass in our time string variable as well as a format string. So let's say I would like to parse the day, so that would be %D for day, then %B for name of the month, and then comma, %Y for year. This function will create a time object, so let's assign that to a variable. Time object equals time.strp time. We're passing in our string representation of a time or date, as well as a format string. And we can print our time object using a print statement. However, this is going to be in a form that is somewhat difficult to read, but you can see at least we have a time object with all of these keywords filled in with anything that we passed in via these format directives that we have. Now the next function is the ASC time function, And this function accepts a time object or a tuple representation of a relative time. So this time, let's create a time tuple. And we're going to follow this order. We can pass in up to 9 values. The first value is a year. So let's pass in perhaps 2020, a month, let's say 4, a day, how about 20, 4 hours, let's say 4, minutes, 20, and seconds, maybe 0. Let me just fix some of the spacing here. Okay, you can also pass in a numbered day of the week. I'm just going to say 0. I don't think it's really that important. A day of the year, 0, and -1 or 0 for daylight savings time. So we created a time tuple, and we can pass in a time object or a tuple representation of a time following this formula. So let's pass in our time tuple, and this will create a time string, a string representation of the time that we create. And let's print our time string. And we should have April 20th, about 4 in the morning, the year 2020. So that is ASC time. It will convert a tuple representation of a time and date or a time object and convert it to a readable string. Now, another option is to use mktime, and mktime will take a tuple representation of a time or a time object and convert it to seconds since epoch. So April 20th of the year 2020 is about 1.5 billion seconds since our epoch date, and for me that was December 31st, the year 1969. So that is a few useful functions of the time module. If you would like a copy of this code, I will post all of this to the comment section down below. And well, yeah, that's the time module in Python. Yo, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain multi-threading in Python, so sit back, relax, and enjoy the show. Think of a thread as a flow of execution, like a river, and each thread can carry out its own separate order of instructions. If we use this process of multi-threading, we can have our program run different parts of its program at different times. They all run concurrently but not truly in parallel. That is a concept for later referred to as multiprocessing. So with threads, they each take a turn running to achieve concurrency. This is due to a notorious feature known as the GIL, the Global Interpreter Lock. Only one thread can be running at one time, but they can all take turns when one thread is idle. So this allows one thread to hold control of the Python interpreter at any one time. So they run concurrently but not truly in parallel, which is what we do with multiprocessing. Now, programs and tasks can be divided into two different categories. They can be CPU bound, that is a program or a task that spends most of its time waiting for internal events, such as a task that is CPU intensive. It is better to use multiprocessing for tasks that are CPU bound. Now, tasks that are IO bound means that the program will spend most of its time waiting for external events, such as waiting for user input, or if you're doing activities like web scraping, you do a lot of sitting around. So with IO-bound tasks, it's better to use multi-threading because we can have multiple threads running concurrently, but not truly in parallel like what we do with multiprocessing. After importing the threading module, we can count the number of threads that are currently running in the background. Whenever we run a program, we have one thread that is running that is in charge of executing our program, and we can print the active count of threads running in our program using the active count function of the threading module. So this will print 1. We have one thread that is running, and we can print a list of all of the threads that are running by using the enumerate function. So the one thread that is in charge of running our program is referred to as the main thread. By using this concept of multi-threading, we can have more than one thread running concurrently, not truly in parallel. All the threads will take turns while one of them is idle. So we can have more than one thread running, more than just the main thread, which is in charge of running the main body of our program. So while our main thread is in charge of running the main body of our program, we can have another thread that's in charge of a separate part of it, maybe like a countdown timer or something. So one good example, take that quiz game that we made some number of videos ago while we were waiting for user input, which is a IO bound task, we could have had a countdown timer going, like you only have so many seconds to answer this question. We could have had one thread in charge of waiting for user input and another thread in charge of the countdown timer. So that's an example of multi-threading. We had two threads running concurrently. And what we'll be doing in this video is creating a program that involves multi-threading. We can have different threads in charge of different parts of our program, and they can all run concurrently. They'll all take turns while one of them is idle. So let's say that we're running late for school or work in the morning, and we have 3 different tasks that we need to complete before we can leave for school or work. So think of 3 different things you do in the morning, such as maybe eat breakfast. Some people drink coffee or maybe a beverage of your choice, so drink coffee. And some people like me, they like to do their homework last minute, so I'll say study before I leave for work or school in the morning. So what we'll do in each of these functions should take some amount of time to complete. So we can have our main thread sleep for a given number of seconds using the sleep function, time.sleep. And let's say that in order for me to eat breakfast, this task will take me 3 seconds. Let's just pretend that instead of minutes, this will be in seconds. So drink coffee will take me 4 seconds, and study will take me 5 seconds. Then when we finish sleeping, let's print a confirmation message. Let's say you eat breakfast, as in you finish eating breakfast. With drink coffee, you drank coffee. And with study, you finish studying. Now, each of these tasks are IO bound. They're going to be spending a lot of time just waiting around for external events. They're waiting for the sleep function to expire before they can finish their task. So we're going to have all of these 3 functions run on our main thread, and we'll see how long it takes for us to complete our morning ritual, these 3 tasks. So let's call these 3 functions within our main thread. So let's call the eat breakfast function first, followed by drink coffee, and then study in that order. So this program is going to take approximately, 12 seconds to complete. So there's going to be a pause for a second. You eat breakfast, then followed by you drank coffee, and then study. You finish studying. So this program took about 12 seconds overall. So if this were realistic, what we would have done is we would sit down and eat breakfast for 3 minutes, 3 seconds in this case, and then once we finish eating breakfast, only then are we allowed to drink our coffee. And once we finish our coffee, only then can we study. So we completed these tasks sequentially and not concurrently. For us to move down to the next function, we need to complete the previous functions because we're doing this in order. But realistically, us human beings, we would probably eat breakfast, drink coffee, and study all together because we can multitask and we can complete these 3 functions in less time. And that's kind of the same process as multi-threading. We can have these 3 separate functions running concurrently as if we're multitasking. We're eating breakfast, drinking coffee, and studying all at once. Now, currently we have one thread that is in charge of these 3 separate functions. What we could do is that we can create 3 additional threads. Each thread will be in charge of each task, and then we'll have our main thread running in the background that will complete the rest of the program. So this is how to create an additional thread. Let's say that x equals threading dot thread. We need to pass in a target equals, and then the name of the function. So let's say thread x will be in charge of eating breakfast. And then you can pass in arguments too if your function has parameters by typing args, and then you pass in a tuple. So let's say you have 1 argument to pass in, you'll type your argument followed by a comma. But we don't have any arguments in this example, but you'll need to be sure to enter them in if you do have any. Okay, then to begin this thread, you type the name of the thread, in this case x, dot start. So we now have an additional thread, and this thread is in charge of eating breakfast. Now let's create another thread to drink coffee. And we'll call this Y. And the target will be drink coffee. And lastly, we have a thread in charge of studying. And this will be Z. And the target is our study function. Okay, now let's see how long it takes for us to complete our program. Oh, and be sure to comment out these function calls within the main thread, because we don't want the main thread in charge of those anymore. Okay, now we can run the program. So we have 4 threads running this time. You eat breakfast, you drink coffee, you finish studying. So this program took approximately 5 seconds to finish. And the reason that this program took 5 seconds instead of 12 is because before, our main thread was in charge of running these tasks sequentially in order, but now since we have a thread dedicated to each task, we can run them all concurrently instead of sequentially, so that this program now took about 5 seconds to complete. And you may have noticed too that the ActiveCount function as well as the enumerate function were called before threads 1, 2, and 3 finished their respective tasks. That's because the main thread is not going to wait around for these 3 threads to complete. It has its own set of instructions to do, so it is no longer in charge of these 3 functions. The program is going to handle those 3 functions to our 3 threads, and our main thread is going to continue its own set of instructions. Its job is to print the active count as well as call the enumerate function, which it did, and it finished its tasks before threads 1, 2, and 3. Now, one trick that you can do too is that you can use the time module's performance counter function, and this function will return how long it takes our calling thread, as in our main thread, to finish its set of instructions. So our main thread is not in charge of executing these 3 functions. Our main thread is in charge of creating 3 additional threads and then calling the ActiveCount function and the enumerate function, as well as the performance counter function. So our main thread will take approximately 0.075 seconds to complete, and our 3 threads are still running in the background. Our main thread's job, its order of instructions, is to create 3 additional threads and then immediately print whatever is returned via the ActiveCount function, enumerate, and then your performance counter. So our main thread says that it finished its tasks in about 0.07 seconds, but threads 1 through 3 were still trying to catch up. That's why the main thread finished before our 3 additional threads, and once all active threads have completed their tasks, then your program will finish and exit. There's also this concept called thread synchronization. We can have a calling thread, in this case our main thread, wait around for another thread to finish before it can move on with its own instruction set. So let's say we would like our main thread to wait around for thread 1, also known as X. So we're going to use the join function of thread X. And now our main thread has to wait around for thread X, also known as thread 1, to finish before it can move on with its instruction set. So let's do the same with Y and Z. So now our main thread, before it can move on with the rest of the program, has to wait for all of these threads to synchronize and join, and then, and only then, can it move on with the rest of its own instruction set. So this time, our program is going to look a little something like this. You eat breakfast, you drink coffee, you finish studying. So by the time we reach our active count, these threads are already joined and synchronized. They're no longer active. When we enumerate over our active threads, we only have our main thread, and our main thread completed in about 5.1 seconds this time because it did a lot of waiting around. It was waiting for threads X, Y, and Z to join and finish. In conclusion, a thread is a flow of execution, like a separate order of instructions that a program can follow. And when we run a program, we always have at least one thread running initially, and that is referred to as the main thread. However, if you have multiple threads using the concept of multi-threading, we can have multiple threads running concurrently, but not truly in parallel, which is what we'll cover during the video on multiprocessing. This is due to a feature known as the GIL, the Global Interpreter Lock, which allows only one thread to hold control of the Python interpreter at any one time. And tasks can be either CPU bound or IO bound. A CPU-bound task is a program or task that spends most of its time waiting for internal events, such as a task that is CPU intensive, and IO-bound tasks spend most of their time waiting for external events, such as waiting around for user input or web scraping. With IO-bound tasks, it's better to use multithreading. With CPU-bound tasks, it's better to use multiprocessing. Well, everybody, that is a quick overview of multi-threading. I will post all of this code to the comments section down below. And well, yeah, that's how to achieve multi-threading using Python. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to explain daemon threads in Python. So sit back, relax, and enjoy the show. Okay, so daemon threads, also pronounced as daemon threads. A daemon thread is a thread that runs in the background, and they are normally not important for your program in order to run. Your program will not wait for daemon threads to complete before exiting, whereas non-daemon threads, they cannot normally be killed. They will stay alive until their task is complete. So a few common uses of daemon threads would be background tasks, garbage collection, waiting for input, or other long-running processes. So here's an example of why daemon threads would be useful. Let's say that we'll have two threads. Our main thread will be in charge of waiting around for some user input. We'll ask, do you wish to exit? And in the background, we'll have a timer going that will display how long somebody is logged in. So let's create a function named timer. And what we'll do is just display how long somebody's logged in. So let's say we have a count variable. While true, we'll use the sleep function of the time module to sleep for approximately 1 second. Then we'll increment our count variable by 1, and we'll print a message. So let's say logged in for count seconds. And let's create a thread that will be in charge of this timer and run it in the background. So let's say x equals threading.thread. The target will be our function of timer, and we need to start this thread, x.start. So our thread x will be in charge of our timer and run it concurrently while we're waiting for some user input. Our main thread will be in charge of waiting for this user input. Do you wish to exit? Now, here's the issue of us using a non-daemon thread for a background task, such as a countdown timer. So our main thread is in charge of waiting around for some user input, and thread x, our additional thread, is in charge of running this countdown timer. So if I wish to exit this program, I'm just going to type OK and hit enter. Well, my background timer is still going, but my main thread is complete. So I would like to exit this program, but my program will not exit as long as there are non-daemon threads that are still alive. We cannot normally close this program unless we do like a brute force, close and exit of the program. So we can turn this thread of x into a daemon thread so that when we wish to exit the program, when there are no more non-daemon threads alive, and to change a thread to a daemon thread, it's actually fairly easy. When you create your thread, you can set this flag of daemon equal to true, and that's it. So when all non-daemon threads have finished their tasks, your program will complete and exit. But if there are daemon tasks running in the background, they will be killed automatically. So let's try this program again. So do you wish to exit? My program is going to continue running. My daemon thread is in charge of the timer, and it's going to continue running until all non-daemon threads have completed their tasks. So once I type OK, my program will finish running and my countdown timer will stop because all daemons are killed when your program has finished running. There's also two additional methods that you might be interested in. You can use the setDaemon method of a thread, and you can set it to false or true if you would like to change a thread to a non-daemon or a daemon. However, if your thread is currently running, well, you cannot actually change it from a non-daemon thread to a daemon thread while it's currently running. So you would have to do that before you actually use the start function. And you can also check to see if a thread is a daemon or not by using the isDaemon method. This will return true or false. So everybody, in conclusion, a daemon thread is a thread that runs in the background and they're not important for your program in order to continue running. your program will not wait for daemon threads to complete before exiting the program, whereas non-daemon threads cannot normally be killed. They will stay alive until their task is complete, and daemon threads are commonly used for background tasks, garbage collection, waiting around for input, or other long-running processes. So if you would like a copy of this code, I will post all of this to the comment section down below. But yeah, those are daemon threads in Python. Yo, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain multiprocessing in Python, so sit back, relax, and enjoy the show. What's up? Let's talk about multiprocessing. Multiprocessing is the act of running tasks in parallel on different CPU cores. It's different from multithreading, although it sounds similar, because with multithreading, we're limited to running one thread at a time because of the GIL that lock, which is used for threading. We can run threads concurrently, but not in parallel. However, with multiprocessing, we can create processes, and we can run each process in parallel on a different CPU cores. So with multiprocessing, it's better for tasks that are CPU bound, where you need heavy CPU usage, whereas multithreading, that is better for IO bound tasks where you do a lot of waiting around. So before we begin, I recommend these two imports, multiprocessing and time. Let's begin. Quick note, if you're running the Windows operating system, you'll probably need to add this line, if name is equal to main. So when we run a program, we have a main process that is running, and if we create a child process from that process, it's going to copy the module that we're currently working with, and that child process will create its own children processes, and it's going to be a problem. So we're going to add this line, if name is equal to main. So when we create a child process, it will copy our module, but it's not going to execute it. So let's create a main function, and a majority of our code is going to be within our main function. If you're running a different operating system, you probably don't have to do this, but if you're running Windows, you probably will. Now with multiprocessing is better for tasks or functions that are CPU bound, where they require heavy CPU usage. Let's say that we have a function named counter, and we'll pass in a number to count up to, but the number we're going to pass in is a ridiculously large number like a billion. So let's create a function that will count from 0. So count equals 0, and while count is less than our number that we pass in, we will increment our counter by 1. So that is the function that we'll call with our processes that we create. Now within our main function, we'll create a process, and to do that, you'll need the multiprocessing module. So import process and CPU count, and we'll save this for a little bit later. To create a process, let's say we have process A. A equals process. This step is very similar to creating a thread. We have a target. Our target will be our function of counter. And if we have arguments, we will pass those in. So remember, with our arguments, we have to pass in a tuple. Since we only have one argument to pass in, to differentiate this from an expression, we have to add a comma at the end. So our number, let's say, is 1 billion. So that's a million, 10 million, 100 million, 1 billion. Let me just verify that. Okay, so that's 1 billion. We're going to count from 0 to a billion. And in order to start this process, my process, use the start function. And then I will use some process synchronization by using the join function. My main process is going to wait around for my child process of A to finish before continuing. And let's print our performance counter. So we'll print finished in, let's say, time.performance counter seconds. Okay, so let's see how long it'll take to count from 0 to a billion using one process. I fast forwarded this video, but it took my program 56.7 seconds to count from 0 to a billion, but we can speed this up by using multiprocessing. Let's create a second process named B. And I'm going to divide the amount of work in half, so each process will count to 500 million, half of a billion. So let's change A to B. and I'm going to group these start functions together, just so it's easier to read, and then b.join, just to synchronize everything. Okay, and then let's change 1 billion to 500 million for each. It's the same amount of work, but divided among workers. So that is 500 million. Let's see how well it runs this time. So it took my program about 40.3 seconds to finish counting from 0 to a billion, but I divided that task among different processes. Each of my 2 processes counted from 0 to 500 million this time. So this time, let's create 4 processes. So we have A, B, C, and D. And we'll need to start them. And I'm going to join them. Now, this might not actually speed it up for you, and I'll explain why later. It depends on the amount of CPU cores that you have. Okay, so, let's change this too. So, 250 million for each. Okay, see you in a couple seconds. Okay, welcome back. So, on my computer, when I ran 4 processes, and each was counting up to 250 million, I could finish my program in 27.3 seconds. Now, for me, if I created more processes than this, it would probably take longer, and here's why. So you can print the CPU count of your computer using this function of CPU count. So if I were to print whatever this function returns, I can get the count of the number of additional processes that I can run. For the time being, I'm just going to comment out this start function because I just want to print whatever this value is. So my CPU count on my computer is 4. So I can run 4 additional processes. But let's attempt to run 8 processes. So I'm going to copy all of these, and let's say that we have E, F, G, and H. And we will start all of those too. So give me a second just to start them. So A, B, C, D, E, F, G, H, and then I'm going to join all of them. E, F, G, and H. Okay, so let's run this now. Oh, and change the arguments too. I keep forgetting to do that. So let's say 125 for each. So 125 million times 8 is 1 billion. Okay, see you in a bit. Alright, welcome back. This time when I had 8 processes working, it actually took me longer than when I had 4 processes working. When I had 4 processes working, it took me about 27 seconds. This time it took 30 seconds when I had 8 processes working. That's because I had more processes than my CPU count. And that's partially because whenever you create a process, there's significant overhead with beginning and destroying a process. And if I can only run 4 processes on my computer at one time, well then I'm creating additional processes to no extra benefit. It's actually hindering the performance of the computer because I'm creating all of these additional processes when it really doesn't help me. In conclusion, multiprocessing is the concept of running tasks in parallel on different CPU cores. It's similar but different from multithreading because with multithreading, we can run tasks concurrently, but they're all taking turns because of the GIL. With multiprocessing, we can run all of these different tasks together in parallel. Multiprocessing is better for CPU-bound tasks, where a task has heavy CPU usage, and multithreading is better for IO-bound tasks, tasks that involve a lot of waiting around. So that's multiprocessing. If you would like a copy of all this code, I will post all of this to the comment section down below. But yeah, that is how multiprocessing works in Python. Hey, what's going on everybody? It's your bro here, hope you're doing well. And in this video, we're going to be creating our very first graphical user interface in Python. So sit back, relax, and enjoy the show. Welcome one and all. Today we'll be creating our very first graphical user interface in Python, also known as a GUI for short. We're going to be using the tkinter GUI, which is a module that is included with Python. Our first step in order to use tkinter is to import this module so that we can begin using it. Our first line of code will be from tkinter import asterisk. This will import everything related to the tkinter module. And with this import, we can now use all of the GUI features that this module has to offer. Now, there is one important distinction that we need to make. We need to discuss the differences between windows and widgets. Here's a few quick definitions that I definitely did not copy from the internet. Widgets are GUI elements such as buttons, text boxes, labels, images, you name it. And windows, they serve as a container to hold or contain these widgets. For this topic, we'll be creating and customizing our own window, and in future topics, we'll be exploring different widgets that are available to us. So let's begin by creating a simple window, and we should give our window a unique name, such as window. That's pretty creative. And in order to instantiate this window, we're going to follow this window name with equals tk. Make sure you get the capitalization right. This is a uppercase T, and a set of parentheses to serve as the constructor. What this will do, and I'm just going to add a comment, is instantiate an instance of a window for us. And when we compile and run this, nothing appears to happen. That's because we only instantiated our window and we're not actually displaying it. In order to display our window, we're going to follow this with the name of the window dot main loop, and this will display our window. And this is our first graphical user interface, and we'll be adding widgets to this window. So I'm going to add a comment that this will place window on computer screen, and it will also listen for events, but we'll get to that in future videos. Now, what we'll be doing is customizing the appearance of this window. Let's begin by changing the size, and we can do that with the geometry function. So we're going to first begin by typing the name of our window, which is window, follow this by using the geometry function, and we pass in a width and a height, but make sure this is within quotes, and set this to whatever width and height that you want. So if I want 420 by 420, that would be 420 x 420. And the size of our window is now the size that we set with the geometry function. Now take a look at the top left of this window. We have this feather icon as well as a title of TK. That's kind of lame, so let's change that. Let's first change the window title, and there is a function to do that. So we type in the name of our window, window dot title function, and we can pass in a new title that we want to set. And I will set the title to be maybe Bro Code First GUI Program. That'll work. And we now changed the title of this window, and it says Bro Code First GUI Program. The next thing that we can do, although not necessary, is that we can change the icon of our window bar at the top. I would like to replace this feather icon with an image of my choosing. Here's my desktop, don't mind all of the clutter, and I would like to use this image of the logo for my channel and set this as the icon for my window. So what I'm going to do is copy this, and then go to my project folder, and then paste it. Click OK, and I now have this image within my project folder, but it's in a format that we cannot use currently. We need to convert this to what's called a photo image. That is a format that tkinter can use. So we'll need to convert our image to a photo image. So do that anywhere within the window between window equals tk and window.main loop. Right here is good, I suppose. We're going to create a photo image from this image, and this is a PNG file, but yours might be something different. So let's give our photo image a unique name, like maybe icon. And in order to create a photo image, we'll follow this with equals photo image. And within the constructor of our photo image, there's an option for file. We can either list the file name or the file path if it's somewhere else on your computer. Since this image is within my same project folder, I only have to list the file name. And this is called logo.png, and this is probably going to be named something else for you though. So we now have this photo image called icon that we can use. And I need to set the icon of my window to this icon. And luckily there is a function to take care of that for us. Type in the name of the window, which is window, dot, and we're going to use the icon photo function. There are two arguments. The first we're going to set to true. And the second is the photo image that we want to use, and this photo image is called icon. So we're going to pass this photo image as an argument to this function of icon photo. And now when we compile and run this, the image that we wanted to use is now set for the top left icon of this window bar. However, it loses a lot of the quality since the dimensions are so small, but you can still tell that it's my logo though. So that's how to replace the icon of your window bar in the top left corner. Now let's change the background color of this window, and one way in which we can do that is to use the config function. You can use the config function anytime that you want to make any changes to this window. So let's change the background color here, and there is an option called background, and we can set this equal to either a color name or a hexadecimal value. Let's begin with just some color names. Let's say that I want the background color to be black. I'll just type in the word black here, and this will change the background color of my window to black. Alternatively, you can set a hex value as the color. So if you were to look up or Google hex color picker, you can select whatever color you want. Let's say that I want a sky blue color like this. Well, this is the hex value. I'm going to copy this value and then paste it within the option for my background. Make sure you have this hashtag as well, because that represents that this is a hex value. So now the background color is that sky blue color that I picked. Well, everybody, that's the basics of creating a window in Python, and in future videos we're going to be exploring different widgets that we can add to this window that have some functionality. So if you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how to create your very first GUI in Python. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create labels in Python. So sit back, relax, and enjoy the show. What is a label? Well, I'm glad you asked that question. It's an area widget that holds text and/or an image within a window. So to begin, we'll need to create a window to act as a container to hold this label. We can create a window with window equals tk followed by window.mainLoop. And this will give us a window in which we can add a label to. Now let's give our label a unique name, such as label. And in order to instantiate a label, we'll follow this label name with equals label with a capital L and a set of parentheses. The parentheses are acting as the constructor for this widget, our label, and we can pass in arguments into these parentheses. The first argument that we're going to pass in is a master. The container for this label, we're going to pass in the name of our window because our window is acting as the container. With widgets in Python, we can delimitate the arguments that we're passing in with a comma, and there are options available to us. Options are keyword arguments that we can pass in to the constructor for this widget. One option available to us is text, and we can set the text of this label equal to a string that we set. So let's say that we want this label to say, hello world. Well, we're going to pass in this option, text, and it's a keyword argument. So if we were to do this, we're going to set the text of the label, but this label currently doesn't appear within our window. What gives, bro? I thought you knew how to code. Hold up, wait a minute. There's one more thing that we need to do. So we're going to actually add this label to the window now. We set the master of the label to be our window, but now we actually have to add it as step 2. One way in which we can do that is to use a pack function of our label. So follow label equals label and pass in all of your arguments, and then follow this with the name of the label dot pack. So with the pack option, by default, this will place our widget in the top center of our window. Another way in which we can add a label to a container or window is to use the place function, and we can set some coordinates of where we want this label or other widget to appear within the window. If we want this to appear in the top left corner, we can set x to equal 0 and y to equal 0, and these are options available to us too that we can pass in. So this place function will place our label at some position or some set of coordinates within the window. And with x equals 0 and y equals 0, that will place our widget in the top left corner of the window. And if I were to change these to, let's say, x equals 100 and y equals 100, well, this is going to be placed down by 100 pixels and to the right by 100 pixels. So you can use pack or place. There's a few others like grid, but they're a little more complex, so we'll get to that in a future video. For the time being, I'm going to use the pack function of the label and turn this place function into a comment, label.pack. All right, now how can we customize this label? We can pass in different options when we instantiate this label. Let's change the font, and that's another option. We can change the font with font equals, and then we can pass in a font. Let's begin with a font family. I will say maybe Arial, a size, perhaps 40, and then a style if you so choose, like bold. There's also italic and underline, but this will work just fine then. So this will change the font of the text of our label, and it says Hello World still. Now let's change the foreground color. So that is another option. The foreground is the font color, and the option is FG for foreground. It's short for foreground. Foreground equals, we can state a color name, such as green, and our text should now be green. You can select something more specific by passing in a hex value. So a custom color that I like is hashtag 00FF00. This is bright green. You can always look up what different hex values are. And we can also change the background color too. That is BG, short for background color. And we can pass in a color name or a hex value. I'm just going to set this to black, just to demonstrate that we can pass in both either hex values or color names. And what we have is green text on a black background. And this is the limits of our label within the window, because when we expand this window, the label is still going to stay the same size. If we were to change the text within the label, our label is only going to take up the room that it needs. And you can see that our label is now smaller. Now we have all of these arguments within our constructor, and it's getting a little bit difficult to actually read. So I'm going to separate each of these arguments line by line, just so that this is more organized, but it'll work just the same as it did before. Now, how do we add a border around our label? One, we can set the border style with the relief option, and one border that I like is raised. But right now, the border width is 1, so it's a little difficult for us to actually see the border. Let's increase the border width with the option BD, and I'll set this equal to maybe 10. So this border is now more visible. Another relief, which is the border style, is sunken, and this will give our label a sunken appearance, but I think I'll change this back to raised. We can also add some padding around the text, between the text and the border. We can pad X and pad Y. Pad X will add some padding, some space between the X-axis of our text between the border. So let's set this to maybe 20, and we now have 20 pixels worth of space between the text and the border. Let's also pad Y. This will add some space above and below our text, between the text and the border. Now, how do we add an image to a label? We first need to create what's called a photo image, and we will create this within the lines of window equals tk and window.main loop. And let's give this photo image a unique name, like photo. And in order to create a photo image, we're going to follow this with photo equals photo image. And within the constructor of our photo image, there's an option called file, and we can list a file path or a file name. Right now on my desktop, there is an image that I want to use, and I need to convert this to a photo image. Here's my desktop, and this is an image that I want to use to add to my label. I need to get the file path, and I can get that by going to Properties, then underneath Location, I can copy this location address and paste it within the quotes for file. And then I need to add the image name, and this is person.png. And with these backslashes, these need to be double backslashes because that is the escape character for a backslash. But what would be a better option is to add this image to my project folder that contains the Python file that I'm working with. So in place of listing the entire file path, I'm going to copy the image that I want to use, go to my project folder, and then paste it. and I no longer need this entire file path. I can just list the image name that I have. And now what we need to do is add this photo to the label, and there's an option to do so. That is the image option, and we'll place this within the constructor for the label. We're going to set image equal to the photo image that we have, and our photo image is called photo. This will add our photo image to our label or other widget depending on what we're working with. So we have our image, but it replaced all of the text that we had for this label. How do we add both text and an image to a window? Well, we can follow this with the compound option. We can set a direction of where we want this image to be placed relative to the text that we have. So I'm going to set compound equal to bottom so that the image appears on the bottom or underneath our text. So we can both have text and an image, or if I want this to be in a different location, I could set this to maybe top, left, or right. If I were to set this to top, we have our image on top of our text. And one thing to know about labels and many other widgets in Python is that the size of the widget will actually increase to accommodate the size of all the components that's contained within. If I were to give the text a longer string of characters, such as bro, do you even code, then the width of our label is actually going to expand to accommodate the size of the longer string of text that we have. So that's the basics of labels, everyone. If you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that's the basics of labels in Python. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create buttons in Python. So sit back, relax, and enjoy the show. Buttons. You click them, and then they do stuff. That's pretty much it. So this is how to create a button in Python. We'll need a window equals tk, followed by window.main loop. Let's call our button just button. And in order to create this, we'll follow this with equals button. And within the constructor for this button, we're going to list what we want to add this button to. What is the master? The master is the window. And in order to display this button, we're going to follow this with button.pack. And we should have a small rectangular button within our window, but it doesn't display any text, nor does it do anything. So let's add some text, and there is an option to do that. Within the constructor, we're going to list the option for text, and set this to whatever text you want to display. Let's say, click me, and then when we run this, our button now says the text that we set, and it says, click me. However, it currently doesn't do anything though. We need to set a command. That is another option. Command equals, and we list a function name. This is what's known as a callback. So let's create a function called click. And then outside of the window, let's define what our click function does. def click, and let's print a message. You clicked the button. Now, with the command, we're going to list the function name without the parentheses. So make sure you're writing it as this and not that. This is what's known as a callback. So when we click on this button, it's going to perform our callback and perform whatever is within our function click. Just like that. Let's customize the appearance of this button. I'm going to change the font. That is another option. Font equals. And let's pick a professional font such as Comic Sans. It's very professional. And I'll set a size of 30. And now you can actually read what's on this button. It's large enough. Let's set the foreground color. That is the font color, FG. You can place a color name or a hex value here. I'll pick green, that is 00FF00. And our text should now be green, which it is. Let's also change the background color. That is BG. I will pick the color name of black. And now we have green text on a black background. Notice that when I click on this button or hold my mouse button down, the color scheme has changed. That's because there is a different active foreground and active background. And we can change those too, so that this won't flash every time you click on the button. So let's change the active foreground and active background. Those are other options, active foreground, and I'll set this to the same color as my foreground. which is green. So the text color is going to stay the same, and I'll also change the active background. And I will also set this to black to match my background. And then this should no longer flash when we click on our button. If you need to disable somebody from clicking on this button, there's an option to do so, and that option is the state option. And normally this is active, but you can set this to disabled, and we can no longer click on this button. And you can see that the color scheme has changed too. It's all grayed out and whatnot. So I'm going to replace this back with active because we still have a few more things to do. Now, how do we add an image to a button? There is an image option, and we set this equal to a photo image. But first, we need to create a photo image. I have this photo of a like button, a thumbs up that I want to use. I need to create a photo image from this image file. So within the window, let's call this photo image just photo. Photo equals photo image. Then I'm going to list the file path or the file name. Since this image is within my same project folder, I only have to list the file name. And this is called like.png, but if you use your own image, it's probably going to be named something else. Then I need to set the image equal to my photo image, which I named photo. But the photo replaces the text on this button, but it still works the same. So we would like to display some text as well as our image. We need to use the compound option. And we list a direction. We can list top, bottom, left, right. We want this image to be on the perhaps bottom. So let's list the bottom. And now when we run this, we have our text as well as our image. And if we changed compound to a different direction like top, then the image is going to be displayed on the top relative to the text. What if we wanted to count the amount of times that we clicked this button? We could create a variable called count, and we'll set this equal to 0. But in order for us to access this count variable within the function of click, we're going to list count as global, so that this is a global variable. Every time we click this button, let's increment our variable count by 1 by saying count plus equals 1, and then we will print whatever the value of count is. So within a print statement, we'll just say count. Now, when we click on this button, we have access to our count variable that's outside of this function, and every time we click on this button, it's going to increase our count variable by 1. Well, everybody, that's the basics of creating buttons in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of buttons in Python. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create a simple entry box in Python. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright, my fellow bros, in this video we're going to be discussing the entry widget. This is a text box that accepts a single line of user input. As always, we'll need a window. Window equals tk followed by window.main loop. And let's give our entry box a unique name. Let's call this entry for short. And then to create this entry widget, we're going to follow this with equals entry. And within the constructor, we have to state what we're adding this to. We're going to add this to our window, and we should finish this by packing it or placing it. Entry.pack. And we should have an entry box within our window. However, the text is somewhat small, so let's change that. We can set this as an option within the constructor of our entry box. So let's set the font. Font equals, and pick whatever font you want. I'm going to pick maybe Arial, and then a size, maybe 50. And this should be a little bit larger. And we can type in some text like this. Cool, right? Now, we should add a submit button, because right now this currently doesn't do anything if we type some text in. So let's create a button. I'm going to create this button maybe after the entry box. And let's say that this is a submit button. So let's call this submit button equals button. What are we adding this to? We're adding this to our window. And we'll set some text. Text equals submit. We'll also need a command for this button. Command equals, and we'll create a function called submit. And we want to pack this submit button to add it to the window. Submit button.pack. All right, now let's put our entry box on the left-hand side and our submit button on the right-hand side. When you pack these widgets, you can set these on a certain side. Side equals left, and our submit button, we want this on the right. Not necessary, but I think it looks better. And we also need to define our submit function. Outside of the window, let's define what this does. def submit. What's this going to do? We need to get the current value that's within our entry box. One way in which we can do that is use the entry box's get function. This will return a string, and we can do something with that string, such as store this within a variable. So let's create a variable called maybe username. Let's pretend we're having a user submit their username to log into something, I suppose. So we'll get the current value of the entry box, store that within a variable, and we'll call this username, and then we will maybe print this for fun. Print hello plus user name. And let's try this. So here's our entry box here and our submit button. I'm just going to make up something. Click submit, and it displays our message. Hello, I didn't say that this video was going to be professional. Let's add a few other buttons. Let's say we want a delete button as well as a backspace button. So let's copy what we have for our submit button and create a delete button and then a backspace button. The delete button's a little bit easier to code. So let's rename our submit button as delete button. Make sure to change the name too when you pack this. And the text, we will say delete, and we'll create a function called delete. And let's define what delete does. So after our submit function, let's define our delete function. And we need to delete all of the text within our entry box. One way in which we can do that is to type in the name of our entry box, dot, delete function. And this takes two positional arguments. Which portion of our entry box do we want to delete? So we want the very first character, that is index 0, followed by the last character, and we can say end. So this will delete all of the characters within our entry box. And let's try it. So I'm just going to type in my name, bro. I'm going to delete this, and all of the text is now gone. Just like that. Let's create a backspace button. We'll copy what we have for our delete button and change the word delete to backspace. Make sure you change that when you pack this as well. And for the text, we'll set this to backspace. And we'll create a function called backspace. And let's define what backspace does. So after our delete function, let's define backspace. And this is going to do something very similar to our delete function, except we're going to change the first positional argument. We need to place the second to last character within this positional argument. One way in which we can do that is to first get the entire length of all of the characters within our entry box. So let's begin by typing entry.get. And we need to determine the length of this, and we can surround this by placing this within the length function. So this will return the current length of all of the characters within our entry box, and then we're going to add -1, so that this first positional argument is the second to last character, and the second positional argument is the end, the last character. And then when we run this, let's type in our name. I'm just going to type in bro code this time. I'm going to click backspace, and then it's only going to delete the last character. And then if you were to click delete, it deletes everything. Broy. And then if you click submit, it's going to submit your name. All right, let's customize the appearance of this entry box. So within the constructor for this entry box, let's change maybe the color, maybe the background color and the foreground color. Let's begin with the foreground color. You can pass in a color name or a hex value. I want this to be green, so the hex value for that is 00FF00. And the foreground color of the text when we type it in is now green. And we can also change the background color. That is BG. We could pass in a color name or a hex value. I'm just going to say black to keep it simple. And we now have a black background, and the text color is now green. Here's a few useful features that you might be interested in. Let's insert some default text for our entry box. So we can use the insert function. Entry.insert. We place a positional argument as well as some text. So for the positional argument, let's say 0. So that's the very beginning, index 0. And let's set the text to maybe SpongeBob. And then the default text within our entry box is now SpongeBob. Another option available to us is that we can set the state of this entry box. We can set this to active or disabled. Let's say that after somebody submits our name, we want to disable this entry box. So we can either pass in this option within our constructor, or we can use the config function to make any changes to the state of our entry box. So let's say after we submit our username, we want to disable this entry box. So let's type in the name of our entry box, .config. And for the option for state, let's set this to disabled. And then once we type in a name and then click submit, our entry box is now disabled. There's also an option called show, where you can show a certain character in place of the normal text on the screen. So this would be useful for a password. Let's say that we're typing in a password, but we don't want to display the password on the screen. We can use the show option to show a certain character in place of our text. So you might see bullets or an asterisk. So let's pretend that we're now typing in a password. So we're going to set the option for show and place a character that we want to replace each character with. Let's say we want to only display asterisks when we type in some characters. And I'm going to type in the word password, but it's only displaying asterisks now. But if I were to click submit, it displays our text in, I would say, plain text instead of our hidden text, because we're only showing whatever character that we set. So that's an option available to you as well. Well, everybody, that's how to create an entry box in Python. You can submit information such as a username, for example, or even a password if you set the show option available to you. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's some of the uses of the entry widget in Python. Hey, how's it going, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create and customize our own check buttons in Python. So sit back, relax, and enjoy the show. Alright, my fellow bros, in this video we're going to be creating and customizing our own check buttons in Python. I sometimes refer to these as checkboxes, so in case I do, that's what I'm referring to. As always, we'll need a window. Window equals tk followed by window.main loop. And let's call this button just check button. And in order to create this check button, we type in the name of the check button equals check button. And within the constructor, what are we adding this check button to? We're adding this to our window. And also within the constructor, we can set the different options for how we want to customize this check button. Let's begin with the text. Text equals I agree to something. And last but not least, we need to add this check button to the window. One way in which we can do that is to use the pack function of this widget. So follow this with checkButton.pack. When we run this, we have our check button within our window, and we can toggle this on or off. Right now I'm agreeing to something. I'm not sure what I'm agreeing to, but hopefully it's not anything bad. Now currently this doesn't do anything, so we'll need to associate a variable with this check button. So we'll add that as an option. Variable equals, and let's create a variable called x, and we'll need to define this within the window. So after we create our instance of our window, let's say x equals, now with check buttons, they store a 1 or a 0 by default within our variable that we call x. So with x, we're going to set this equal to a int var. If this were to return a string, we would say string var, but normally by default, this returns a 1 or a 0. And we can actually change that using the on value and off value options. So the on value is what's going to be stored within our variable if it's toggled on. So by default, this is 1, and the off value is the opposite. This is what is stored within our variable if this is toggled off. All right, now let's have some fun with this. So let's associate a command with this check button. Command equals, and let's create a function called maybe display. And then let's define this before the window. Def display. And we're going to check the value of x to see if it's 1 or 0. So within our display function, we're going to check to see if x, and to get the value of x, we're going to use the get function. So if x.get is equal to 1, that means that somebody clicked on the checkbox or toggled it on. So if they check the checkbox or check the check button, then they agree. So print you agree. If it's 0, and we can do this with an else statement, else print you don't agree, frowny face. And let's test this theory. So we have our check button. When we click on this, it's actually going to call our display function. I agree to something, and it says within our console window, you agree. And if I were to toggle this off, it says you don't agree. Let's change the font of our check button. So we'll add that as an option. Font equals, and we can pass in a font that we want. I'll say maybe Arial, and then a size of 20. And now this should be readable. I agree to something. Let's also color this because, well, I like coloring. Let's begin with the foreground color. So that is FG for short. FG equals, and then we can pass in a color name or a hex value. I like hex values, so I'm going to stick with those. I want a green foreground color, so that is 00FF00. But feel free to adjust these values however you want. So our text should now be green. That is a very bright green and it hurts my eyes. So I'm also going to change the background color, which is BG, and I'm going to set this to black. So we'll have green text on a black background. Okay, now when you click on this, it flashes. That's kind of annoying. That's the active foreground and active background. If we click on this or hold this down, the color scheme switches to our active foreground / background. And we can change those too. So I'm going to set those options. Active, foreground. I'm going to set this the same as my foreground color. And the active background will be the same as our normal background. So that's active, background equals black. And this should no longer flash when we click on it. Not too bad, not too bad. Let's add some padding. Pad X, I'll set this to 25. And pad Y, I'll set this to 10. We have a little more padding around our check button. One feature that's available to us is that we can add an image next to our check button. I downloaded an image of the Python logo that I want to add. So we'll use the image option to add a photo image to this check button. But first, we need to create a photo image from our image file. So within the window, let's call this Python photo, but you'll probably use something different for your project. Python photo equals photo image, and within the constructor for our photo image, we can set the file path or the file name. Since this image is within my project folder, I only have to list the file name, and this photo of mine is python.png. And now we set the image equal to our photo image that we have. Image equals Python photo, but when we run this, it's going to overlap the text. We still have our image though, and this still works as intended. So in order to display the image as well as the text, we're going to need to use the compound option, and let's add that at the end. Compound is where we're adding this photo relative to the text. I want this photo on the left-hand side of the text, so I'm going to set this to left. And now when we run this, surprise, surprise, our image is on the left-hand side. One thing that you should know is that with the on value and the off value data type, if you were to change this to a non-integer value, let's say we're going to replace the on value with a Boolean value of true, and the off value is false. With this variable, make sure to change the data type as well to reflect what you're storing within it. So with our int var variable, we want to change this to a Boolean var value. So replace int with Boolean, and this will work much the same. Now with this display function, we'll need to account for that. So within the if statement here, we'll say if x.get. We don't need to say is equal to 1. This will return true or false, and this will work just the same as it did before. And if you replace this with a string, let's say the on value is yes, all caps, and the off value is no. This is now a string var, and we'll change our display function to say if x.get is equal to yes. And this should work. You agree, you don't agree, you agree, you don't agree. And I'll change that back to 1. So 1 and 0 is the default for this, but you can edit these based on what you need. Alright, so that's the basics of check buttons in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of check buttons in Python. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to be teaching you guys how we can create radio buttons in Python. So sit back, relax, and enjoy the show. Okay everybody, let's create some radio buttons. Now these are similar to checkboxes, but you can only select one from any single grouping. So let's pretend that I'm buying you lunch, and you can only select one item from a menu. You can select either a slice of pizza, a hamburger, or a hot dog. So let's begin by creating a list. I will call this list food. Food equals pizza, hamburger, hot dog. And let's create a window. Window equals tk, followed by window.mainLoop. So to create a radio button, we'll need a name. So I'll call this radio button. Radio button equals radio button. And we're going to be adding this to our window. And we're going to put this within a for loop. So we're going to iterate through all of the items within our list. So let's create a for loop. So we'll say for index in range length of food. So this is going to iterate once through all of the elements within our list. So when we run this, it's going to create 3 radio buttons for us because we're instantiating one radio button for each item in the list. Now what I'm going to do is set the text equal to our list of food at a certain index. So when we first run this for loop, it's going to be 0 for the index, then 1, and then 2, and then so on and so forth for each item within our list. And then we just need to pack this. So radio button dot pack. And then let's take a look at this. All right, so here are all of the radio buttons that we have. Currently, they're all selected though, so we'll need to link these within a single grouping. The next thing we'll add is a variable, and we'll set this equal to x, and we'll need to declare this after we create an instance of our window. So x equals int var. So this will hold an integer object. So these are all within the same grouping. However, if we try to run this again and select one of these options, they all become selected. So we're going to need to give each of these individual radio buttons their own value because right now they're all sharing the same value. So we can add value equals whatever the index is currently. So the first item within our list of food is going to have an index value of 0, then 1, then 2. So let's try that again. And you can see by default it's 0, so pizza is already selected. Then we can select either hamburger or hot dog, but we can only select one. So that's kind of what we want then. So do you guys usually know how I call the config function after each change that I make for an object? Well, that's because I like to add comments just for teaching purposes for what each change does. However, it might be easier for you, instead of calling the config function a bunch of times, just to list all of the changes within the parentheses when you create an instance of the object that you're working with. However, just for teaching purposes, I'm going to put this all within separate lines. That allows me to add some comments. So I think I'm going to start doing that from now on. So what this does is that this adds text to radio buttons. And this groups radio buttons together if they share the same variable. So if you wanted a completely different grouping of radio buttons, you can give them a different variable like y. And what this line does is that this assigns each radio button a different value. All right, so let's make some cosmetic changes to our radio buttons. So right now, they are centered. Let's anchor these to the west. So we'll place this within the pack function. So anchor equals W. Alternatively, you can just say capital W without the quotes. This would also work too. So now they're all lined up. Let's add some padding. So I'm going to add pad X, and I'll set this to 25. And this adds padding on X axis. Let's also change the font. So we'll say font equals, maybe I'll pick impact for a font style, and set the font size to 50. And now we can actually read these because the font is large enough. Now let's add some images. So let's create some photo images. You'll want to be sure to create these after you create your instance of your window. So let's create a pizza image first. Pizza image equals photo image, file equals the file path or the file name, and my file is pizza.png, and it kind of looks like this. It's just the pizza emoji. So pizza.png. And then I'll do the same thing for hamburger and hot dog. So this will be hamburger image, file equals hamburger.png, and then hot dog image. And this is what the other emojis look like. And then let's create a list of the photo images that we have. I'll call this food images equals, then the names of these images, pizza image, hamburger image, and hot dog image. So then we can set the image for each radio button. Image equals the name of the list, food images, followed by the index that we're currently on within our for loop. So this adds image to radio button. And let's test this. Cool. Here's our images. Now, if you want some images as well as text, you'll have to use compound. So let's add that next. So I'm just going to add a comma followed by compound equals, let's say left. So this will add the image to the left of the text. Adds image and text. I'll just say left side. So this will display both an image and text. So with these radio buttons, you can eliminate these circle indicators, and there's actually a way to do that. So what we'll add, if you want to get rid of those, is indicator on equals 0. So this will I should say eliminate circle indicators. So it's going to change these to these push buttons. However, they are going to be of uneven size. You can set the width if you want to. So we'll do that. So we'll say width equals, what about 75? I'm not sure if that's a good size or not. Okay, that's way too small. Let's try 375. So yeah, you can have some push buttons if you want to, if you don't like the circle indicators. So this sets width of radio buttons. Now let's actually set a function to be called when we click one of these buttons. So let's call this function maybe order, like we're ordering one of these items. So def, we'll call this order, like we're ordering something. And what we'll do is just a few if statements because I'm feeling lazy. So we'll just say if x, that's the value that's going to be stored, because each of these radio buttons is grouped together by the variable x. If x dot get is equal to 0, that's our first index for pizza. What we'll display is print you ordered pizza. Then we'll just add else if x.get is equal to 1, we will print you ordered a hamburger. And then else if 2, you ordered a hot dog. Else print So there's probably a more efficient way to write this. However, I was just feeling lazy, and this is probably the best way to keep this simple and easy to understand. So let's try this now. Oh, however, we need to set the command for our radio buttons. So command equals then the function name, which is order. And make sure you do not add the parentheses. So don't do this, do that. And this will set command of radio button to function. All right, let's test this. So if we click on pizza, it says you ordered pizza, you ordered a hamburger, and you ordered a hot dog. Okay, everybody, so that's the basics of radio buttons. If you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of radio buttons in Python. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create a sliding scale in Python. So sit back, relax, and enjoy the show. Let's create a scale. So we'll need a window. Window equals tk, followed by window.main_loop. We'll create a scale called scale. Scale equals scale. We need to add the scale to our window, so we'll put that here. We can list a from position and a to position. Both of these values will be our range of values that we can use for our scale. So from, make sure to add an underscore after from. It won't work without this underscore. From equals, let's say 0, and to equals 100. So we're going to create a scale for temperature, and this will be in Celsius. So 0 will be freezing and 100 will be the boiling point, for water. So then to display the scale, we'll need to add scale.pack. And let's run this. So the from position is 0, so that's at the top here. And then if you go down, it increases. So you can actually flip this. So we'll say from 100 and 2 will be 0. So now you can scroll up and the number will increase. Let's also get the current value. So we'll need a button. So button equals button. We'll add this to the window. We'll add some text. Text equals submit. and then a command. Command equals submit, but we'll have to make this function. So let's do that outside the window. def submit, and we will simply print the current temperature. So let's display a message. The temperature is plus scale dot get plus degrees Celsius. We can just say degrees C. So let's try this, but we also have to pack the button. So button dot pack. So if we were to try and submit this, right now scale.get is going to return an integer, so we need to convert this to a string. So str scale.get, and you have to do that with Python if you're displaying a integer value along with another string. You need to convert it to a string. So now this should work. So it is 82 degrees Celsius. So let's do some cosmetic changes for our temperature gauge, because right now it's kind of ugly. So the first thing we'll change is, let's say the length. So length equals 600. So that should be fairly large. You can also set the orientation. So that is orient, spelt like that. So this can either be vertical, which it currently is, or horizontal. But I'll keep this as vertical. So I'll add a comment that this is orientation of scale. Let's also change the font. So font equals, pick whatever font you want, and a size. So maybe 20. Now you can add some tick intervals. Maybe I'll set this to 10. So these will be numeric indicators on the scale. And show value, this hides the current value. So if you set this to 0, this will hide current value. So it no longer displays what the current value is next to the slider. To actually retrieve it, you'd have to get the value. So right now it's 40, but it helps that you have the tick intervals on the left-hand side. I should probably add that this adds numeric indicators for value. Good enough. Let's continue on. Now let's use the set function. We can set the current value of the knob on our scale, and by default it is 0. So we can use the scale.set function, and we can place a number in here, a value. So let's say we want this to be 100. So this is now at the 100 position instead of 0. If we wanted this in the middle, we could set this to 50. And now it's in the middle. However, if you change the range of your scale from -2 and set this to 50, now 50 is all the way down here, so it no longer appears in the middle. So this isn't really necessary, but if you want this to be a little more sophisticated, there's actually a formula that you could use. We can use scale, straight braces, and then place the word from within here. This will give us our max, basically. So this is from without an underscore. So this, not this, this. Scale from minus scale to. And then we're going to divide this by 2. And then I'm just going to put this within a extra set of parentheses. Plus scale to, just in case our 2 value is greater than 0. We just want to account for that. And then I'm just going to put these within another set of parentheses. So this should always appear in the middle then, even if we were to change this range. Yeah, it seems like it works. Like I said, it's not really necessary, but if you want this to be a little more sophisticated, that would work.
Now let's make some cosmetic changes to this scale and make it look pretty. So first, let's change the trough color. This is this gray portion right here. So let's set the trough color equals whatever color you want. You could say like blue, or you can place a hex value here. And I actually picked one out already. So I'm going to use 69EAFF. And that is this icy blue color, kind of like this is sliding on ice. And I'm also going to change the font color. And I'm going to pick this fiery red color to symbolize heat. And then you can change the background color too. So that is BG. And I'll just set this to like black. It's looking kind of cool now, right? And for no good reason, I'm going to add some pictures. So feel free to pause the video if you'd like to download some images. I'm going to use an image of a flame for the hot side of our scale and a snowflake for the cold side. So let's begin by adding the hot image to the scale before we actually add the scale to the window. So we'll do this after we instantiate the window because that's the only place that we can do that. So we're going to create a image. I'll just call this hot image for the fire icon. So hot image equals photo image file equals, this is hot.png. So hot.png. We're going to add the image to a label. I'll call this hot label. Hot label, label, image equals hot image. And then we need to pack this. So hot label dot pack. And this should appear at the top. Let's test it. Yep, there it is. Let's do the same thing for the cold side. So I'll add this here before the button. And I'm going to replace hot with cold. Same thing with the file name, cold.png. This will be cold label, cold image, and cold label.pack. And that should be it. Let's take a look. Not too shabby. It's looking pretty sweet. It has our submit button at the bottom too. So right now the temperature is 100 degrees Celsius. The temperature is 0 degrees Celsius. The temperature is 60 degrees Celsius. Well, that's how to create a scale in Python. If you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how to create a scale in Python. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create a list box in Python. So sit back, relax, and enjoy the show. Alright, you wonderful people, let's create a list box. A list box is a listing of selectable text items within its own container. So as always, we'll need a window. Window equals tk, followed by window.main loop. Let's create a list box simply called list box. Big surprise there, right? So list box equals list box. What are we adding this list box to? We're going to place that here within the parentheses of the constructor. We're adding this to our window. And then we're going to follow this with listbox.pack. You can also do listbox.place as well and place some coordinates, but we've always done pack. Let's just stick with that for now. All right, so this is what our list box looks like. It's a small rectangular box, and we're going to add some text items that are selectable, and eventually we'll be able to submit a choice. So I have an idea. Let's create an online menu like we're ordering food from a restaurant. Let's say it's Bro's Italian restaurant. So let's add some food items to our menu and somebody can submit an order. So we'll need to use the insert function of the list box to add some items. So listbox.insert. We place an index and a text item. So let's say for index 1, we'll have pizza. And this is what we end up with. We have the item pizza, it's selectable, and well, that's really it. We'll need to create a submit button and populate the rest of this list box. So let's add a few other items for our menu. So let's say we'll have 5 items. And we need an index for each. So 1, 2, 3, 4, and 5. So we have pizza for the first item. For the second item, let's have pasta. And third, let's say garlic bread because garlic bread is awesome. And restaurants usually have appetizers, so why not soup and salad? And that should be enough for this example. And this is what we have. We have our menu, and we can select an item from this menu. So let's customize the appearance of this menu, well, because we can. So let's do that. Let's change the background color. So we do that with the option BG for background, and you can set this equal to a color of your choice or a hex value. So I have a hex color value already picked out. It is F7FFDE, and this has the appearance of, I would say, paper, like it's kind of faded. I think that would fit some sort of menu for a restaurant, but pick whatever background color you want. So let's change the font next. So we can do that with the option font, and I will pick the font Constantia. It's somewhat fancy. I think it would fit like a restaurant menu. And then a size of 35. Yeah, we're getting somewhere. We can also change the width and the height. So width equals, let's say 12. That's not too bad for a width. Let's also change the height. So we can do that with a function of our list box. So let's get the current size of the list box, and let's actually do that after we insert all of the items within our list box. So to change the size of our list box, what we do is type in listbox.config. You usually use config if you need to change any options. And we want to change the length of, or the height of this list box. So we're going to say height equals listbox dot size function. So then this will adjust the size of our list box dynamically. Even if we were to remove an item, then the size of our list box is going to shrink. Just like that. But let's keep salad in there for now because we need salad. All right, so how do we actually submit one of these options? We'll need to create a submit button. So let's do that after we create our list box. So near the bottom, we'll call this submit button. Submit button equals button. We're adding this to our window. Let's set the text to submit, and we'll need a command. So we'll create a function called submit. And then we need to pack this submit button. Submit button.pack. Now at the top of this program, let's create a submit function. So at the top, def submit. So to retrieve or get the current selected item of a list box, there is a certain function that you can use. So we'll begin by saying listbox.get. What are we getting? We want to get anything that is currently selected, and there is a function for that. So what we're going to do within the parentheses of the get function is type in listbox.current selection. It's shortened to CUR selection. All right, and then we can either store this within a variable or we can just print this, but I think we'll just print this to keep it simple. Now, when we select an item and click on the submit button, it's going to submit our order. Actually, better yet, let's actually print you have ordered whatever item that we select. So garlic bread. You have ordered garlic bread. Cool. What we're going to work on now is a way to submit or insert an item to our list box after this program is compiled and already running. So we'll create an entry box within our window where we can submit a custom item to this menu. So let's create an entry box, and let's do that before the submit button. That would be a good spot for this. So let's call this entry box where somebody can type in something to add to the menu. So entry box equals entry, and we're adding this to our window, and then entry box dot pack. Then we're going to create a button called add, and I'm just going to copy everything from the submit button, and we'll change submit to add. We're going to add an item to the menu.
So we'll change the text to add and command add button dot pack. Then we're going to create a function called add, and we'll do that at the top. Def add parentheses colon. So to add an item to the list box, first we need to get what is currently in the entry box. So we can do that by typing in listbox.insert. Then within the parentheses, we need to get an index number as well as a text item. So for the number, what we can type here is the listbox.size. So this will give us the current position of the index that we're currently on for the list box. And then we need to get the text in the entry box. So we type in the name of the entry box dot.get. And this will insert a new item within our menu, our list box. So let's try it again. So we can type in an item, let's say soda. We want to add soda to the menu, and then we click add. All right, there's our soda, but we have to scroll down to see it. So let's change the size of our list box. So there's actually a line of code that we did that already. Listbox.config height equals listbox size. So let's add that within the add function at the very end. So then the height of our list box will adjust. So currently there's no soda within our menu. Let's type in soda or some other item, click add, and then that item will appear and the size of the list box will change to accommodate any new items. Let's say now that we serve sushi, we're now an Italian and Japanese restaurant. Now we have sushi on the menu. You know what? Why stop there? Let's create a delete button to delete an item from this menu. So we'll create a delete button. I'll just copy everything for add and change this to delete. So delete button, text equals delete, command equals delete as well, and delete button dot pack. And then at the very top, we'll create a delete function. So we'll do that here. Def delete. And to delete an item from a list box, there's actually a function to do that. So listbox.delete. And then within the parentheses of the delete function, we can pass in listbox.currentSelection, or just CUR selection for short. And then we want to readjust the height of this list box after we delete an item. So we'll just add listbox.config height equals listbox.size, because the size of all the items within the list box is going to shrink after we delete an item. So let's try this. So here's our menu. Let's say we no longer want salad because salad is healthy. Well, we can delete it. Same thing with soup. And you know what? Let's also delete the pasta and the pizza. So we're only left with sweet garlic bread. Well, ladies and gentlemen, we're going to get into some more advanced stuff with list boxes. What if you want to select more than one item from this list box? We're going to need to change a few things. So when we create our list box, there is a select mode, and we are going to set this equal to multiple. So now we can actually select multiple items from this list box. Like, I want to select one of everything, but what happens when we submit this? Well, we're going to run into some problems, so we're going to need to change this program around. So let's begin with the submit option. So what we're going to do within the submit option is first get rid of this line. Let's say we no longer need this anymore. And then before we print out the items that we ordered, let's create a list called food. And we'll just leave this empty for now, and we'll fill this later. So we'll create a for loop for index in listbox.currentSelection. What we're going to do after each iteration, food.insert our index number, as well as listbox.get the item name at this index. What this for loop is doing is that it's going to iterate once for each item that we select. So since we have 3 items that are currently selected, this is going to iterate 3 times,
get the index number as well as the item at that index number. And now we just need to display the contents of what we have within our list of food. So we can do that with another for loop. So let's add that after you have ordered, then for index in our list food. All we'll do is print index. So this will print out everything that we ordered. So let's say that we want one of everything and submit this. You have ordered pizza, pasta, garlic bread, soup, and salad. Now, what happens if we try to delete multiple items? So let's say we want to delete soup and salad, and we click delete. Well, we're going to run into an error because our function is not set up to accommodate for multiple items. So we'll need to change a few things around. So let's get rid of this line for now, listbox.delete, listbox.currentSelection, and we're going to place a for loop here. So for index in listbox.currentSelection. Then after each iteration, what we're going to do is use listbox.delete, and we're deleting the item at whatever index we're currently on. So you would think this would work at first glance. Let's say we want to delete pizza and pasta. We're going to click delete. So pizza was deleted, but not pasta. That's because the indexes are changing after we delete an item. So when we use this for loop, we should actually reverse this. So with listbox.currentSelection, we are going to enclose this with reversed. So then we're going to start at the last index and work our way to 0 in that order. So now if we want to delete pizza and pasta, I don't know why we would because they're amazing, and we click delete, it deletes pizza and pasta, but we still have garlic bread, soup, and salad. Then we can add an item. Let's say we want to add sushi again to the menu. We can do that, and then we can order one of everything because we're really hungry. You have ordered garlic bread, soup, salad, and sushi. So that's the basics of creating a list box in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of list boxes in Python. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create message boxes in Python. So sit back, relax, and enjoy the show. Okay, people, let's create some message boxes, but first we'll need an import. So from tkinter, import message box. And what this will do is import the message box library. So it's not necessary to add this comment. So we'll need a window. Window equals tk, followed by window.main loop. Let's create a button. So button equals button. We're going to add this to the window. We're going to set the command to execute a click function that will have a message box appear when we click on the button. And let's set the text. So text equals click me. And then we will need to pack this button. So button.pack. Now we'll need to create a click function. So let's do that at the top. def click. And what do we want to do? So there's a few different message dialog boxes that you can use. So let's begin with a basic show info message box. So message box dot, and there's a few options. Let's begin with show info. Show info. This just displays a simple message. So if we were to run this, we have a button, we click on the button, and it's going to create a message box for us. And it just shows some info, but we don't really have any info to show yet. So we can set a title, and we can set a message. So let's set the title. Title equals, this is an info message box. Although part of the title got cut off. Let's also set the message. Message equals, you are a person. Click me. You are a person. Thanks, I didn't know that. So there's a few other message boxes that we can use too. So for now, I'm just going to turn this into a comment. And I'll just copy this just to save some time. And the next one that we have
is show warning. So this will have a different icon. So the title, let's say warning, and the message, you have a virus. So now we get this annoying warning message, but you can just click OK to get rid of it. So one thing that you might see with tech support scams, they'll have a message box like this that shows a warning, but they'll put this within a while loop that's set to true. So this will just continue on and on. Kind of like this. So if we were to try and close out of this, it's just going to reappear. While true is true, basically. So that's just something funny that I wanted to show you. So let's move on. I'm going to turn this into a comment. Then the next one we have is show error. So show error. Title, set it to whatever you want. Error. Message, something went wrong. There's a few more sophisticated ones too. We can ask for some user input. So this next one is message box dot ask, and there's a few to choose from. Let's go with ask okay cancel first. We'll set the title. Title equals ask okay cancel, and a message. Message. Do you want to do the thing? So we can actually put this within an if statement. So this returns either true or false depending on what you click. So let's put this within an if statement. If this is true, print, you did a thing. If it returns false, we can use an else statement. Else, what else do we want to do? We'll say else print, you canceled a thing. And let's test this. But I am forgetting a colon. There. Do you want to do the thing? Okay. You did a thing. Let's try it again. Do you want to do the thing? Cancel. You canceled a thing. Cool. There's a few others. So I'll turn all of these into comments. And the next one we can go over is ask, retry, cancel. And this is fairly similar to what we had before. I'm going to copy this. Let's change this to ask, retry, cancel. Ask, retry, cancel. Do you want to retry the thing? You retried a thing, or you canceled a thing. So it's very similar to what we had before. Do you want to retry the thing? Retry. You retried a thing. And cancel. You canceled a thing. Okay, the next one we have is ask yes, no. So we can get some user input if it's a yes or a no. So this returns a Boolean value, a true or false value. So message box dot ask yes, no. And we'll set the title. Title equals ask yes or no. And a message. Do you like cake? So let's put this within an if statement, because this returns a true or false answer. Print, I like cake too. Else, they answered no then if this is false. Print, why do you not like cake? and I'm missing a colon. There we go. So if they click yes, this returns true, and we execute this line of code, I like cake too. If they answer no, it's going to execute this else statement. Do you like cake? No. Why do you not like cake? Now, what we have next is ask question, and this doesn't return a Boolean value of true or false. It actually returns a string of yes or no. So this is message box dot ask question, and we'll set the title to ask question and a message. Message equals do you like pie? So let's just print the result, what this returns. So print everything within here. So like I said, this doesn't return true or false, but yes or no. So what we could do is assign the response to a variable such as answer. So answer equals whatever the answer is, whatever they click, whatever button they click on. So if our answer is equal to yes, we'll print a message, print I like pie too. Then else, the answer is no. We'll print why do you not like pie? So do you like pie? Yes, I like pie too. Do you like pie? No. Why do you not like pie? So this next one is probably the most difficult. It's ask yes, no, cancel. So it's message box dot ask yes, no, cancel. It's this last one. So let's set the title. Title equals whatever you want. Yes, no, cancel. And a message. Message equals do you like to code? So let's just print the results, what this returns. So print everything, just so we can take a look. So the possible answers are true, false, or none. So we can just run some if statements for this. So if answer is equal to true, what we can do is print you like to code. Oh, but we need to assign this to an answer. So answer equals all of this. Else if answer is equal to false. Let's print. Then why are you watching a video on coding? And then else, the response is none. So we can just use an else statement. So else, you have dodged the question. Okay, let's try this. Do you like to code? Yes, you like to code. But this should really be a smiley face, right? Do you like to code? No. Then why are you watching a video on coding? Do you like to code? Cancel. You have dodged the question. Now, one other option available to you is that you can change the icon that you're using. So let's say that we want to change this icon. So right now it is currently this question mark. So we can set this to one of a few preset icons. So icon equals, and let's set this to warning. So instead of that question mark, we get this yellow exclamation point, and you can also use info. It's just an I, and error. So do what fits best for you. All right, well, that's the basics on message boxes in Python. If you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of message boxes in Python. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys about the color chooser module in Python. So sit back, relax, and enjoy the show. Okay, everybody. So before we begin, we'll need a second import. So let's add this at the top. So from tkinter import color chooser. And the reason that we need a second import, and it's not included with this first import, is because this is a sub module. It's not necessary to add this comment. I just like to add comments for teaching purposes. So make sure you have these two imports before we begin. Now we'll need a window and a button that we can add to the window. And when we click on the button, we're going to select a color and change the background color of the window. So let's create a window. Window equals tk followed by window.main loop. And then let's set the geometry. So we're going to change the background color of the window after we select a color. So let's select a fairly large size for a window, maybe 420 by 420. So this is the width and the height. And then let's create a button. So button equals button. Let's set some text. Text equals click me. And we're going to set a command for this button that is called. So we're going to create a function maybe called click. And then we just need to pack this button so we can add this to the window. So button.pack. Now we're going to need to create a function and we'll call it click. So when we click on the button, this function is going to be called. So def click. And what do we want to do after clicking this button? What we're going to do is take color chooser and we're going to use the ask color function. So currently this is what this does. We can select a color after clicking this button and pick whatever color you want. Then you hit OK. However, we need to store this color within, let's say, a variable. So we'll create a variable called color. Color equals colorchooser.askColor. And then we can do something with this color. But for now, let's just print this color just to take a look to see what it contains. So print color. So let's say that I want this green color. Click OK. This is what this prints. This is our color. So this is the RGB values that we have in this first element. So this is the amount of red, then green, and then blue. And the second element is the hexadecimal representation of these values. So what we want is this hexadecimal value. So what we could do is create a second variable to store this. So let's just call this color hex. Color hex equals color, and we're going to get the first element. Well, technically it's the second element, but it's the element at position 1. So this one. This is 0, index 0. So we're going to basically extract this hexadecimal value, and let's just print this just to be sure that it's working fine. So print color hex. And let's try this again, but select a different color. Maybe I want this purple color. Then click OK. So this is CB4 to FF, and here we have CB4 to FF. Now let's change the background color. So since we have this hex value, that's actually fairly simple. So we're going to take window.config bg for background color equals color hex. And this will change background color. And let's set this to a sky blue color. Maybe like this. Click OK, and it changes the color. However, it's not really necessary to continue printing these values. You can take these out if you want. And this would work like just the same then. Now, this part isn't necessary, but if you want, you can condense these 3 lines of code that we have for our click function into less lines of code. So what you could do, instead of assigning the value of color at index 1 to a separate variable, we can take color at index 1, get rid of this line, and assign bg equals color at index 1. So now this is done with just 2 lines of code. And why stop there? We can write this with just 1 line of code. So now we're going to take colorchooser.askColor, get rid of this line, bg equals color chooser dot ask color at index 1. And now this is done with just one line of code. However, it's I would say a little more difficult to teach. So that's why I kind of like to separate this line by line. So if you want, you can condense all of this into just one line of code. So here's some ideas of where the color chooser submodule could be helpful. So of course you can change the background color too, but let's say that you're creating a game and you can customize your character or avatar. Well, it would be kind of nice if you could have some way for the user to actually change maybe the character's hair color, eye color. Something like this would actually work fairly well. So yeah, that's the basics of Color Chooser. If you would like a copy of all this code, I'll post this in the comments down below. But that's the basics of Color Chooser in Python. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create a text area in Python. So sit back, relax, and enjoy the show. Alright, my fellow bros, let's discuss the text widget. This functions like a text area. You can enter multiple lines of text. I'm not sure why it's called a text widget instead of a text area widget. Text area would make more sense, but IDK though. So let's begin by creating a window. Window equals tk, followed by window.main loop. So to create a text widget, also known as a text area, let's call this text. Text equals text. And we're going to add this text to our window, and then we need to pack this text. Text.pack. So we should have a text area, and you can enter in stuff like this. Alright, but what good is a text area if you can't actually submit some text? So let's create a button to do that for us. So button equals button. We're going to add this button to the window, and button dot pack. So we need a command for this button and a function as well. So let's create a function called submit. It's going to be a submit button. And let's change the text too, because we can. Text equals submit. Cool. Now let's create a function called submit, and we'll do this at the top. def submit. And what is this going to do? Well, it's going to get the text from the text area. And let's assign this to a variable, and we can call this maybe input or whatever you want. So to get the text from the text area, let's say text, that's the name of this text area, dot get. But we need a starting index as well as an ending index. So we're going to place 1.0 here for the beginning index. This is the first line. We want to get everything. So for the second index, we can just put end. Then we can do anything we want with this input. So let's just print this to the console window. So print input, and this should work. Hey you, drink plenty of water. Love you. And click submit. And then you can do whatever you want with this input. Well, that's how a text area functions, but now let's customize the appearance of this text area, and I have a few ideas that you might be interested in. So let's change the background color of this text area. So bg equals, and I will pick light yellow, and you will see why in just a second. So now this text area kind of resembles maybe a piece of paper, a notebook, a post-it note. However, this font is really small. So let's change the font styling and the font size. So font equals, and I will pick the font ink free. This somewhat resembles handwriting, so I kind of like this, and it kind of fits our notebook theme. And then a size, maybe 25. One thing you should know, the text area size corresponds directly with the font size. So 25 is a fairly large font. So if we were to compile this and run this, the size of our text area is now massive because it corresponds directly with the font size. So we might want to limit the width and the height. So the height
is the amount of characters that this is tall. So let's say 8. And the width is the amount of characters that this is long. And let's say 20. And now this should be much smaller. And it kind of resembles a post-it note, which is kind of cool. Let's also change the amount of padding that we have. We can do that with pad X and pad Y. So pad X, let's say 20. And pad Y, also 20. So the text shouldn't actually touch any of the borders. This is some sample text. Cool. Let's finish this by changing the font color. So that is FG for foreground. Foreground equals, and I'll pick purple because purple is a pretty color. And let's run this one last time. Roses are red. Violets are blue. Booty, 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 booty. Rockin' everywhere. Well, that's the basics of the text widget in Python. If you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of the text widget in Python. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can use file dialog in Python to open and read the contents of a file. So sit back, relax, and enjoy the show. Okay, people, so this is how you can use file dialog to open and read the contents of a file. But first, we'll need a second import along with this import at the top. So what we're going to be importing is from tkinter import file dialog. And then we'll need a window like what we usually do. So window equals tk followed by window.main loop. Now we'll need a button that we're going to add to the window, and when we click on this button, it's going to launch our file dialog so we can select a file. So we'll call this button equals button. Let's set some text, maybe to just open, like we're opening a file, and we'll associate a function to our command for this button. So let's create a function called open file. That's fine. And then we need to pack this button so we can add it to the screen. So button.pack. Now we need to create a function called open file, and we'll do this before we create our window. Let's type def open file. And when we call this function, we're going to take file dialog and use the ask open file name function. So this is going to return a string, and that string is the file path of where your file is located. So what we could do is store this within a variable. So let's store this within a variable called file path. And to test this, let's just print this, just to take a look at the contents of this variable. So let's just print the file path. Now I have a file on my desktop that I want to use called test file. So let's click the open button. And this might not necessarily bring you to your desktop. It might bring you someplace else within your file directory. So this just happens to bring me to my desktop. So I'm going to click the test file that I have and click open. So this prints the file path. So it's going to return a string, and it's the file path basically. So now we want to open and read the contents of this file. So we don't really need this print line anymore. So what we'll do is create a file variable, and we're going to use open. We're going to list the file path, and then we're going to use R for read. So the default is normally RT for read text. Otherwise you can read binary, but we can just set this to R. R is the same as RT basically. So then we're going to open this file, and then we're going to read it. So let's just print this to the console window. So print the name of the file, which is file, where this is located, file.read function. And then it's a good idea to close your files after you're done with them. So file.close. And let's test this. So I'm going to click open, find the file that I want, click it, and then open. And that text file says, my name is bro, I like pizza.
Now, let's say you want to make this a little more advanced. So what I'm going to do is that I'm going to set the initial directory of where we begin looking for a file when we launch our file dialog. So with that test file, I'm going to move this to my project folder. So I'm just going to paste it. So now this is within my project folder. Now I'm going to set the initial directory within the function of ask open file name. So we're going to set the initial dir for initial directory, and then we can list a file path. So one thing you could do, I want to get this path here, this file path. So if you're using PyCharm, what you could do is right click this, copy path, and then get the absolute path. And then I'm just going to paste this. And then with these backslashes, you'll have to do double backslashes because this is the escape character for a backslash. All right, so this should open my project folder, which it does. And here's that test file. Another thing we could do is that we can change the title of our file dialog. Right now, the default is just open, so we can change that to something else. So I'm going to add a comma, maybe put this on a different line. So this is still within the function of ask open file name. So I'm going to set the title to something else. I'll say open file. Okay. So if we were to run this again, instead of just saying open, it says open file, okay? And we can also limit the file types that we accept and look for. So we can use file types. So let's say that we want to initially look for a txt file. So what we'll do is type in like a name for the file that we're looking for. So this is what's going to appear to the user. Text files followed by an extension. So we want *.txt. And then we can also have an option for all files. So I'm going to add a comma for a second option. And then let's say all files. And then an extension. So comma *.*. This will look for all files, but I think I am missing a parenthesis. There, that should be good. So then when we open our file dialog, it's going to initially be looking for plain text files, and with this drop-down menu, it says text files and all files. So that's what we have listed within our file types of what we want to search for. So you can see that if I switch to all files, our Python file actually appears because we don't have any limits on the files that we're trying to open or search for. So if I change this back to text files, only folders and plain text files are visible. So then we can open our test file again. But yeah, that's the basics of file dialog. In the next video, we're going to be saving a file. So if you'd like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of opening a file using Python. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can use Python's file dialog to save a file someplace on your computer. So sit back, relax, and enjoy the show. Okay, everybody, so this is how we can save a file. We're going to be reusing file dialog again, kind of like what we did with the video on opening and reading a file. So from tkinter, import file dialog. We're going to be creating a window and adding a button as well as a text area to this window. So let's create our window. Window equals tk, followed by window.main loop. Let's create a button. So button equals button. Let's set the text of the button. So text equals save. It's going to be a save button. And then a command. So we'll need to link a function to this command. So let's create a save file function. And then we need to pack this button. So button.pack. Now let's create a text area. This is just called text. So text equals text. We're going to add this to the window. And we need to pack this text. So text.pack. And now let's create a save file function. So at the top of our program, def save file. And then we're going to take file dialog and use the ask save as file function, and we're going to store the contents within file. File equals file dialog.ask save as file. Let's run this just to test it out. So we have our window, a save button, and this is our text area. We can type in multiple lines of text. Yay! And let's try and save this just to see what we have so far. So this will bring me to my desktop. It might bring you someplace else for your computer. So I'm just going to save this as test file. Now with this drop-down menu, save as type, there's nothing set up, so we'll need to do that manually. If we were to save this, and here's that test file on my desktop. So let's take a look at the properties. We did not list a file extension, so the type of file just says file. So we'll get to that later on in this video. And if we were to open this with a program like Notepad, well, it's currently empty. That's because we need to write some text to this file. So let's do that next. Let's store all of the text from our text area to a variable. Let's call this variable file text. File text equals, and then we need to get all of the text from our text area. So text.get, and we're going to list the starting index as well as the ending index for this function. So we're going to begin at 1.0. That is the beginning of this text area, and the ending, we can just put end. And then we need to convert all of this into a string. So let's surround this with str. And then we can store all of the text from our text area within this variable file text. And now we just need to write our text to this file. So file.write. And we're going to pass in file text. And then it's a good idea to close your files when you're done using them. So file.close. And let's try this again. Hello, my name is Bro. Let's save this. I'll call this hello and click save. And we still can't save as type, so we'll work on that next. Let's go to my desktop. Here's that test file that we created. I'm going to open this with Notepad, and it has all of the text that we added to that text area. Now let's list some available file extensions that we can have the user save this file as. So let's begin by setting the default extension. So default extension, and let's set this to a text file that is .txt. And then we can list all of the available file types. So file types, and we're going to place these within a set of straight brackets, and I'll just separate these line by line. So let's begin with a plain text file. So this will take two strings. The first is the message that will appear within that save as type drop-down menu. So let's place text file, and the second string, the file extension, and that is .txt. Then let's add another. Let's say HTML. So I'm going to copy this and paste it, and let's say HTML next. .html. And then lastly, you can do just all files. So all files, and that is .*. And let's try this again. So, hello, my name is Bro. I like pizza and ice cream. And this time, I think I'll save this as an HTML file. And this is, we'll call this pizza and ice cream, I guess. And click save. Now let's go back to my desktop. Here's that file, pizza and ice cream, and it is an HTML file. Let's just verify that. Yep, .html for the type of file. So we can open this with Notepad, and it has all of the text. I could even open this with Sublime Text as well.
Kind of like that. All right, let's change the initial directory for saving a file. Let's change it to my project folder for this Python file that we have. So that is, and I'm just going to organize this a little bit, initial dir equals, and then we can list a file path. So I'm just going to copy this. So copy path, paste it. Then I want to make sure that these are double backslashes. And I need to add a comma at the end. Okay, let's try this again. So, testing 1, 2, 3. And this should go to my project folder, which it does. Testing 1, 2, 3. And let's save this as a plain text file. Click save. And here's that plain text file, testing 1, 2, 3. Another option available to you is that you don't necessarily need to use a text area to get some text to write to a file. You could use the console window to accept some text. So to demonstrate this, I'm going to turn this line into a comment, and we're instead going to use the console window this time. So we'll say file text equals input, and then let's just have a prompt here. Enter some text, I guess. And then let's run this again. So we still need to click this save button and select a file location. I'll just save over our file, testing 1, 2, 3. I'll click save. Yeah, I'll replace it. All right, so we need to enter some text, I guess. So I will write a message such as the cake is a lie, and hit enter. So then our file, testing 1, 2, 3, now says the cake is a lie. So you don't necessarily need to use the get function for a text area. You can use the console window as well. Here's one last thing to consider before you go. So what if we begin the process of finding a file location to save a file to, and then we exit out of this window? Well, we're going to encounter an exception. So one way that we can prevent this is to add this line, if file is none, return. So then if we were to try this again, begin saving a file, and then exit out of this, there is no exception that we encounter. So that's just one little extra I thought I would throw in. But yeah, that's the basics of saving files in Python. If you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how to save a file using Python. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create a menu bar in Python. So sit back, relax, and enjoy the show. Alright people, let's create a menu bar. Not too different from the menu bar that you see at the top of many programs. There's usually a tab for File, Edit, View, Help, stuff like that. Except we're going to create one that doesn't have as many options or features. It's going to be the generic brand menu bar like the Walmart variety. So let's begin by creating a window. So window equals tk followed by window.main loop. Then we're going to create a menu bar and add menus to the menu bar, and each menu is going to function like a drop-down menu where you hover over one of these tabs and there's a drop-down. So we need a menu bar. Let's just call this menu bar. Menu bar equals menu, and we're adding this to our window. So then we're going to take window.config, and we can set the menu of this window to equal the menu bar that we just created. With each of these tabs for your menu bar, you need to create a separate menu and add each menu to your menu bar, and the menu bar is added to the window. There's different levels to this stuff. So let's create a file menu because, well, this one has a file menu. Why not our program? So file, menu, equals menu. Kind of like what we did with our menu bar, except instead of adding this to our window, we're going to add this to our menu bar. So menu bar, like that. There's one other step too. We need to use this function, menu bar dot add
underscore cascade. This will have a drop-down menu sort of effect. So let's create a label just called file to mimic the file tab that you see at the top of many programs. So label, file, and we're going to set the menu to equal the file menu that we created. So file menu, and let's take a look just to see what we have. So here's our menu bar, and here's our menu. There's a drop-down effect for this, but we need to add actual options to this file menu. So let's do that. So let's begin by creating, let's see, we got maybe open, save, and exit. That should be good. So file, menu, dot add, underscore command. So this is a clickable option, and let's create a label called open, and we can open a file, and maybe two more. So we got open, save, and exit. Open, save, exit. And let's take a look at this. So here's the drop-down menu. We can open, save, exit. Now you might notice that there's this annoying line. This is called a tear off. You can actually get rid of this if you want. So when we create this file menu, we're going to set tear off to equal 0, and that should get rid of that. And it's gone. So sometimes you might see a line to separate sections. Well, you can do that with a separator. So let's separate the exit command that we have from open and save. And to add that separator, we just type in the name of our menu, file, menu, dot add, separator. So this will separate your different commands from each other within a menu. You can see that there is a line between save and exit because we placed a separator here. Now, if you want each of these file commands to actually do something, you need to associate a command with each of these commands. It's a command within a command. So command equals, for our open file command, we'll create a function called open file. And we'll need to declare that function. And then let's create a command called save file. And then another called exit. Actually, one shortcut, if you want to exit something, you can just say quit. All right, let's create an open file and a save file function. So def, open file. Let's just print something just to keep this simple. I already have another video on opening files. So print file has been opened. And let's do the same thing for save file. File has been saved. And then our last command, exit, will just quit. So let's try this. So let's go to file. Here's the drop-down menu. We can open a file. File has been opened. We can save a file. And then exit. And exit will close out of our window. Let's create a second menu called edit to mimic the one that we have at the top of our IDE. So let's create a edit menu. So it's the same process that we did with our file menu. So let's call this edit menu equals menu. We're adding this to our menu bar, and I do not want a tear off, so tear off equals 0. Then for the next line, we need to add cascade. So I'm going to copy this, menu bar dot add cascade. The label name will be edit, and the menu will be edit menu, and we're setting this menu that we're adding to edit menu. And let's try this. So we have file and edit, but we need to add commands to this edit menu. So it's the same process that we did with our file menu. I'm just going to copy this, change file to edit, and let's make a command called cut, copy, and paste. So the label will be cut. We'll create a command called cut. We'll copy this, and we'll create another command called copy, and then paste.
All right, then we just need to create some functions for this. So cut, copy, paste. Let's do that at the top. So cut. You cut some text. So cut, copy, and then paste. You copied some text and paste. You pasted some text. All right, let's try this. So here's our edit menu. Here's the drop down. We can cut, we can copy, and we can paste. Not actually, but it's going to call a function that can do something like that if you want to set that up. Maybe that's a video for a different day. Let's customize these menus, well, because we can. So let's begin by changing the font. So we can just type in within each of these menus, font equals, pick a font that you want, and then a size. So I'm going to add this font for both of these menus that we have. And then when we hover over and click on these menus, you can see that the font has changed. Did you guys know that you can actually add images next to each of these commands? Well, you can, and this is how we can do that. First, you'll need some images. Here's a few that I'm using. So add these to your project folder. I plan on using a floppy disk for save, an open folder for open, and for some reason a stop sign for exit because I couldn't really think of anything at the moment. I guess an arrow would have worked too, I guess. So let's create some photo images out of these images. So I already did this. I'm just going to copy and paste the text that I had. So create a unique name for each image. I have open image, save image, and exit image. They're all photo images, and here is the file path or the file name for each of these pictures that I'm using. So to add an image to each of these commands, when you add the command, we can just say image and then the photo image that you want to use. So with my open command, I'm going to use this open image photo image that I have, and this is the open folder. So I'm going to do the same thing for save and exit. So we have save image and exit image. But when we run and compile this, let's take a look. Yeah, so all the text is gone. That's going to be a problem. So we'll need to compound these. So with compound, we can add an image on a certain side of the text and keep the text. So compound, let's say we want the image on the left. So compound left, and I'm just going to add this to each of these commands. And now we should have an image as well as some text. Well, that's the basics of creating a menu bar in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how you can create a simple menu bar in Python. What's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how frames work in Python. So sit back, relax, and enjoy the show. What's going on, people? We're going to be discussing frames today. A frame is really just a rectangular container to group and hold widgets together. So we're going to practice using frames today. But first, we'll need a window. We're going to create a frame and add a frame to the window. So window equals tk followed by window.main loop. Well, we're going to need some widgets to add to our frame. So let's create a bunch of buttons because why not? So I'm going to show you guys a shortcut too. So let's say button equals button. And then for now, we're going to add this to our window, but we're going to replace this eventually with frame when we create this. And I'm just going to set the text to equal, let's say W. We're going to have 4 different buttons, WASD, like the buttons on a keyboard if you're playing a game and you want to move forward, left, back, or right. So we're adding this to the window. For now, let's set the text to W. And what else can we do? Let's change the font. So font equals, I'll pick the font Consolas because that tends to be even with buttons. The size of the button adjusts to the size of the letter that you're using or the size of the text. So let's set this to 25 and then a width. So maybe width equals 3. All right, and then button.pack. And I just want to take a look at this. So here's our button W. So I'd like to show you guys a shortcut. If you don't plan on using this button by name, you don't really need to give it a name. You can just say button, and then have all your options here. And then instead of having button.pack, just add .pack to the end. So this will do the same thing. However, you can't adjust this button by its name though, because it doesn't have a name anymore. So let's create a few other buttons, one for A, S, and D. So we have W, A, S, D. And by default, they're all top and center. So with pack, we can actually put these on a certain side. So let's say we want W on the top, and then the other three will be all left. So side equals left. And then after I show this to you, you'll see the benefits of using a frame. All right, so right now they're all, at least it appears that they're all within a container. So what if I were to expand this? Well, W is just drifting off. It's sailing away by W. So what if we could put these within a frame or container to actually contain all of these widgets? Well, we can. So let's create a frame. Frame equals frame. And instead of adding these buttons to the window, we're going to add these buttons to our frame. And now we need to add the frame to the window. And this is what this looks like. However, we need to actually add this by using pack or place. So frame.pack. So now what this looks like is that all of these buttons, all of these widgets are now contained within a frame, a container. Let's change the background color of this frame just so that we can see the width and the height of this frame. So when you create your frame, there is an option for background color. It's just BG. And let's set this to a color. We haven't done pink yet. Pink is a very masculine color. So now the background of our frame is pink. And that might be a better visual cue to the balance of the frame. Let's also give this frame a border. So let's set a width of 5 using BD and then the type of border that we want, and we can specify that with relief. So relief equals, let's say, raised. So this will have a 3D pop effect, kind of like that. Let's try sunken. There's a few other ones as well, but I don't feel like it's necessary to go over all the border types. Let's stick with sunken for now. That'll work. All right, so with this frame, we are currently packing this. We can set this on a certain side within our window. So currently, it's at the top. Let's set this to maybe the bottom. So side equals bottom. Now, this frame is sticking to the bottom of the window, and it still contains all of the buttons, all of the widgets that we added. Another function available to you is the place function. We can place this frame at certain coordinates within our window. So let's set x to equal 0 and y to equal 0. So then when we place this frame within our window and set some coordinates, this entire frame is going to stick at these coordinates even if we were to resize this window. And we can change these too. Let's say x is now 100 and y is also 100. So the frame, along with all of the components, all of the widgets that it contains, are sticking within the container and they move along with this. So that's the basics of frames. It's really just a rectangular container to group and hold widgets together. So if you want a copy of all this code, I'll post all of this in the comments down below. And well, yeah, that's how frames work in Python. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys a few different ways in which we can create new windows using Python, so sit back, relax, and enjoy the show. Let's get started everybody. So we're going to create a window, and we'll add a button to this window. When we click on this button, it'll create a new separate window for us. So window equals TK followed by window.main loop. We'll need to add a button, so let's do that. Button, we're adding this to the window. Let's add some text to the button. Let's say create new window.
and we'll set a command. Command equals, and we'll need to define a function. Let's create a function called create_window, and let's pack this as well. So we will define this function, createWindow, and let's do so at the top. def createWindow, and what do we want this to do? Well, we're going to create a new window, and let's call this next window new_window equals, and there's two popular ways of creating a window. One is we can use TK, and the other is that we can use something called top level. And let me explain the difference between the two. Here's a definition for a top level window. This is a new window on top of other windows, and it's usually linked to a bottom window. Our main window is serving as the bottom window, and our new window is serving as the top window, the top level window. So let's try this and just experiment. Here is our main window, the bottom window, and if we were to click on this button, it's going to create a new window for us, a new top level window. If we were to close out of the bottom level window, any top level windows associated with this would also close, kind of like what you just saw now. However, it's not the same case the other way around. If we have a bottom window and a top level window, and we close out of the top level window, our bottom level window is just fine. It didn't close out of that. So think of these like Jenga pieces. If you were to pull one of the pieces, one of the windows, out from underneath the bottom, any pieces or windows on the top of it will close out as well or collapse, kind of like in the game Jenga. So that's one way to think of top level windows. They're stacked on top of any bottom level windows. If you remove a bottom piece, it removes any from the top. On the flip side, we have TK. This is a new independent window, and we've actually been doing this since day one of our GUI programming. TK is a new independent window, and our main window and the new window that we create are not linked whatsoever. They're completely independent. So if we were to create a new window, this is our new window, and close out of our old window, well, this new window still persists. So this could be useful for, let's say, a login form or a login screen. After you log in, you'll be brought to your main program, which could be within the new window. One other thing that you can do too, you can also destroy the old window after creating a new window. So we need to type in the name of the window that we want to destroy. Actually, let's call the main window just old_window, just to clarify things. So let's rename that here, here, and here as well. So we want to destroy our old window as if we're closing out of it. So we type in the name of the window, old_window, and we use the destroy function, and that sounds pretty sweet. So we're going to destroy our old window after creating our new window. So let me add a comment that this will close out of old window. And let's test it. So we have our old window, our main window. We'll create a new window. It creates our new window and then closes out of the old window. So that's one of a few ways in which you can create a new window for your program. So if you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how to create a new window using Python. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create separate tabs for our GUI applications in Python. So sit back, relax, and enjoy the show. Okay, let's begin. So in order to create tabs for our Python GUI application, we're going to need access to a widget called Notebook, and that's found in a different module. So this time we're going to need two imports. So at the top from tkinter, import just everything, but the Notebook widget is found within a separate module. So we'll need a second import from tkinter, import ttk. So this ttk import gives us access to several different widgets that are normally not available to us. So once you have these two imports, you're ready to begin. So we'll need a window equals tk followed by window.main loop. And we need to create a notebook widget. So right after you create your window, we're going to create a notebook. We'll call this notebook equals ttk.notebook. And we want to add this notebook to our window. So let me add a comment here what this widget does. So this is a widget that manages a collection of windows and displays. And that's really all there is to it. So in order to create different tabs, we're going to create some frames. So for the first tab, I'll call this tab 1 equals frame. and we want to add this to the notebook. And with our notebook, we're adding this notebook to the window. All right, so this will be a new frame for tab 1. And let's create a second tab, and we'll call this tab 2. And you can create more tabs if you want, but that might be overkill. So this is a new frame for tab 2. After you finish these 2 lines of code, we're going to follow this up with notebook.add. So notebook.add. What widget are we adding? We're adding our tab 1 frame, and we can set some text for this tab. So text equals, and I'll type in tab 1, and we'll repeat the process for tab 2. So notebook.add tab 2, and we'll change the text to tab 2. And then we need to pack this notebook, notebook.pack. And let's take a look to see what we have. All right, we have tab 1 and tab 2, but we'll probably want to actually add something to each of these tabs so that the content is visible. So let's create some labels. So after we pack our notebook, let's create some labels. I don't really feel like giving these names because we don't really plan on using them for anything else. So we'll just say label tab 1, that's going to be the parent widget, and let's set some text. Text equals hello. This is tab number 1. Then I think I'll give this a width and a height too, just so it's more visible. So for the width, I'll make this 50, and the height 25. So this will be roughly a square shape. And then we need to pack this, so I'm just going to add pack. And let's create a second label for tab 2. So label tab 2. Maybe I'll say goodbye. This is tab number 2. Okay, we should have some actual content for these labels now, for these tabs. So here's the label. This is tab 1, and this is tab 2. And you can switch between these, and they display each of these separate labels. However, with the way that this window is arranged, if we were to expand the size of this window, well, our frames and our tabs kind of stay in the top and in the center. So I'm going to add a few lines within the pack function of our notebook. The first thing I'm going to do is use the expand option and set this to true. So what this does, and I'm just going to add a comment that expand, this will expand to fill any space not otherwise used. So what happens now is that this will actually expand, and it's staying in the center of the window. But there's one more thing we're going to add. Fill equals both. Normally this is X or Y, or you can do both. So I'll add a comment as to what this option does. So fill will fill space on X and Y axis. So if you combine both of these together, what you get is that these tabs will stay in the top left corner. And if you were to expand the size of this window, the tabs aren't going to move. They're going to stick to the top left, but the size of the window will expand. All right, so that's the basics of creating tabs in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of creating tabs in Python. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys all about the Grid Geometry Manager in Python, so sit back, relax, and enjoy the show. Alright everybody, let's talk about the Grid Geometry Manager. Well, because we have to. This is a useful way to organize widgets within a container. Imagine our windows being arranged into a series of rows and columns, similar to an Excel spreadsheet. I tend to use that example a lot. The top leftmost cell is row 0, column 0. Computers always begin with 0, so that's why our grid doesn't begin with row 1, column 1. And we can list which row and column we would like our widgets to be placed within. And by default, we only have one row and one column to work with at the start. But we can explicitly state which row and column this widget should be placed within relative to the container that it's in. And Python will create new relative rows and columns for us if we state where these widgets should be placed. So let's create a small submission form and then organize all of our widgets using our new grid system that we have. So let's begin by creating a window. Window equals tk followed by window.main loop. Now that we have our window, we'll need to create some widgets to add to this window. So let's say that we want an entry box and a label for a first name, last name, and email address, as well as a submit button. So let's create a label and an entry box for a first name just to demonstrate this. So let's call this label first name label equals label. We're adding this to the window, and let's set the text to first name. For now, I'm just going to use .pack to demonstrate the differences between pack and grid. And let's create an entry box. Let's call this first name entry equals entry. We are adding this to the window. And for now, we're just going to pack this. And let's take a look. So here's our label on the top. It says first name, and then it has our entry box right underneath. So what if we want to have this label on the left-hand side and our entry box on the right-hand side of the label? We're better off using the Grid Geometry Manager. So we're going to replace pack with grid. And we have to set which row and column that we want each of these widgets to be placed within. Normally, if you use the Pack Geometry Manager, as you create new widgets, they're just going to be placed directly underneath in one long column. So let's say that for our name label, we want to place this where the row is 0 and the column is 0. That's the top left corner. So within the Grid Geometry Manager, when we call it, we're going to set row to equal 0, as well as column to equal 0. And then for the first name entry, we want this to be on the right-hand side of our label. So we'll place this within the same row. Row equals 0, but in a different column. Column equals 1. So column 1 is directly to the right of column 0. And then when we compile and run this, we now have our entry box to the right of our label that we have. So let's repeat the process for a last name, an email address, and then a submit button. So I'm just going to copy what we have here and change first name to last name. So last name label, and we'll change the text to last name entry, and we'll keep that the same. Now we want this last name label to be underneath the first name label, because right now they're going to overlap because we have them in the same row and columns. So you can see that we can no longer see the first name label or the first name entry. So let's place this directly underneath. We're going to put these underneath by one row. So we'll keep the columns the same, but we're going to put this underneath by one row. So row 1 and row 1 for the last name entry. And what you get is that these two labels and entry boxes are arranged neatly into rows and columns. And let's do the same thing for an email. So I'm going to copy what we have, and we're going to change last name to email. So email label and email entry, and then change for the text last name to just email. And we're going to place these where row equals 2, and we'll keep the column the same. And for email entry, row 2, column 1. So doesn't that look a lot better? Now let's create a submit button. So let's call this submit button equals button, and then we're adding this to the window, and we should set some text. Text equals submit, I guess, dot grid. And we want to place this underneath. Currently kind of just shoves it underneath for now. Let's say that we want this between these two columns. So we'll want to set the row and the column to begin with. Row is going to equal 3, and column, we'll set this equal to 0 for now. There isn't going to be any apparent change, it's still going to be in the same place. But one thing that we can do is use an option called column span. We can have a widget take up more than one column, and it's going to place this widget in between both of these columns, in between the combined width of both of them. So we'll add column span equals 2. So this widget is going to take up the next two available columns, including the one that it's currently in. And you can see that our submit button is now between these two columns that we have. One thing that you should know is that the column width is dependent on the width of the largest widget that is contained within that particular column. Let's say that we increase the width of our first name label. Well, our column is going to expand to actually fit that widget that we have. So for our first name label, let's set the width to maybe 20. And this is going to increase the width of column 0. And to even better demonstrate this, let's color each label a certain color, just for a visual. For our first name label, let's say this is red. And then for our last name label, let's set this to green. And then for email, maybe blue. Now, all of these are color coordinated, and you can see that the background color of our first name label is taking up the entire column space. Now, what if we changed the size of our email label to something even larger, like 30? So width equals 30. And now the column 0 has expanded to accommodate the size of our largest widget, which is our email, which has a width of 30. And before we finish this video, let's add a title to this submission form right on top of the first name label and the entry label. So let's call this title label equals label. We're adding this to the window. Let's set some text. Let's say enter your info. And let's pick font. Font equals, what am I feeling like today? Maybe just Arial. And then a size, maybe 25. We're going to use the Grid Geometry Manager. And we want this at the top, so we want row 0 at least. I want this to take up 2 columns. So we'll say column equals 0, and then set a column span. Column span equals 2. Now, a few things are going to overlap here. So we're going to move everything down by 1 row, besides our title label. So we want this first name label to be directly underneath our title label. So let's move everything down by 1 row. And our title is going to be directly on top of our first name label, as well as the first name entry box that we have. Alright, so that's the very basics of the Grid Geometry Manager. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of the Grid Geometry Manager in Python. Hey, what's going on everybody? It's your bro here, hope you're doing well. And in this video I'm going to teach you guys how we can create a progress bar in Python, so sit back, relax, and enjoy the show. Let's create a progress bar, but we'll need a few imports to begin. The progress bar widget is found within that TTK module, so we'll need a separate import from that. From tkenter.ttk import everything, and we'll import everything from time as well. Let's create a window. Window equals tk followed by window.main loop. We're going to add a progress bar and a button to this window. When we click on the button, it's going to fill our progress bar. Let's begin by creating a button to begin with. Let's call this button equals button. We're adding this to the window. Let's set some text. Text equals maybe download. And then a command. Maybe I'll call this start. Finish by adding this button to the window, and we'll just use pack to do that. Let's define what our start function does. def start. We'll fill this in later. I'm just going to print nothing just as a placeholder. And we should just have a button. Now let's add a progress bar before this button. And we'll call this progress bar just bar for short. Bar equals progress bar. We're adding this to the window. We can set an orientation. This can be horizontal or vertical. Later on in this video, I'll show you the differences between the two. But for now, let's set this to horizontal. And then I'm going to pack this bar, bar.pack, and add some padding. Pad y equals 10. And let's see what we have. Okay, this is our progress bar at the top, and this is the button. When we click on this button, it's going to fill our progress bar. But I think I'm going to increase the length of this progress bar. Let's set this to maybe 300. I believe 100 is the default. Okay, that's not too bad of a size. Now let's define what our start function does. We can actually increase the value of our progress bar by typing in the name of this progress bar here. Value plus equals some amount, let's say 10. So what's going to happen right now is that every time we click on this button, it's going to fill our progress bar by 10 out of the total, which is 100. Let's pretend that we're waiting for a certain amount of tasks to complete. So let's define a few variables. Let's say we have a variable called tasks, and let's set this to 10 just to keep it simple. And x will represent the current task that we're on, and we'll say 0 to begin with. Let's create a while loop. While x is less than the amount of tasks that we have, we will increment the value of our bar by 10%. 10% for each task that we have, which is 10 for a total of 100%. And we'll want to increment the task that we're on as well, which is represented by x. So let's increment x by 1 after each iteration of this while loop. Now, when we run this and click download, this fills instantly. Let's add a delay just to simulate each task waiting to be completed. So let's add that here. Let's add a delay by using time.sleep, and let's set this to 1 second. We're going to wait 1 second and then complete a task. What ends up happening now is that nothing appears to be updating. Well, what gives, bro? You lied to me. Well, that's because the window is waiting to have this progress bar complete before it's actually going to display it being filled. So we would want to refresh this window after each iteration of the while loop. So at the end of this while loop, let's add one thing: window.update_idle tasks. After each iteration of this while loop, it's going to update the window that we have. So then when we download something, it's going to update our progress bar after each iteration of this while loop until it's completed. Right about now. Let's take this a step further by adding a label that displays the current percent of the progress bar that is complete. Let's add this label after the progress bar but before the button, sandwiched right between these two widgets. So let's add that here. We'll call this label %label equals label. We'll add this to the window, and we'll need a text variable. Text variable equals, let's call this %. So the reason that we use a text variable is so that we can update this label with some text after each iteration of our while loop. And we'll need to pack this. Okay, within the window, near the top, let's define %. % equals string var. This allows us to update % with some new text and set the % label with the new text that we have within the while loop. But before we update idle tasks, let's set what % is. %.set, and let's say x divided by tasks. And then we'll multiply this by 100%. I'm just going to put this within its own set of parentheses times 100, and then we'll convert all of this to a string so we can display this along with some text. There are a lot of parentheses here, so it might be difficult to keep track of all this. All right, and then we're just going to tack on %, and that's it. Let's try it. So we got 10%, 20, 30, 40, 50. I'll shut up now. One change that I'm going to make is that I'm going to cast all of this as an integer before we convert it to a string, because I do not like that decimal at the end of our percentage. So yeah, it says 10%, 20, so on and so forth. Let's add a label that displays the current task that we're on. So let's copy what we have for our % label, and let's rename this as maybe task label. Task label, text variable will equal maybe text. And let's define what text is. So text is also a string var. And within our while loop, let's update the value of our text. Text.set we'll display x plus maybe a forward slash plus our tasks. And since we're displaying integers along with some strings, we need to convert these to strings, and we can use the str function to do that for us. So surround x and tasks with str to convert these to strings. And then we'll add just plus tasks completed. So the value of x will update after each iteration of this while loop. Let's try it. And after clicking download, this will display the percentage as well as the amount of tasks that have been completed, all the way until it reaches the end. Let's change this into a more practical example. We'll pretend that we're downloading a video game. So let's replace or rename tasks as maybe GB for gigabytes, and this game will be 100 gigabytes. We'll rename X as well. So let's refactor, rename, and change X to maybe download to represent the amount of gigabytes that are downloaded. And let's create a variable called speed, and let's set this to 1. All right, so while our download is less than the amount of gigabytes for this game, we'll sleep for maybe a portion of a second. 0.05 should be good. We'll increase the value of our bar by this amount, speed divided by gigabytes, and then multiply this by 100. For the download, we're going to increment this by whatever our speed is, and right now it's 1, so that's the same. We can keep percent the same. For our text, let's change tasks to gigabytes. And that's all the changes that we have to make. And now when we download something, we're kind of pretending that we're downloading a large file or a game. You can see that once it reaches 100, it says 100%, 100 out of 100 gigabytes completed. Now we can change this to a different value, let's say maybe 50, and the speed will be maybe 2. So this will adjust to accommodate whatever the new file size is as well as the speed. And before I forget, you can change the orientation to a vertical bar if you so choose. So we have this vertical download bar now, which could be good for something. All right, so that's the basics of progress bars in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of progress bars in Python. What's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can use the Canvas widget to draw some simple shapes. So sit back, relax, and enjoy the show. Welcome back, everyone. Well, in this video, we're going to be creating a canvas. A canvas is a widget that is used to draw simple graphs, plots, and images within a window. We're going to be creating some simple shapes in this video. Not anything too sophisticated. I might get more into the canvas widget in a separate video. And at the end of this lesson, we're going to practice by creating a Pokeball. So to begin, we'll need a window. Window equals tk followed by window.main loop. To create a canvas, we can just simply call this canvas. Canvas equals canvas, and we're adding this canvas to our window. And then we need to follow this with canvas.pack or place. But I'm just going to use pack because it's simple. This is what our canvas looks like. It's a rectangular area which we can draw graphics on. We can also set the width and the height of this canvas. So when we create this canvas, we're going to set the options for a height and a width. So let's begin with the height. Height equals, let's say 500, and the width will be the same, 500. And now we have a square canvas that we can draw graphics on. Let's begin by creating some simple shapes. Maybe a line. I think a line is a shape. Maybe a one-dimensional one. I don't know. I don't geometry. So let's create a simple line. So we type in the name of the canvas, dot create, and there's a bunch of different shapes that we can create. Let's create a line. Now I'm just going to turn this into a comment for a moment. We need to set some coordinates for this line. This top left corner of our canvas is 0, 0, and the bottom right corner of this canvas is 500 by 500. Depends on what you set the dimensions of the canvas to. So when we create a line, we need a starting point and an ending point. So if we want this to start in the top left corner, we're going to pass in 0, 0. That is the starting position. And we can place the coordinates for the ending position
If we want this line to end in the bottom right corner, that would be where x is 500 and y is 500. And this is what this looks like. We just have a simple line going across the screen. But that's not all. We can also change the color of this line and the thickness. Let's begin by changing the color. So we can do that with fill. Fill equals, let's pick the color blue. And now we have a blue line going across the screen. But we can also change the width of this as well. So we can do that using the width option. And let's set this to 5. Now we get an extra thick line across the screen. Now let's make a red line. So I'm just going to copy this, canvas.createLine, and let's change some coordinates for this. Let's say we want this to start in the bottom left corner and go up to the top right. So the starting x position would be 0, y would actually be 500, x for the ending position would be 500, and y would be 0. And let's set this to red, and we'll keep the width the same. Okay, so here's our red line, and notice that this red line is overlapping the blue line. So when you create shapes on a canvas, if there's any that overlap, the one that you most recently created will appear on the top. One option available to you is that you can actually give these graphics a unique name. With our blue line, we could call this blue line. Blue line equals all of this, and then we can call our red line something different, like red line. This would be useful if you want to call or use a graphic by its name. If you want to like move a graphic on the screen or have something appear, you can use this by its name. But we don't really need it for this lesson, so I'll just revert this back to what we had previously. I'm just letting you know that you can do that. All right, what do we have up next? Let's create a rectangle. So canvas.create rectangle. We can set some starting coordinates and ending coordinates. The starting coordinates are for the top left of the rectangle, and the ending coordinates are for the bottom right. So for the starting coordinates, let's say we're going to place this where x is 50, y is 50. For the ending coordinates, we want this where x is 250 and y is 250. I'm just making up numbers. Put it whatever you want, really. And this is what this looks like. But I think I'm going to comment out these lines for now. And here is our rectangle. Well, I guess it's also a square. We can actually give this a fill color as well. So we do that with the fill option. Fill equals purple, I guess. And now we have a purple rectangle. Next on our list is create polygon. We can create many sorts of shapes using create polygon, but it really depends on how many coordinates that we enter. Let's create a simple triangle, so we need at least 3 coordinates for this to work. So canvas.create polygon, and I have some coordinates picked out already. So let's place the first set of coordinates where x is 250, y is 0. For the second set, where x is 500 and y is 500. And the last set, the third set, we'll place this where x is 0 and y is 500. And what this looks like is that we have this black triangle that's taking up most of the canvas. We can also change the fill color as well. So we do that with the option fill. And we can set this to whatever color you want. Let's say yellow. And we now have a yellow triangle on our screen, and it kind of resembles the Triforce from the Legend of Zelda series, one of my personal favorites. Let's also add a border. This is actually done with outline. Outline equals, and then pick a color for the outline. Let's say black. And we have a black outline around this graphic. And you can also change the thickness of this too, with width. And let's set the width to 5. And now we have an extra thick line around our triangle. With these shapes, you can pass in a list of points too. So I'm going to get rid of all these, and we're going to pass in a list. So let's create a list called points. Points equals all the points that we just entered in previously. And then instead of passing in all of these coordinates individually, I'm just going to pass in our list of points. And this will work exactly the same. Okay, let's create an arc now. So canvas.create arc. An arc is really just a curved line between 2 points. However, when we list some coordinates, we're not listing the coordinates of the starting position and ending position for this arc. It's more or less for the amount of space that we want to allocate to actually draw this arc. So let's say that we want this arc to take up the entire canvas. We can pass in the dimensions for this canvas. So the top left corner is 0, 0, and the height and the width are 500. So this is our arc. It resembles a pie slice. It's not starting in the top left corner and ending down here. That's the amount of space that we're giving this create arc function to actually draw an arc. It's really an entire circle, but only a portion of it is visible. Let's also set a fill color for this. So fill equals, what color did we not pick yet? Let's say green. And now we have a green pie slice. There's different styles you can do too. So we can change that with style equals, the default is pie slice. That's what we had previously. Let's change this to chord. This will draw a line between these 2 points, and this kind of resembles like a bow with arrows. And there's also just arc, where it's simply just a curved line. Let's change this back to pie slice, well, because I like pie. We can change the starting position of where this arc begins with the option start. So start equals 0 by default, so there's going to be no apparent change. Let's adjust this by 90 degrees. So this is in degrees. So this shifted, what is this direction? Counterclockwise by 90 degrees. So 180 would theoretically flip this. And now this is on the other side of what we had previously, and then 270. All right, we can also set an extent. So the default is normally 90 degrees, but let's change this to 180. And now we have a, what is that, hemisphere? Half a circle. All right, people, let's practice by creating a Pokeball. There's still one more function that we have to cover. It's called create oval, but we'll do that as we're making this. So let's begin by creating the top red hemisphere of this Pokeball. So that's canvas.create arc. And we're going to set the extent of this to 0, 0, 500, 500, so that this is going to take up the entire canvas. And then let's also set a fill color to red. So fill equals red. We need to change the extent of how far this extends. So we'll do that with the extent function. So extent equals 180, so that this is a half circle. And let's also change the thickness of this outline as well using the width option. So width equals 10 would be good. And we have a red hemisphere for the top of our Pokeball. Let's work on the bottom half. So that is a white hemisphere. So canvas.create arc, these are all the same. We'll change the fill to white. The extent will be the same, but we need a different starting position. So start equals 180. So this is going to begin at the 180 degree mark. So when you combine these both together, we get 2 different colored hemispheres that form a perfect circle. Now let's create an oval within the center of this Pokeball. So we're going to do that with canvas.create oval. We're going to set the amount of space that we want to give the circle to be drawn. So we'll place this where x is 190, where y is 190, where x2, or the second x position, is 310, and y2 is 310. Let's set the fill color next. So we do that with fill. Fill equals white. And lastly, let's just give this a thicker border. So that is width equals 10 to match the width for the 2 arcs that we have. And there you have it. We have a simple Pokeball. All right, well, that's the basics of the Canvas widget. If you'd like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of the Canvas widget in Python. What's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create key events in Python. So sit back, relax, and enjoy the show. Welcome back, everyone. In this video, we're going to be discussing key events. We can bind a key event and a function to a widget or a window so that when we press a certain key or do something, we can trigger a function to be called that will perform some sort of task for us. So we can actually do this by using the bind function. So widgets and windows have access to a bind function. So when our window or our widget is selected and then you press a certain key or do something, then it's going to call a certain function to perform a task for us. So there's two arguments within the bind function. This takes an event as well as a function name. Let's say that when we press the enter key, we want to call this function to do something. So for this event, what we type for that is a set of quotes, angle brackets, and the name of the button. So for example, if you want to press W to move forward like you're playing a game, this would be W, A, S, D. There's also up, down, and then let's say we want to press enter to do something. That is actually a return. And then we will call this function. So let's create a function called do something. And let's define this at the top. DEF, do something. Now pay attention to this part. We need to set up one parameter for this do something function. This needs an event, so be sure to include that, and it's easy to forget. So what do we want to do after we press enter? Let's just print a message. You did a thing. And this should work now, so let's try it. So while this window has focusability, we can actually have this respond to events. So right now I'm pressing all sorts of keys. You can probably hear me right now going crazy on my keyboard. But now I'm going to hit enter, and it says you did a thing. And you can bind all sorts of keys to this window. Let's say that I want to press Q to quit. So we'll just replace this with lowercase q. So I'm typing all sorts of keys, but now I'm going to press Q, and it says you did a thing. Kind of like we're quitting the game. You can actually have this respond to all keys, well, almost all of them. So to do that, you just type in key with a capital K. So I can pretty much press on any key, then it's going to trigger or call our function. Kind of like that. So one thing that we could do, we can display the key event that was pressed. So I'm just going to add that here. Maybe I'll change this message. You pressed plus, and to display what key was pressed, that is event dot key sim. I believe that's for key symbol. So this will actually display what button you pressed. So WASD. Here's a unique idea for practice. Let's say that we want to add a label to our window, and we're going to change the text on the label to reflect whatever key that we press. So let's create a label. Label equals label. We're adding this to our window. And let's change the font as well to something massive, like Helvetica, and a size of 100. That should be good. Then we need to pack this label. So label.pack. Then within this function, let's turn this into a comment, and we're going to use label.config, and we're going to update our text. And the text is going to be whatever key that we press, so we can do that with event.keySim. So now this label is going to display whatever key that we press. So for example, WASD, backspace, escape, up, up, down, down, left, right, BA start. All right, so that's the basics of key events. If you could do me a favor and in the comments down below, just press F to pay respects. So if you want a copy of this code, I'll post this in the comments down below. But yeah, that's the basics of key events in Python. Hey, what's going on everybody? It's your bro here, hope you're doing well. And in this video, I'm going to teach you guys all about mouse events in Python. So sit back, relax, and enjoy the show. Hey everyone, we're going to be discussing mouse events in Python. So before we begin, we'll need a window. So window equals tk followed by window.main loop. And in the last video, we learned that we can bind a widget or a window so that when a certain event occurs, we can call a function. So we're going to do the same thing for this video, but we have various mouse events that we can cover. So we're going to use the window.bind function. And this takes two arguments, an event as well as a function name. So let's define a function. Let's call it the do something function. So do something, and we'll need to define this. So at the top, def do something. And remember that we need to set up one parameter for this function.
the parameter is an event. And then we'll just print something. Print, you did a thing. Okay, so there are various mouse events for a left button click within quotes, and then within angle brackets, a left button click is button dash 1. So then, if we were to click within this window, it's going to call our function, you did a thing. But if I were to right click, it doesn't do anything. So there are other mouse events too. So button 2 is that scroll wheel. Not if you scroll up or down, but if you press in on it. So right now I'm clicking left, I'm clicking right. Now I'm going to press in on the mouse wheel, and it says you did a thing. Button 3 is a right mouse click. So I'm clicking left, nothing, but I'm gonna click right, and that seems to work. All right, so button 1, I'm just going to add a note. Left mouse click. Button 2 is the scroll wheel. That's if you press in on it. And then button 3 is a right mouse click. So did you guys know we can actually get the X and Y coordinates of where this event occurred? So to do that, we type in the name of the event, .x. However, since we're displaying this along with some text, we'll need to convert this to a string. So string event.x. Then I'll add the Y coordinates as well. Event.y. I think I'll just add a comma between these to separate them. And we'll change our text. So we'll say mouse coordinates. All right, let's try this again. So this is going to give us the coordinates of where we click. And right now I'm just left clicking. So the top left corner is 0, 0. Well, at least close to it. I'm not there exactly. All right, so here's a few other events that we can cover. I'm going to copy this. We have button release. If we were to release a button, it's going to trigger our event. So right now I'm holding in on the left mouse button, but I'm going to let go, then it triggers our event. If I were to right click and hold it, it doesn't do anything. But as soon as I let go, then our event is triggered. We also have enter, not to be confused with the enter button. Just going to get rid of that. So that is enter. If we were to enter our binded window or widget. So if I were to enter, it's going to give the coordinates of where I entered this. There is also leave. So I'm going to say that enter the window. And leave is leave the window. So if I enter, nothing happens, but as soon as I leave, it gives the coordinates. And the last one is motion. As long as the cursor is in motion. So this one might be good for a game. So that is motion. Where the mouse moved. So it's consistently giving me the coordinates if I'm moving the mouse, but if I were stationary or stop moving, it stops. Alright, so that's the basics of mouse events in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of mouse events in Python. Hey, what's going on everybody? It's Bro here, hope you're doing well. And in this video, I'm going to teach you guys how we can drag and drop widgets in Python. So sit back, relax, and enjoy the show. Alright people, let's just dive into this. So we'll need a window, and then we're going to be adding widgets to the window. So window equals tk followed by window.main loop. Now you can drag and drop all sorts of widgets, but let's just stick with the label because creating a label is simple. So let's define a label. Label equals label. We're going to be adding this label to the window, and let's set a background color so we can actually see this label. Pick, I don't know, your favorite color. I'm going to pick red, and then I'm going to set a width and a height because normally if you have a label without any text, it's really small. So let's set a
width of maybe 10, and then a height of 5. That should be good. And we want to place this label someplace within the window. So label dot place, and we can pass in some x coordinates as well as y coordinates. So x equals 0 and y equals 0. So that this is going to appear in the top left corner of our window. So this is what we have. This is our label, and we want to be able to drag and drop this label someplace within the window. What we're going to need to do is actually bind this label twice. But let's begin with just the first binding. So in order to bind a widget, you type in the name of the widget, followed by calling the bind function. So this bind function can take 2 arguments. It can take an event as well as a function name. So for the function name, let's call this drag_start. But you don't really need to name it the same that I do. And for the event that occurs, this is going to be a left button click with the mouse. So that event is within quotes and within angle brackets, button-1. So if we were to click someplace within the label using the left mouse button, it's going to call our drag start function. But we need to define this. So at the top of our program, let's define this function. def drag start, and this takes 1 parameter. The parameter we have is our event. So what we're going to do is actually get the coordinates of where we click within this label, and we're going to assign these to a new variable or attribute of our label. So label dot, let's create an attribute called start x equals our event dot x. So this is where we click within the label and not necessarily the window. And let's repeat the process for y. So label dot start y equals event dot y. So we're going to have some coordinates of where we click within this label, and we can actually use that for our next function. So we're going to bind this label a second time. So I'm going to copy this line and paste it. The second binding, let's say, is drag_motion for the function name. And this event is going to occur if we were to hold down the left mouse button and then drag. So that is b1-motion. And then we need to define this function. So at the top, def drag_motion, and this takes our event as a parameter. So this part is going to be a little funky. We're going to get or create new x and y coordinates. So let's begin with x. X equals the name of our label or widget, label.winfo_x. This is a function, so add some parentheses. This will get the top left x coordinate of our label relative to the window that we're in, minus label x, well, label.startx, plus event.x. All right? So we're going to do the same thing for y. Well, we're going to replace x with y for the second line. All right, so this is the top left corner, the x coordinate of our widget relative to the window. This is the place where we click within the label itself. And this is where we begin dragging our widget to. It's a little difficult to explain, but if you combine all of these together, you'll get the new coordinates of where you want to drag this component, this widget to. So we need to replace this widget. So label.place x equals x and y equals y. So then when you combine all of these together, we have our widget and we can drag it and drop it someplace else within the window. Now, wait a second. What if we have more than one widget? Well, with the way that our functions are written now, they wouldn't be compatible with more than one widget, just this label itself. So what if we were to create a second label? So I'm going to call this second label just label2. So I'm just going to rename them. And let's change the background color to maybe blue. And I'm just going to place this somewhere else within our window. So maybe where x is 100 and y is 100. And we'll need to bind label2 as well. So make sure to bind label 2. So we have label 1 binded, it's just called label, and the same thing with label 2. All right, let's see what happens. I'm going to attempt to drag label 2, but label 1 is moving. That's because with our functions, we stated we're getting the coordinates, and we're storing them within the attributes of label 1 and not necessarily label 2. So in order to make these functions compatible with all widgets, we can actually add one line of code. Widget equals event.widget. So this is going to get the widget of the event that we're dealing with, and we're going to temporarily rename this as widget. So now we're going to replace all instances of where we use label and replace it with widget. So be sure to do the same thing too with drag motion. And then we will need to add this line at the top of drag motion. So now these functions are now compatible with any widget that we create. And we should be able to drag and drop both widgets. All right, well, that's the basics of dragging and dropping widgets in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of dragging and dropping widgets in Python. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can move an image on both a window and a canvas in Python. So sit back, relax, and enjoy the show. All right, my fellow bros, I'm going to divide this video into two different sections. In the first section, we're going to move a widget within a window, and in the next section, we're going to move an image on a canvas. So let's begin by moving a widget within a window. So we'll need a window equals tk followed by window.main loop, and we'll also need to set some geometry for this window. Window.geometry, and let's make this 500 by 500. 500 x 500, and let's take a look. Okay, that should be a decent size. Let's add a label to this window. So I actually have a race car image that I want to use. If you would like an image, feel free to pause the video and download one. What I would like to do is create a photo image from this PNG file that I have. I'm just going to call this my image equals photo image file equals, since this is within my project folder, I can just list the file name. Otherwise, you might have to list the file path. And for me, this is called racecar.png. I want to add this image to my label. Not necessary, but it'll be helpful for this example. I'm going to call my label just a label. Label equals label. I'm adding this to the window, and I'm going to set the image to equal my image that I created. It's a photo image. If you do not have an image that you want to use, you can simply just change the background color. You could say BG, I don't know, red. Oh, then we need to place this, so be sure to do that. Label.place, and I'm going to place this in the top left corner. That is where x equals 0 and y equals 0. And then we should have a race car, or whatever image you used, and a red background. You can get rid of the background color if you prefer. That's just if you don't have an image to use. You can set the background color just for a visual to show you where the label currently is. Let's set some key bindings for this window, and let's add them maybe here before we create the label and our image. So let's bind the W key for up, S for down, A for left, and D for right. So we do that with window.bind, and we pass in an event as well as a function name. So we want to tie the W key to a function, and we'll call this move underscore up. And then we will need to define this. So outside of the window, let's define move underscore up. And this takes an event. So we'll place that as a parameter. And to move our label up, we're going to take label.place. And we're going to place this at some new coordinates. X equals the label's current position relative to the window that it's in. So that is label.w info underscore x. All right, so then for y, it's similar. Y equals label.w info underscore y. But
we're going to subtract maybe 1. All right, so this is all we need. Although this is only going to move up. So I'm going to press W, and our label, our race car, or whatever image you used, is going to move slowly up. I'm going to increase this to 10, so the change is more drastic. So now our race car is drifting off into space. Let's bind a few other keys. S, A, and D. Sad. All right, so S will be down, move, underscore down. A for left, move, left. And D for right, move, right. We'll just copy what we have here and make a few changes. Let's begin with move down. The only thing we're going to change within here is, in place of subtracting 10 from the y coordinate, we're going to add 10. And with our race car, oh, I guess we have to define these, so let's do that real quick. So we have left, move left. We're going to subtract 10 from the x coordinate and keep y the same. And then the same thing for move right, move underscore right. And this time we are going to add 10 to x, and y will stay the same. Okay, now with our image, we can move up, down, right, and then left. And why stop there? We can bind these to our arrow keys. So up is just up with a capital U, down is down. These are all capital, by the way. Left is left, and then right is right. And now I can use my arrow keys to move this image. Now for this part of the video, I'm going to teach you guys how we can move an image on a canvas this time, and not just within a window. But we'll need a window to begin with. Window equals tk followed by window.main loop, and we're going to create a canvas. Canvas equals canvas. We're adding this canvas to the window, and let's set a width and height. For the width, let's make this 500, and the height 500 as well, so this is an even square. And we'll need to pack or place this canvas. Canvas.pack should take care of that. And let's run this, and this is our canvas. At this step, we need to add an image to our canvas, and I have an image of a race car that I want to add. So I need to create a photo image from this file. So we can do that. Let's give this photo image a unique name. I'm just going to call this photo image to keep it simple. Photo image equals photo image, and I can list the file path or the file name. Since this image is within my project folder, I only have to list the file name, and my file is called racecar.png. This next step, we need to give our image a unique name, the image that's being added to the canvas. I'll call this my image equals, and we need to turn this photo image into an image added to the canvas. So we type in the name of the canvas, canvas.create_image. We first need to list the coordinates of where we want to place this photo image. So let's place this in the top left corner. That is where x is 0 and y is 0. And we need to set the image of the image that we're creating. So we can do that with saying image equals the name of our photo image. And let's see what we have so far. So this image is somewhat cut off in the top left corner. We can easily fix that by anchoring our image when we create it. So let's at the end add anchor equals northwest. So that should fix that problem. And we now have our image that we want to use. And to move our image, we can set some key bindings. So we type in the name of the window, .bind, and we pass in 2 arguments, an event as well as a function name. Let's tie pressing the W key to moving up. So the first argument is going to be W, and the second is going to be a function name. So let's say move underscore up. And let's bind some other keys. W for up, S for down, A for left, and D for right. We'll need to define these now. So at the top, outside of the window, let's begin by defining move up. DEF, move up. This has an event as a parameter. And let's create the other definitions here. So I'm just going to rename these. So we have move up, move down, move left, and move right. Okay, now this next step. We can use the canvas's move function to move an image a certain amount of pixels on the x-axis and y-axis. So let's begin with move up. We type in the name of the canvas, dot, and use the move function. And this has 3 arguments: the image that we want to use, and this image is called my image, the one with the race car. The next argument is the amount of pixels we're moving this on the x-axis. With up, we can keep this the same, but on the y-axis, let's say we want to move this up 10 pixels, so that would be minus 10. And let's repeat the process for move down, move left, and move right. For move down, we're going to change y to 10. For move left, we'll keep y the same at 0, but we're going to subtract 10. And then move right, we are going to add 10 to our x's. And that should be it. So we can move up, down, right, left. And if you want to bind these to some arrow keys, all we have to do is just change the event so we can bind these to our WSAD keys, as well as up, down, left, and right. And this time I'm going to use my arrow keys: up, down, right, and left. Alright, so that's a few of the basics of moving either widgets or images on a canvas or window. If you would like a copy of all this code for both examples, I'll post both of them in the comments down below. But yeah, that's the basics of moving widgets and images in Python. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create some simple 2D animations in Python. So sit back, relax, and enjoy the show. Alright, my fellow bros, in this video we're going to be animating an image on a canvas. We're only going to be moving this image up, down, left, and right. Feel free to download an image that you want to use. I'm just going to use this UFO emoji that I found. So we'll need 2 imports at the top from tkinter, import everything. That's what we usually have. We'll also need to import time as well. We'll need a window equals tk, followed by window.main loop. We'll need a canvas. I'm going to call the canvas canvas. Canvas equals canvas. We're adding the canvas to the window. I'm going to create something that's called a constant. We're going to create a constant for the width and the height of our canvas. So a constant is a variable or value that you don't plan on changing later at all. And a common naming convention for a constant is that the name of the constant is all uppercase. So I want the width and the height of this canvas to be constants. So for the width, this is going to be all uppercase. It's not necessary to make it all uppercase, but that's a common naming convention. For the width, I'm going to set this to 500, and the height set to 500 as well. And for the width of this canvas, I'm going to set the width to equal my constant, which is 500, and the height to my constant height. So the reason that I'm making constants is that we'll be reusing these a lot later in this program, so we might as well just declare them now and get it over with. So for the canvas, we're adding this to the window, we're setting the width to our constant of width, and the height to our constant of height. And we need to follow this by packing this, or place canvas.pack. Pack to make it simple. So we should have a canvas on our window. Now if you have an image that you want to use, we're going to animate it. I need to create a photo image from this file. It's a PNG file. It's called UFO, but yours is probably going to be named something different, so don't copy me exactly. I need to create a photo image from this. I'm going to call this photo_image, but name it whatever you want. This equals photo image, and I need to list the file path or the file name. Since this file is within my project folder, I only have to list the file name, and for me this is called ufo.png. Our next step is that we're going to take our photo image and add this photo image to the canvas, and we'll also give this image a unique name. I'm going to call this my image equals, we're going to use the canvas's create image function. So canvas.create image. There's a few arguments that we need to pass in. Where we want this image to appear, we need a set of coordinates. If we want this to appear in the top left corner, that is where x is 0 and y is 0. For the image, we're going to set this equal to our photo image, whatever you named this. And lastly, we should anchor this. I'm going to anchor this in the northwest corner to keep it simple. And we should have our image on our canvas in the top left corner. And here is my UFO that's being piloted by a green alien that's waving to me. Aliens are usually not that friendly unless they're abducting you. Our next step is to create a while loop. So we'll say while true. This will continue forever until we close out of the program. If you're looking at the code for a game, this might say instead while running. Running will be a Boolean variable that contains either true or false. So if this is true while the game is running, they're going to continue moving all of the characters on the screen. And then if somebody pauses the game or closes out of the game, then they'll flip this running variable to false. But to keep things simple, we'll just say while true, but that's something that you might see. What we'll want to do is get the coordinates of our image within the canvas, and this will return a list of coordinates. So let's create a list called coordinates. So coordinates equals canvas, and we can use the coords function to get the coordinates. I guess that's short for coordinates. And we're getting the coordinates of my image, so we'll pass this into this function. And then let's print this just to see what this returns. We'll print coordinates. Okay, now to update the window after each cycle of this while loop, we can use the update function of our window. So window.update will also have this thread sleep for, let's say, 0.01 seconds. So time.sleep 0.01. So here's a quick rundown of what we have going on so far within this while loop. We're going to first get the coordinates of where our image is located. We'll print the coordinates to the console window. This part isn't required, but it's going to help us for learning purposes. We'll update this window for any changes, and then our thread, which is in charge of running the program, is going to sleep for, I believe that's 1/100th of a second. So when we run this, our image is staying in place, and we know that our while loop is running because it's continuously printing the coordinates. The first number is the X position, the second number is the Y position. Now we're going to give our image a speed, or velocity. I like to call it velocity. And in fact, I'm going to give this image two velocities, one for how fast this image is moving on the X-axis, and another for how fast it's moving on the Y-axis. So I'm going to create two variables, one called X velocity, and I'm going to set this equal to 1, and Y velocity, and I'll set this to 1 as well. Okay, so what we need to do now is update the position of our image. So let's do that before we update our window. So I'm going to type in the name of the canvas and use the move function. This move function takes 3 arguments. What you want to move. I want to move my image, my UFO, and how far I want to move this image on each axis, each coordinate. So what I want to do is update the X velocity, the X position of my image. So I'm going to pass in my X velocity variable, and then Y will just keep the same for now. So we'll just say 0. So after each iteration of this while loop, my UFO is going to move 1 pixel to the right, and it's just going to go off into the void forever. And now if we replaced X velocity with 0, and for Y we set this to our Y velocity, this image is now going to travel down, and it will continue into the void forever. And then if we combined both of these together, we're going to move diagonally down and to the right. So what if we want this image to bounce off the walls? We're going to add some if statements. We're going to begin by just having this image bounce off the left and right walls. For now, let's set y velocity to 0 so that this image is only moving left and right. So before we move this image, we'll add an if statement. We're going to check to see if the x position of our image is either greater than the width of the canvas or if it's less than 0. So we take our coordinates and we're going to get the first element from this list. So that is 0. That is x, the x value. If coordinates at element 0 is greater than or equal to the width of this window, and this is a constant, so we can just place that here. If coordinates, well, x within our coordinates is greater than or equal to width, or coordinates at index 0 is less than 0, then we want to reverse the direction or flip the velocity. So we want to change our x velocity and make this a negative number. One easy way to do that is that we can take x velocity equals x velocity times -1. Or another way of writing this is just to say x velocity minus negative velocity. Now what ends up happening is that when this image reaches the right border, it's going to bounce back. However, it only bounces back after it reaches the top left corner of the image. We need to factor in the width of the image as well. So we're going to create two new variables, and let's do this right before the while loop. We'll want to determine what the height and the width are for our photo image that we have. So this is what we're going to write. Let's call these two values image underscore width and image underscore height. So we need to determine what the width and the height is for our photo image, and there is a function to do that. Type in the name of the photo image, dot, and there is a width function. And the same thing for height. Photo image dot height. And then we can reuse these. So I'm just going to add one line to this if statement. If the x position of our image is greater than or equal to the width of our window minus the width of our image. And I'm just going to put these within parentheses just to keep these more organized. And what ends up happening now is that when the right portion of our image hits the right wall, it's going to bounce off. And let's do the same thing for our y velocity. We're going to replace coordinates at index 0 with 1 and change that here as well. Replace width with height. And this is image underscore height. And we're going to change the y velocity this time. And when we move this image, let's also add the y velocity. And now our image is just going to bounce off the walls forever, but it's kind of predictable since we set x and y to equal 1. Now let's change the speeds to kind of spice things up. Let's say for the x velocity, this is 3, and y velocity, this is now 2. This is going to go in a completely different direction. So you can mess with the speeds however you want. So guys, how about we add a background image to this? Well, because we can. I'm going to reuse this image of space from my Java video on this same topic. I need to create a photo image from this, and I'm going to copy what we did for our normal image that we were moving and animating. So this is called space.png. Well, that's the name of my file. And I'm going to give this image a different name. Maybe I'll call this background underscore photo. And then I'm going to add this photo to the canvas. And I'm going to call this a different name. I'll just call this background. All right, so our window should have a background now, and then our image moves on top of the background. So make sure you add and create the background before you add any other images. Otherwise, the background might overlap your image. All right, so that's the basics of some simple animations in Python. If you want to copy all this code, I'll post all of this in the comments down below. But yeah, that's the basics of some animations in Python. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how we can animate multiple objects in Python, so sit back, relax, and enjoy the show. Welcome back my fellow bros. In this video we're going to be animating multiple objects within a window. More specifically, we'll animate some circles, and each of these circles will have their own characteristics, speeds, and directions. So we'll need two imports to begin. From tkinter, import everything. We'll also be importing everything from the time module as well. We'll need a window equals tk, followed by window.main loop. I'm going to create two constants, one for the width and one for the height. Let's set the width equal to 500 and the height equal to 500 as well. We'll create a canvas and we'll be animating the circles that we're going to create on the canvas. So let's create a canvas. Canvas equals canvas. We're going to be adding the canvas to the window, and we'll set the width of our canvas equal to our constant width, which is 500, and our height equal to our constant of height, which is also 500, and we will add this canvas by using the pack function, canvas.pack. Here's our canvas, and we're going to be creating multiple circles. Let's pretend that they're all different sports balls, like a tennis ball, baseball, volleyball, bowling ball. They'll all be bouncing off of the borders, and once each of them encounters a border, they will change direction. Since we're going to be creating multiple objects, I think it's best if we do this with another class. So let's create another class. I'm going to go to File, New, Python file, and let's call this class Ball. And click Python file, and we need to define this class. Class Ball. And we also need a constructor for this ball class. We can create one with def, 2 underscores, init, 2 underscores again. And we can set up the parameters of what we want to receive if we were to create a ball object. So let's pretend that we're going to be creating a volleyball to begin with. So let's call this ball volley underscore ball equals ball. And we'll pass in some arguments. So let's set up the parameters first. What do we want to receive? One, we want to receive our canvas so that we can actually draw this oval. We can draw this ball. We should also have an X and Y position, a diameter, X velocity, Y velocity, and a color. All right, so when we create a ball, like a volleyball, we're going to pass in whatever the parameters require. So we need a canvas, X, Y, a diameter, an X velocity, Y velocity, and a color. So within the constructor for the ball, we're passing in our canvas. It's kind of like what we do with widgets. We're specifying what we're going to be adding this widget to. We're going to be adding this ball to our canvas. We also need X, Y, and a diameter. Let's make this simple by setting X and Y to both 0. For the diameter, let's set this to maybe 100. And we also need an X velocity and Y velocity. Let's set this both to 1. And a color, so let's pass in a string, like white. Let's head back to our ball class and finish assigning all of these arguments that we're going to receive. The first step is that we'll say self.canvas equals the canvas that we receive when it's passed to us as an argument. Our next step is to draw this oval, draw this ball, and we'll say self.image equals canvas.create underscore oval. And with creating ovals, we can pass in X, Y, and with circles, the diameter is equal for both the width and the height. So we'll pass in our diameter twice. And lastly, a fill color. And we'll say this is equal to the color that we receive, which is white. We're going to set the X velocity and the Y velocity. This is related to the direction that it's initially going to head in. So self.x velocity equals the X velocity that we receive. And we'll do the same thing for Y velocity. Self.y velocity equals Y velocity. Now, since this is in another class, we need to import this class. From ball import everything. And you can see that this red underline went away. So let's see what happens now. We have our volleyball, but it's not currently moving, so that's the next step. So let's create a function within the ball class called move that we can call upon. So we'll do this after the constructor, def move, and this will take self as an argument. The first thing that we should do is get the coordinates. So we'll say coordinates, and this is a list. Coordinates equals self dot canvas dot coords. And we'll pass in self dot image. And we will print these coordinates just to see what's here. All right, now we'll create a while loop within our main class. So let's add that near the end. And we'll just say while true. So while this is running, let's move our volleyball. So volleyball dot move. So this will call the move function of our volleyball. And then we will update the window dot update so that this refreshes, and we will sleep for maybe 1/100th of a second. Time dot sleep 0.01, but you can put whatever you want here. So this is going to at first just print the coordinates of this ball. So it's not currently moving, and this time with our list we have 4 coordinates. 0, 0, that's the top left corner, and 100, 100, that's the bottom right corner. So this time we have 4 coordinates that we have to deal with, the top left corner as well as the bottom right corner. Our next step is that we should move this image. Self.canvas.move. What object are we going to move? We're going to move self.image. And in what directions? Self.x velocity as well as self.y velocity. Now our ball is going to move across the window, and right now it's displaying all of the coordinates. We don't have any bounds set up, so it's just going to continue into the void forever. So we should set up some if statements to check to see if one of the borders touches one of the walls of the window. If so, it's going to change direction. So let's check to see if the left or right side of our ball touches one of the left or right borders. So let's write an if statement. If, and then let's take a look at these coordinates. If coordinates at index 2, that is this one, 0, 1, 2. So this is the bottom right corner with these 2 sets of coordinates. If coordinates at index 2 is greater than or equal to, and I'm going to put these within parentheses, self.canvas, and we need to get the width of the canvas. One way which we can do that is to use the winfo_width function. So this is going to get the width of the canvas. And then let's add one more thing. Or coordinates at index 0 is less than 0. So if this ball touches the left or right border, we want to change direction. So we can flip the x velocity. Self.x velocity equals negative self x velocity. And let's do the same thing for the top and bottom borders. So let's copy what we have. And we'll replace coordinates at index 2 with 3. And we'll also replace winfo_width with height. And coordinates at index 1. Change self.x velocity with y velocity. Same thing here as well. All right, and that should be everything. Let's try it. So let's see if this ball actually bounces off the borders, which it does. Pretty cool. So that's everything we need to do within our ball class. Now, if we need to create multiple balls, we can just construct them. So let's say this time we would like a tennis ball. I'm going to name this volleyball as tennis ball. And let's make the diameter smaller, like 5. But we'll make this a lot faster, like for the velocity, let's say 4 and 3. And the color, let's make this yellow. And we also need to call the move function of this tennis ball. So within the while loop, tennis ball dot move. And then we should also have a tennis ball moving across the screen in a different direction. Now, technically we don't need to print the coordinates, but I tend to do that just for teaching purposes to better demonstrate all of this. Now, our ball class is acting as a blueprint for how balls should be created and the behavior that they exhibit. And if we need to create a ball, we can just come up with a name for the ball and call the ball constructor to take care of that for us, kind of like what we've been doing with widgets. So all we need to do to create another ball is come up with a unique name for the ball and instantiate it using our ball class that we created. So this time, let's create a basketball. I'll rename this as basketball, and we'll pass in different arguments based on how we want to customize this unique ball. So for the diameter, let's say this is now 125, and the x and y velocity, let's set this to something very fast, like 8 and 7. And with the color, let's change this to orange. And make sure you also call the move function. So basketball.move. And we should have a basketball moving across the screen. Alright everybody, so that's the basics of animating multiple objects in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how to animate multiple objects in Python. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how we can create a clock program in Python, so sit back, relax, and enjoy the show. Alright my fellow bros, in this video we're going to be creating a clock GUI program, so we'll need a few imports from tkinter, import everything, and from time, import everything as well. We'll need a window equals tk followed by window.main loop. And in this program, we're going to be creating 3 separate labels, one for the time, another for the day of the week, and another for the date. So let's begin with just displaying the time, and we'll work on the day of the week and the date later. So let's create a label for the time called time label equals label. We're adding this to the window, and let's set the font because we can. I'm going to choose maybe Arial, and then a size of 50 so that this is somewhat large. I'm going to change the foreground color, that is the font color, and I will pick a hex value of green, so that is 00FF00, but feel free to pick whatever color you want. And I'm also going to set the background color, and you can pick a hex value or a color name. I'm just going to say black. And then I am going to pack this label, time label dot pack. Now we're going to call a function, and we'll call this update, and we'll define what this does. After every second has passed, we will use a recursive function to keep on updating the time every 1 second or so. So let's define what this function does. def update. There is a function within the time module called strftime, which we can use to return the current time and format it however we want. So we're going to actually place this within a string variable, and we'll call this time string. And this function is strftime. I'm actually going to go to Python's website just to give you an example of how this works. Here we are on Python's website, and this is the strftime function. And this converts a tuple representing a time as returned by GM time or local time to a string as specified by the format arguments. So when we call this function, we can pass in directives as arguments based on what we want to display. If we want to display the current time, there is a few directives that we can pass in. So let's say that we want a 12-hour clock as represented by a decimal number between 1 and 12. Well, we would pass in %i as an argument. If we want the minutes, that would be right here, %m, and if we want the seconds, that is %s. So we're going to pass in these directives as if they are arguments. So within this function, we'll pass in those format specifiers or directives. So I want %i followed by %m and %s. All right, but these also have to be within quotes, so don't forget that.
because I just did. Okay, this will display the current time. Oh, then we also have to update our time label. So time label dot config text equals our time string, because remember that this returns a string of text. Text equals time string. So this will display the current time. And right now it is 6 in the morning or so. However, we just get one long jumbled number, so it would be a good idea if we separated some of these numbers. So within our strf time function, I'm just going to add some colons to separate these values. And this will display the current time. It is currently 6:46 in the morning. Let's add AM or PM to the end of this. So the directive for that is % lowercase p. 6:46 AM. Now, how do we update this label every 1 second to reflect the current time? Well, that's a good question, and I'm glad you asked it. So we're going to use the time labels after function. We pass in a delay and then a function that we want to call after that delay. So let's say we want to call this function update every 1000 milliseconds or 1 second. So we'll pass in the delay as an argument, 1000 milliseconds, and the function that we want to call. And we're going to perform what is known as a recursive function. We're going to call a function within itself. So after 1000 seconds, we're going to call update again, and it's going to repeat the process. It's going to return the time and format that time and update our label with the new time. So what ends up happening now is that our clock is going to update every 1000 milliseconds. Now let's add a few other labels. Let's say the day of the week. I'm going to copy what we have here, and let's rename this as day label. But I probably don't want this to be the same size. For the font, let's say ink free, because I like that font. And a size of maybe 25, and I'll get rid of the coloring. It's the same process as before, really. So let's replace time string with day string. The directive for strf time to display the day of the week is %a. And we're going to replace time label with day label. Text equals day string. And this will display the day of the week. And it is currently Wednesday. And if we want to display the current date, we can create a label, and we'll call this date label. And I'll make the font slightly bigger, maybe 30. We'll copy what we have for our day string and rename this as date string. So we have a few options for the date. I want to display the name of the month, the day, and then the year. So that would be %, capital B, %, lowercase d. I'm going to add a comma to separate the day and the year, and %, capital Y. And then I want to set the text of my date label to my date string, so that this will now display the current date. There's just one quick change that I think we should make. Right now we have 3 different labels: a time label, a day label, and a date label. And right now we're using the after function of the time label. So since we have all of these different labels, I think we should replace time label with our window, because our window has an after function as well, so that after 1000 milliseconds has passed, we can update the time, the day of the week, and the date. Alright, so that's the basics of creating a simple clock program in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of creating a clock in Python. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video I'm going to show you all how we can send an email using Python, so sit back, relax, and enjoy the show. Oh, a quick note for you all, you're going to need a Gmail account to sign into, as well as your username and password, so once you have those set, you're ready to begin.
Alright, let's begin by importing the Simple Mail Transfer Protocol library. We'll need a couple of variables to hold strings. Let's say we have a sender, a receiver, a password, a subject for your email, as well as a body for the email. Okay, sender is going to be you sending the email, so enter your email in here. I'm just going to make up one, you@gmail.com. Actually, sender would be better, I would say. Let me change that. Sender@gmail.com. Let's say we have a receiver. This is who you're going to send the email to. Receiver@gmail.com. Don't actually enter in these emails. Use your own or the person that you intend to send the email to for your test, because these will probably not work, I'm assuming. Then enter the password for your Gmail account. So let's say password123. And a subject. Let's say Python email test. And a body. What do you want to say within your email? I wrote an email. Okay, so that should be good. So remember that you're going to want to change these to your actual Gmail account, and you'll want to send it to a valid email address too. And make sure that you use your password for your Gmail account. Okay, now we're going to create a header for our email, and the syntax on this is a little strange. We're going to say message, F, and then triple quotes. So what this triple quotes is that a triple quote string can span multiple lines of text. So the first thing we'll enter is from within our header, from, and then since we're using an F string, we can insert a variable at a given location when we insert a pair of these curly braces. So from will be sender, the next line, to, colon, receiver, then the next line, subject, colon, subject. This will be the title of the email. Then I'm going to add a new line and then insert the body. And if you want, you can give yourself a name when you send this email. Let's say maybe Snoop Dogg. And if there's somebody you want to send the email to and give them a name, you can say like Nicolas Cage. But these aren't necessary. Okay, so we have our header completed. Let me just add a note that this is our header. Okay, we're going to create a server object. Server equals smtp lib dot smtp. There are two arguments. The first is smtp.gmail.com. The other argument is the port number, and that is going to be 587. That is the default mail submission port, 587. Now we're going to take our server object and start TLS, Transport Layer Security. Okay, now we need to log in. So server.login, we will pass in our sender email, that's us, as well as our password. Password. And let's print logged in. We'll eventually place all of this within a try and accept block later. All right, and then to send an email, type server.send mail, and we pass in ourself, sender, receiver, and our message. Sender, comma, receiver, comma, message. And let's print a confirmation. Print email has been sent. Now, if you were to run this program, you may encounter this error, SMTP authentication error. That either means your username password combination was not correct, or you need to turn on the less secure app access on your Gmail account, which you can find here. However, I would recommend turning that back off when you're done with this program, just because your account will be less secure, and I'm not liable if you get hacked. Hey, you know what? Let's place this code within a try block. We will try all of this code, and then if we encounter this exception, we can catch and handle it properly. So we will try these 4 lines of code, and we will handle our exception of smtlib.smtp authentication error. that means we could not sign in. So let's print unable to sign in. So I'm going to run this one more time, and instead of getting that ugly error, we should get a simple message that says unable to sign in. Once you have the proper username password combination for your Gmail account, and if you need to, set less secure app access to on, but make sure that you turn it back off when you're done with this. You should be able to send an email. Let's try it. Logged in, email has been sent. Here is a snapshot of the email that I received. I blurred out my actual email because I don't want it public, because some of you guys are weird. So we have our sender, our receiver, and I gave myself a nickname of Snoop Dogg. That's why it says Snoop to Nicholas, the receiver. But you don't actually need a name for these. As long as you have the sender and receiver fields filled in, you should be good. We have our subject, Python email test, as well as our body. I wrote an email. Well, everybody, that's how to write and send a simple email using Python. If you would like a copy of this code, I will post this in the comment section down below. But yeah, that's how to send a simple email using Python. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video I'm going to show you all how we can run a Python file using command prompt. So sit back, relax, and enjoy the show. Hey y'all, in today's video I'm going to show you all how we can run a Python file with command prompt. So first we'll need a script to work with. Let's just make a very simple program. Let's say print hello world, and then maybe we will ask for some user input. Name equals input. What's your name? And then at the end we will print the word hello plus the user's name. Okay. So let's save this to a place that we'll remember, perhaps my desktop. Now to save this file to a separate location, go to File, Save As. You can pick a name for this Python file, then to Directory, click these three dots, and pick a location you want to save this to. To make this easy, I'm going to save this Python file to my desktop, and then click OK. So the name of this Python file of mine is hello_world.py, then click OK. Now, our second step is to open command prompt. To open command prompt, just search for CMD. If you're using Mac, I believe it's terminal. Step number 3 is that we need to navigate to the directory that contains our Python file. I saved this Python file to my desktop. So if you right-click on your file and go to location, you can just copy this address. Now within command prompt, type cd to change directory, space, and then paste that directory that contains your Python file, hit enter, and for the last step, we need to invoke the Python interpreter by typing Python, space, and then the name of the script. And the name of my script is hello_world.py. Hit enter to run the script. Hello world, what is your name? Bro. Hello, bro. So that is how to run a Python file with command prompt. I will post all of these notes to the comment section down below, and well, yeah, that's how to run a Python file with command prompt. Hey, it's your bro, hope you're all doing well, and in this video I'm going to show you all how we can use pip for Python to download packages and modules. So sit back, relax, and enjoy the show. Alright people, pip for Python. Pip is a package manager for packages and modules from the Python package index. If you're using Python version 3.4 or above, pip should already be installed. If you're using a Python version below 3.4, one option is that you can always update your version of Python. Just click download, open when done, go to customize installation, make sure that pip is checked, go to next, and add Python to environment variables, then install. Now to use pip, open up command prompt and type pip for a help menu. All sorts of different general options and commands will appear. If you need to check your version of pip, type this command, and here's a cheat sheet that I wrote. So to check the current version of pip, type pip -- version, enter. And currently, the version that I'm using is 21. If you need to upgrade pip, use this command. Pip install -- upgrade pip. Mine should be the latest version. Yeah, requirement already satisfied. And if you need a list of installed packages, type pip list. So here's all of the packages that I currently have installed. Some of these you might recognize, like NumPy, Pygame, PyInstaller. Those are just a few. To check to see if any of your packages are outdated, type pip list -- outdated. And this might take a second. Here are 4 packages that are outdated on my computer: Babel, Pygame, PyTZ, and Setup Tools. If you need to upgrade one of your packages, type pip install the name of the package. Let's say that I would like to update Pygame, then -- upgrade. I just realized that in my notes I'm missing update a package, so I just added that here. Now you can see that Pygame has successfully updated, and let's just check to see if it has by using pip list outdated. Pip list -- outdated. And Pygame is no longer in here, so it is up to date. And if you would like to install a package, type pip install and the name of the package you would like to download. Let's say I would like to download pandas. Pip install the name of the package, in this case, pandas.
2 very boring minutes later.
And it's done. So I should now have pandas installed, and let me check. Pip list. And here it is. I have successfully downloaded the package of pandas. So those are a few commands for pip, and if you're interested in downloading more packages, head to Python's package index. On second thought, I should probably show you all where that is. Python's package index is located at pypi.org, and you can do a search for all sorts of different projects and packages. So everybody, that is pip for Python. I will post my notes in the comments section down below. And well, yeah, that's how to use pip for Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to show you all how we can convert a Python file to an executable, so sit back, relax, and enjoy the show. Here's a quick disclaimer before we begin. Windows Defender and other antivirus programs may prevent your executable from running, but if you head to the settings section of your antivirus, you can disable that so that your Python file can run. Also, please be sure that pip and PyInstaller are both installed and up to date. I have a separate video on that if you're interested. Now, the program that I'm going to be converting to an executable has a GUI portion to it. I created a clock program in a previous video, so I'm going to turn this clock program into an executable. Now, I recommend creating a new folder on your desktop just because this process is normally somewhat messy, so we'll create a folder to contain it all. Now copy any relevant Python files and or images and paste them to within this folder. If you have an image that you would like to set as an icon for your executable, I recommend moving that to the same folder as well. Our next step is to open Command Prompt, and we need to change the directory of Command Prompt so that it's pointing to that folder that contains our Python file. So on your Python file, right-click on it, go to Properties, and copy this location. And in Command Prompt, to change directory, type cd space and then paste that location. Now here's the cheat code to convert a Python file to an executable. Make sure that PyInstaller and pip are installed and both up to date. So type PyInstaller -F to make all of this one file. If you need the terminal window in your program, then omit this next part. Since I'm running a GUI application, I do not need that terminal window. So to remove that window, type -W. If you have an icon that you want to set, type -I and the name of your icon. However, it should be an ICO file. So if you have some other image that you would like to convert to an ICO file, here's how. If you need to convert an image to an ICO file, you can just Google convert to ICO, but one website that I commonly use is icoconvert.com. Just pick a file to upload, so choose File. I'm going to convert this PNG file of an alarm clock, upload it. There's a bunch of different settings you can use. Convert ICO, and then download my icon. And once your ICO file is downloaded, I will drag and drop it to my folder, and I will rename this. Let's rename this as icon.ico. And here's that cheat code one more time. PyInstaller -F-W if you do not need the terminal window, -I if you would like to add an icon, the name of your icon, it should be an ICO file, followed by the name of the Python file, and mine is named clock.py, then hit enter. Alright, looks like building our executable has completed successfully, so open that folder back up. Your executable is located within this dist folder. I would recommend just dragging and dropping it to your desktop, and we can get rid of this old folder. But close out a command prompt. And by clicking on this executable will now run my Python program. Well everyone, that is how to convert a Python file to an exe file. I will post my notes to the comment section down below, and well, yeah, that's how to convert a Python file to an executable. What's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to show you all how we can create a basic calculator using Python, so sit back, relax, and enjoy the show. Let's create a calculator. After importing tkinter, we'll need to define 3 separate functions. Our first function will be named button press, and there is one parameter which we will call num. We're not going to fill this in quite yet, we'll get back to it later. We'll use pass as a placeholder. We'll also need an equals function to calculate our expression, and a function to clear our calculator. Okay, that's it for our 3 functions. Let's create a window. Window equals tk, and at the end of our program, we'll write window.mainLoop. Let's set a title. Window.title. Calculator. Program's good, but make sure you spell title right. And let's set a geometry of 500 by 500 should be decent. Now we're going to create a string named equation text equals a set of quotes. This will effectively be empty for the time being, and we'll need to create a string var, and I will call this equation label equals string var. Let's create a label equals label. We're adding our label to our window. I will set our text variable equal to our equation label. You can pick a font if you wish. I'll set the background color equal to white. A width of 24. And a height of 2. And we need to finish this by using label.pack. And we should have a blank label within our calculator. This will display our numbers that we're entering in, or our expression. Okay, this is the tedious part. We have to create all of the buttons, and I think we should place these all within a frame. Frame equals frame. We're adding our frame to our window, frame.pack. Now let's create button 1. We'll do some copying and pasting later, so it's not as tedious. So button 1 equals button. We're adding our button to our frame. I'll set the text equal to 1, the height equal to 4, and the width equal to 9. And a font size of 35. Okay, we'll need a command. Command equals, I'll write a lambda function here. Lambda, we will call button press. Actually, I think I'm going to put this on the next line, just so it's easier to read. Button press, and we will pass in the number 1. And we need to add our button to our frame. Button 1 dot grid, and I'm going to set a row equal to 0 and a column equal to 0. And let's just test it. Okay, let's add the other buttons. I'm going to copy and paste everything that we have for button 1 and change button 1 to button 2. Set the text equal to 2. Pass in 2 to button press. And for the row and column, I'm going to set the column equal to 1 but keep row the same. Okay, button 3. It's going to be the same process, really. So text equals 3, button press 3, row 0, column 2. and button 4. Text equals 4, button press 4, column, actually let's set this to row 1, column 0, and I need to change that too. Okay, let's just double check this. Okay, button 5. So button 5, text equals 5, button press 5, and let's set column equal to 1. Okay, number 6. I told you all this is going to be tedious. Okay, so row 1, column 2. Button 7. Okay, so row 2, column 2. Actually, let's change that to column 0. Much better. Okay, button 8. 8, 8, 8, 8. Row 2, column 1. Number 9. Row 2, column 2. And lastly, 0. So button 0, text equals 0, button press, pass in 0, and this will be row 3, column 0. Okay, not too bad. Now let's fill in some of the symbols. So we need plus. I'm just going to rename this as plus. The text will equal the plus sign, put that within quotes. And button press will be plus. Oh, and we should probably put this in a row and column. So let's say row 0, column 3. So it should be on the right-hand side here. Okay, we need minus. Let's change plus to minus. And place this at row 1, column 3. We need multiply. That is an asterisk. Row 2, column 3. And divide. That is a forward slash. Row 3, column 3. I promise we're near the end of creating these buttons. We'll need an equal sign. Let's say equal, equal. Text is the equal sign, and our command is going to be equals the function. And this will be row 3, column 2. Okay, we need a decimal. Let's change the text to a decimal. Row 3, column 1. Okay, and lastly, we just need a clear button. Let's put this at the bottom. So clear, clear. Let's set the text equal to the word clear. And the command will be our clear function. And I think I'm going to pack this at the end. But let's change frame to window. Okay, let's check out all these buttons. Okay, not too bad. I think I'm going to change the width on our clear button so it's a little bit wider. Let's change the width to 12. That's a little bit better. Okay, let's fill in some of these functions. Let's start with button press. We're going to state global equation text. Then our equation text is equal to equation text plus we're converting whatever number or symbol that we receive to a string. And our equation label, which is a string var, will be set to our equation text. And let's test this. So we can type in any combination of numbers or symbols. Okay, let's work on our equals function next. So let's say global equation text total equals eval. Now eval will parse the expression that we pass in. Equation text and our equation label will be set to whatever our total is. And if we want to reuse our total, let's set our equation text equal to total. 2 plus 2 equals 4, minus 3 equals 1, times 5 equals 5, divided by 2 equals 2.5. Now, what if we divide by 0? Well, we'll run into that ugly zero division error. So let's write our code within a try and except block. So I'm going to indent some of this. And let's write try all of this code, and we will catch a zero division error exception. So except zero division error, and I will set our equation label set, let's say, arithmetic error. Equation text equals a set of quotes. Okay, so we should be able to catch this exception now. 5 divided by 0 equals arithmetic error. Now, what if we have a syntax error? Like we type in just a bunch of symbols and hit equals. We'll probably want to catch the syntax error as well. So let's write an additional except block before zero division error. Or after, I guess it doesn't matter. Except syntax error. And let's change arithmetic to syntax. And we can keep equation text the same. So now our program won't crash if we type in a bunch of symbols. Syntax error. Now let's work on the clear button. So that is within the clear function. So we will set global equation text equation label dot set to a set of quotes to effectively clear it, and our equation text equal to a set of quotes as well. And that should be it for this program. Let's run this one last time. Let's say 3.14 times 2.1 equals 6.594 divided by 2.1 equals 3.14 minus 1. I'm just making up numbers here. Plus 10 equals 12.14. And let's clear this and start again. 1 plus 2 plus 3 plus 4 equals 10. I think that's good enough. Alright everybody, so that's how to create a basic calculator in Python. I will post all of my code in the comments section down below if you would like a copy for yourself. But yeah, that's how to create a basic calculator using Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain how we can build a basic text editor program in Python, so sit back, relax, and enjoy the show. Okay, people, let's create a text editor. Here's all the different imports that you'll need, and we'll begin by defining all of the different functions that we'll need. So let's say we have a change color function to change the color of our font, and for all of these functions, I'm going to write pass as a placeholder. So we have change font, and this function will accept a varying amount of arguments, so we'll use that args keyword. We will need to open a file. New file, open file, save file, cut, copy, paste. Yeah, there's a lot of functions here. About. This is for an about section. And lastly, quit. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 functions. Let's create the main window that we're going to work with. Window equals tk. And at the very end, window.main loop. Okay, so let's create a title for this window. Window, title, notepad, program, I guess. Or maybe text editor program would be more appropriate. Text editor program. Okay, and we will need a file to work with, and I'll declare that now. File equals none. We'll need a window width and height. Window width equals 500 is good. And a height. Okay, so let's attempt to center this window, because right now it just appears to the side. So our next step is to get the screen width. Equals window dot w info screen width. And I'll copy this for screen height. Okay, so we need to figure out how much we're going to move our window on the X and Y axis. So let's say X equals screen width divided by 2 minus window width divided by 2, and we're going to cast all of this to an int. So add an int cast around this. Let's copy this, do the same thing for y, except this will be screen height and window height. Okay, let's set the geometry for the window. Window, geometry. I'm going to use a string format method. So let's say these will be placeholders for our values. So we have window width for the first value, window height, X, and Y. So this should be near the middle. Cool. We're going to create a string var variable to hold the font name. Font name equals string var, and pass in your window. And you can set this too. What do you want your default font to be? So let's say font name dot set, and then pick a font. I'll use Arial, I think. Let's create a font size string var as well. We're going to add this to the window. And we can set a default size. Perhaps 25. Okay, let's create a text area. Text area equals text. We're adding this to the window. I'm going to set a font equal to font name dot get. The name of the font that we want to use will be the font that we set within our font name string var. So now we'll use a size of font size dot get. Font size dot get. Okay, now we need a scroll bar. Scroll bar equals scroll bar. We're adding this to our text area, so pass that in. And I'm going to configure my window using grid row configure. This will allow our text area to expand, but we're going to set a weight equal to 1 so that it does in fact expand. And then we need column configure. Okay. And text area dot grid. I'm going to use the sticky keyword, and this will stick north plus east plus south plus west. So my text area should take most of the window. This is some sample text. Hooray! So it goes down to the next line once it runs out of room on one line, unless you resize the window, which is exactly what we wanted. Let's create a scroll bar. Well, we already created it, we just have to add a few details to it. So that will be near the bottom. And why don't we say scroll bar dot pack side equals right, fill equals Y. And then we just have to configure our text area with the scroll bar. So text area dot config Y scroll command equals scroll bar dot set. So that should work, but let's test it to be sure. Okay, I'm just going to type a bunch of Fs. Okay, look at that. Our scroll bar works. Cool. Okay, let's head to this portion, and we'll create a bunch of buttons. Well, a button, an option menu, and a spin box for the font color, the size, and the font style. So I'm going to place all of these different widgets within a frame. Frame equals frame, add it to the window, and then I'm going to use frame.grid. Okay, let's create a color button to change the font color. Color button equals button. I'll add my button to my frame. I'll set the text of the button equal to color. And I will associate a command of change color, which we have already defined at the top. Where is it? At the top here. Change color. And then, actually that's it for this portion. So then we need to add this button. Color button dot grid. I'll set the row equal to 0 and the column equal to 0. So let's be sure that this appears. Make sure you spell grid right. Okay. And we have a color button, but this button doesn't do anything. So let's head to the change color function. Within the change color function, we're going to say color equals color chooser dot ask color, and you can set a title too. Pick a color or else. You don't technically need a title. And then text area dot config. Oh, I should probably print this color, so let me do that. I'm just going to explain something here. So this color is going to be, I believe, a tuple. So let's print it. So let's say that I would like white. Okay, so we have a tuple. We just need one of these values, not both of them. So I'm going to say text area dot config foreground equals our color, but we do not want to assign a tuple to our color. We just need one of these values. So let's say I would like this hex value. So I'm going to say at index 1. And let's try it. Color. Perhaps I would like my text pink for some reason, so we're going with pink. This is some text, I suppose. And we can change this back to by using this color button. Now I would like blue. And we have blue text. Okay, so that is the change color function. I'm going to minimize this because we do not need it anymore. Okay, we're going to change the font next. So head to the portion of our code right after the color button, and we'll create an option menu to list all of the different fonts available to us. So let's say font box equals option menu. We're adding this to our frame. We need to set a variable, a string var, so that will be our font name that we declared up here. Now here's a trick to add all of the fonts as options to our option menu. We can use the unpacking operator, which is an asterisk, followed by font.families, and then call this function. So this will return all of the different fonts available to us, and we just need to set a command. And when we use our option menu, we'll call change font. And we need to add our font box to our grid. Row equals 0, and column equals 1. So this should be on the right-hand side of our color button. Yeah, it's going to look something like that, and you can see the default is Arial that we set. And we can change it to something else, like Comic Sans, or whatever. However, it's not going to change it quite yet, so that'll be the change font function. Before we fill in the change font function, there's another widget that's going to share the same command of change font, so we should create that next. So our next widget is a spin box, which I will name size box. This will be in charge of increasing or decreasing the font. So size box equals spin box. We're adding the spin box to our frame, and we'll set a range. So from underscore, you have to add that underscore, it's kind of weird. This is the range of our spin box for the font size, from 1 to, let's say, 100. The text variable will be font size. And our command equals change font. So when we use our spin box and call this command of change font, it's going to pass in our font size as an argument, whereas with option menu, it doesn't pass any arguments. That's why with our change font function, we're accepting a varying amount of arguments, because one's going to pass in an argument and the other isn't. And we just need to add our spin box. So that would be size box dot grid, row equals 0, and column equals 2. So we should have a spin box right on the bottom, and it's set to 25. That was our default for our font size string var, which we set as the text variable. Okay, so we can fill in this function of change font now, which will apply both to our option menu and our spin box. So that is all the way at the top. Within the change font function, we're going to take our text area dot config, set the font equal to font name dot get, and the size will be size box dot get. And that's it for this function. I'll minimize it for now. And let's test it. This is some sample text. Hey, how you doing? Good looking. Okay, so let's change the font. Let's pick Comic Sans or whatever you want, and we can increase or decrease the size, and we can change the color. How about red this time? All right, nice. Now let's add a menu bar at the top so we can save this file or open a file or create a new file and some other stuff. On second thought, I'm going to move these two last lines of code to this section here where we create our scroll bar just so that it's more organized. Okay, so at the bottom, let's create various drop-down menus. So we'll need a menu bar to begin with. So let's say menu bar equals menu. We're adding this to our window. Make sure that's capital, by the way. And window dot config menu equals menu bar. So we'll create a file menu, edit menu, and a help menu. So let's begin with the file menu to add to the menu bar. File menu equals menu. We're adding this to our menu bar and set a tear off equal to 0. We'll need a cascade for it to actually be a drop-down menu. So that will be menu bar dot add cascade. Label equals file, comma, menu equals file menu. Let's see if anything appears yet. Yep, so we have a file menu, but there's nothing to drop down yet. So we need some options. Well, commands technically. File, menu, dot add, command, label equals new, and the command will equal our new file function. Actually, I'll put these together. Okay, so let's copy this and paste it. We have open. The command will be open file. We have save. The command will be save file. And I'll add a separator. File, menu, dot add, separator. And lastly, we will have exit, command, quit. Okay, let me show you what this looks like. So here's our drop-down menu. That separator is this bold line going across. So if I was to remove this, then we wouldn't have that bold line. You can keep it in or get rid of it. Do whatever you want. And this is the tear off. So I'm going to remove the tear off. And you get this like tear off line at the top. I guess it's the default. I usually don't like it, so I set tear off equal to 0. So that is our file menu. Let's work on a edit menu. Edit menu equals menu, menu bar. Make sure that's capital too. Tear off equals 0. We'll need a cascade. Menu bar dot add cascade. Label equals edit menu equals edit menu. Edit menu dot add command. Label equals cut to cut some text. Command equals copy. Actually, that's cut. My bad. Okay, next is copy. So let's copy this and paste it. Cut, copy. We have paste. Command, paste. All right, let's take a look. Oh, make sure you spell label right. Okay, there we go. Okay, so we can cut, copy, and paste. And lastly, we should have a help menu. Help menu equals menu bar tear off equals 0. I think I'll copy this for my cascade. So menu bar dot add cascade help menu equals help menu. What we'll be doing for a command is that we'll be creating an about section that will bring up a pop-up window if you need to display any like help information or anything. So let's say about, and the command will be about. Okay, let's take a look. So we have help, and we'll have an about section that will tell you more about this program. But we need to work on some of these functions. Let's head to the quit function. This one's fairly easy. This is found within the file menu. Window.destroy. That will close out of the window. So go to File, then Exit to exit the program. We don't need it anymore, so let's minimize this. Okay, let's go to the About function. Let's bring up a message box. Show info. This first argument is the title. So let's say about this program. And the text will be whatever you want to tell the user about this program. This is a program written by you. Okay, so we should have a pop-up window when you go to help, then about. About this program, this is a program written by you. The next function is the paste function, so we can paste some text. Text area dot event generate, and the event is going to be within quotes and double angle brackets paste. Let's copy this and change paste to copy, and then cut. Okay, so we should be able to cut, copy, and paste. Hey, how's it hanging? Okay, let's highlight this. Edit, copy. Let's move down to the next line and paste. And we should be able to cut as well. Edit, cut. Nice. Head to the new file function, and we'll set the title of our window to maybe untitled until we save something. So untitled. And I need to delete any text within our text area. Text area dot delete, and we need to set a range. So this has to be a floating point number, the first character until the end. Let's try it. So I'll write some sample text. And we are going to go to File, New. That changed the title, and it deleted our text. So that is the new file function. Let's work on open file. We are now within the open file function, and we'll say file equals ask open file name. So we have a default extension, if you would like one. Default, I think I spelled that wrong. Extension equals, let's say, a txt file, comma, what are the accepted file types? I'll set this equal to all files, comma, and then we need asterisk dot asterisk for all file types, as well as text documents. So these are what is accepted when we look for a file. So we have either all files or all text documents. Text documents, comma, asterisk dot txt. Okay, so then let's try some code. We'll set our window title equal to os.path.base name of our file, so that we will change the title of the window to match whatever the file is that we opened. Then let's take our text area, delete what's currently here, from 1 until the end. Take our file, use the open function, open our file, and read it, so pass in our text area dot insert beginning at index of 1.0 file dot read. Then you can catch any exceptions too. I'll just write except exception, but it's better to name specific exceptions. I'll just print couldn't read file. And we should close our file at the end within a finally block. Finally, file dot close. We'll need a sample file to read, so I'm going to create a new file on my desktop. I'll call this test.txt. And let's write something. Whoa, you can actually read this? Awesome. Okay, let's save, close out of it, and run our program. File, open, test.txt, open. Whoa, you can actually read this? Awesome. Nice, so we know that the open function is working. If we need to create a new file, just go to File, New, and that will delete our old text. So lastly, we have save file. Underneath the save file function, file equals file dialog dot ask save as file name. So this will be the default name for the file, but you can change that. Initial file equals, let's say, untitled.txt. You can set a default extension. Default extension equals, let's say, txt. File types equals all files, comma, then asterisk dot asterisk for all file types. And any text documents, text documents, asterisk dot txt. Okay. If file is none, that's if they close out of our file dialog, we'll just return. Else, so we'll set the window title first. Window title os.path.base name file equals open our file and write. File dot right, take our text area, and get the text from index 1 through the end. Catch any exceptions. It's better to name them instead of just doing a general accept exception. But I'm just going to print couldn't save file. And finally, close our file. File.close. All right, so let's test it. So I'm going to change the font. I wonder if impact is in here. Yes, it is. I'll change the font size, maybe 30, and I'll pick a color. How about this swamp green color? Okay, so write something, perhaps some lyrics to a song you like. I should probably test copying and pasting. Edit, copy. Edit, paste. Nice. All right, let's actually try and save this now. I'll go to File, Save. The default file name is Untitled because we set it to that. I'll say All Star Lyrics. And save. Now I should be able to open this. So I'm going to go to my desktop. Here's that text file. I'm going to open it, and here are the lyrics that I wrote within my text editor. And let's try and read this. So let's go to File, Open, find your text document, Open, and would you look at that, my lyrics are still here. However, this program doesn't save the font. So I thought of a fun last-minute project that we can do. We can actually use our text editor to write a Python file, much like what we do with PyCharm. So let's write a program using our text editor program. It'll be just a simple program. Let's print hello world and ask for some user input. Let's say name equals input. What's your name? And we will print hello plus our name variable. And you can change the font and everything too if you want. Okay, so let's save this. File, save. I'll save this to my desktop, but make sure you save it as a py file, a Python file. I'll name this as hello.py and save. Now, to run a file using command prompt, we need to find the directory that contains our Python file. Mine is hello.py and it's located on my desktop. So I need the location, right-click, go to Properties. You can copy the location, then within command prompt or terminal, you can change directory by typing cd space and then paste your new directory, the new location. Enter. Then to run a Python program, type Python space and then the name of the program, the Python file. Mine is hello.py. Hit enter. Hello world, what is your name? Bro. Hello, bro. I just thought that would be a fun last-minute project that we can do. You don't even technically need an IDE to write a Python program. Screw you, PyCharm. Well, everyone, that is a basic text editor program. I will post the code for this program in the comments section down below. And, well, yeah, that's a basic text editor program using Python. Alright, ladies and gentlemen, let's create a game of tic-tac-toe. To begin, we'll need to import tkinter as well as random. And let's begin by defining all of the different functions that we'll need. Let's define a function named next turn. For the time being, we'll just write pass. We'll fill this in later on. We'll need a function named check winner. A function named empty spaces to check if there are any empty spaces left. And lastly, a function named new game that will launch a new game for us. Okay, we have our 4 functions. Now let's create a window. Let's create a window. Window equals tk. And at the end of our program, we need to use window.mainLoop. And when we run this, we should have just a small basic window. Let's set the title. Window.title. Let's set this to tic-tac-toe. We'll need a list of players. Players equals x, comma, o. And with the way that we're writing this program, we can swap these symbols with a different character. For example, we could say $sign is playing against the @ symbol too, but I'll demonstrate that later. Let's keep it as x and o for now. Now we need to select a random player to begin. Player equals random.choice and pass in our list of players. Now we'll need 9 buttons. I'm going to create a 2D list of buttons named buttons. And this will be the first row. This will be the second row. For the time being, I'm just going to initialize these with 0 for everything. And put these all within a list. So we have a 2D list named buttons. And to better visualize this, I'm going to place each row on a new line. So that's what our board is going to look like. We have a 2D list named buttons. We'll need a label to display whose turn it is. Label equals label. I'll set the text equal to player plus the word turn. And I'll set the font to font equals, pick whatever font that you want. And I am going to pack this label, label.pack, and set the side equal to top. And let's run this just to test it. Okay, looks like it's X's turn. Let's try it again. O's turn. Okay, that's fine for now. Let's create a reset button. Reset underscore button equals button. I'll set the text equal to restart. It's going to be a restart button or reset button. Pick a font. Maybe I'll set the size to 20. And we'll need a command. Command equals new game. When we click on this button, it's going to call this new game function for us. And we need to pack this button. Reset button dot pack, and I will set the side equal to top. Okay, let's see if that appears. All right, so we have our turn order, a label that will display whose turn it is, as well as our reset button. Now we'll need to create all of the buttons to add to our 2D list named buttons, but I'm going to place these all within a frame. Frame equals frame. We're adding our frame to our window, and I'm going to pack this frame. Frame.pack. Now we'll take our 2D list of buttons and add a button to each spot, and I think the best way to do this would be to use nested for loops. We'll have an outer for loop in charge of the rows. For row in range 3. Remember, we only have 3 rows and 3 columns. The inner for loop will be in charge of the columns. For column in range 3. And inside the inner for loop, we're going to create a new button. We'll say buttons at index, row, and column. We have 2 indexes because we have a 2D list. So buttons at row whatever, column whatever, depending on what iteration we are within our for loops. We'll create a new button, and we'll set the text. Oh, first add this to the frame. Almost forgot about that. We're adding our buttons to our frame and adding the frame to the window. Now we'll set the text equal to a blank set of quotes because we don't want any text. We'll set the font. I'll just copy what we have here for label. For a width, let's say 5, and a height, let's say 2. I'm going to hit enter just to move down to the next line because we still have a few more things to fill in. Okay, we'll need a command. Command equals, and I'm going to set this equal to a lambda function, so we need some arguments. Actually, I think I'll pass in some keyword arguments. Row equals row, and column equals column. Then our expression is next turn, and we will pass in row and column. Now we also need to add our buttons to our frame. Buttons at index of row and column. We'll use the grid function for this. Grid row equals row and column equals column. And it's always a good idea to test your program after making any major changes, so we should have our label, our reset button, and our grid of buttons. Now that the main body of our program is complete, let's head to the next turn function. And remember that we're passing in row and column as arguments, so we need to set up those parameters within the next turn function. Row and column. And the first line within here, we would like access to our player. So let's say global player so that we have access to it. And we're first going to check to see if the button that we click on is empty. So buttons at index of row and index of column. To access the text of a button, just add a third index operator and type in text. If the text of our button that we click is equal to a set of quotes, that means it's empty. And when we call check winner, 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 chicken dinner, and it's false, there is no winner, then we will fill in that button with our player, our player's character, whatever it is, X or O or whatever we decide. So within here, let's check to see if player is equal to players at index 0. That is our first player, and remember that we created a list of players, and we're planning on swapping these later. We could say like if player is equal to X, but that would make our program less flexible if we want to pick like a different character instead of an X. So if player is equal to players at index 0, whatever symbol is there, then we are going to take buttons at index of row, index of column, take our text, and set it equal to our player. And we should check to see if there's a winner after filling in this button. If check winner, and we still need to fill in this function, returns false, then we will switch players. Player equals players at index of 1. And label dot config text equals players at index 1 plus the word turn. So what we did here is that we're checking to see if after placing our text of our player on that button that we click, if there is no winner, then we're going to swap players. Player equals our next player, and we're configuring our label so that it displays the next player's turn. Players at index 1, turn. Now what if there is a winner? Let's say else if check winner is true. Then we will take our label dot config and set the text equal to players at index 0 plus the word wins. Now let's add another else if statement. Else if there's a tie. Let's say check winner is equal to the word tie, because we are already using false and true. Then let's change our label, and I'm just going to copy this. Text equals the word tie. Okay, so let's create an else block. So that goes right here. So if it's not player 1's turn, player at index 0, then it's our other player's turn, player at index of 1, so O then. So we just need to mostly just copy this text and change a few things around. So I'm going to copy all of this. And within here, let's set player equals players at index 0, then players at index 0's turn, players at index 1 wins, and that is it. Now our next turn function is now complete. Let's head down to the check winner function, and we need to check all of the different win conditions and return true if somebody won, false if there is yet no winner, and the word tie if it's a tie. So let's check all of the horizontal win conditions. So we can do this using a for loop. For row in range 3, we need to check the text of each button in each row. If buttons at index of row and column index of 0, we'll use the index operator to check the text, is equal to the next button in our row. So I will copy this and change 0 to 1. Check to see if that is equal to buttons at index of row, index of 2. And I'm going to check to see if this is all not equal, let me move this a little bit, to a space. So if that is the case, that means somebody won. So if all of these buttons are the same and they are not equal to an empty space, that means they're all the same. So let's return true. That means that somebody won. Now we need to check the vertical win conditions if anybody has the same character all the way down a single column. This next for loop is going to be for column in range 3. For the first button, this will be button at index of 0 and column, then 1 and column, let me just paste that, and 2 and column. Now we need to check the diagonal win conditions. So if buttons at index 0, 0, that's the top left corner, if the text of that button is equal to buttons at indexes of 1, 1, is equal to the indexes of button 2, 2. And if all of this does not equal an empty space, then return true, so there is a winner. And we have one last win condition to check, that is the other diagonal win condition. So we just need to change some of these indexes around. So we have 0, 2, 1, 1, and 2, 0. I'm going to change this statement to an else if statement. Now we need to check to see if there's any spaces remaining. Else if we will call the empty spaces function, which we have yet to fill in. If this returns false, then we will return the word tie. And lastly, else. Else there is no winner and no tie, so we will return false. And that is it for the check winner function. Let's test this. So this doesn't account for a tie quite yet, but we can fill in some of these spaces. Looks like X wins, and we can no longer fill in buttons. And we cannot start a new game quite yet either. Within the empty spaces function, let's create a local variable named spaces and set this equal to 9 whenever we call this function. For row in range 3, and we'll create a nested for loop for column in range 3. We will check the text of each button if buttons at indexes of row and column, and we will check the text to see if it's not equal to an empty space. If that is the case, spaces minus equals 1. Then we'll write an if statement. If spaces, as in spaces remaining, is equal to 0, that means we will return false and there are no spaces left. Else, we will return true. Okay, let's test it. So this time I'm trying to get a tie. Yep, it looks like it's a tie. This next part's optional, but I would like to change the color of each button for the winning combination. So within our check winner function, underneath the first win condition, I'm going to take buttons at index of row and index of 0, use the config method, and set the background color equal to, let's say, green. And I'm going to repeat this process for the other buttons within this win condition. So that is row 0, row 1, and row 2. I'll copy all of this, paste it, and switch some of these around. So these should all be matching. So 0 end column, 1 end column, and 2 end column. Okay, so we have 0, 0, 1, 1, and 2, 2. And one more. 0, 2, 1, 1, and 2, 0. Now, when we have a winning combination, the color of the buttons involved in that combination are going to change to green. Now, if there's a tie, let's change all of the buttons to, let's say, yellow. So I'm going to write nested for loops for this. For row in range 3, for column in range 3, take our buttons at row and column and change the background color to yellow or some other color of your choosing. So if there's a tie, they should all be yellow. I'm trying not to win here. It's actually more complex than what I thought. Yep, it looks like it's all a tie. And the last thing that we need to do is to fill in the new game function so that we can begin a new game. So let's say global player, we would like access to our player from inside this function, and set player equal to a new random choice. Random.choice, and pass in our list of players. And we will change our label.config, and set the text equal to player plus the word turn. And we also need to reset all of our buttons. For row in range 3, for column in range 3, buttons at index of row and index of column dot config text equals a set of quotes, so it's empty, and we'll change the background color back to what was previously. So the default color for buttons is actually hexadecimal, F0, F0, F0. So this function will begin a new game for us, and let's test it to be sure. I'm gonna start a new game, reset. I'll actually try and win this time. And reset. Okay, so it looks like the new game function is working. Now, another thing that you can do too is that you can change the players around. Let's say we would like to play as $sign and @sign. So this program is flexible enough so that you can change the icons of the players. Alright everybody, so that's a basic game of tic-tac-toe for Python. If you would like a copy of this code, I will post all of this to the comment section down below. But yeah, that's how to code a basic game of tic-tac-toe for Python. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, we're going to create a game of Snake using Python. So sit back, relax, and enjoy the show. First thing we should do is import from tkinter as well as the random module. And let's define all of the different classes and functions that we'll need. So let's create a class for our snake object as well as our food object. So for the time being, I'm just going to write pass for my classes. We'll fill these in later. So we have class snake and class food. And let's define all of the different functions that we'll need. So let's say we have a function named next turn. Change direction. Check collisions. And lastly, game over. Okay, for change direction, I'm going to have one parameter, a new direction. Now, when I create a game, I like to place a bunch of constants at the top of my game. Constants are variables that you do not want to change later. They're kind of like the settings. However, in Python, there are no constants compared to other programming languages, so we're just going to create a bunch of variables that will behave like them. So constants are values we do not want to change, and they're kind of like the game settings. And I place them at the top for convenience. And the naming convention for a constant is that all the letters are uppercase. So these will be settings like the game width, the speed, etc. So let's say the width of our game will be 700, but feel free to take the liberty to pick whatever size you want. So we have game width, game height. I'll set this to 700 as well, so it's a square. Let's say we have a speed, the speed of the snake. How often will our canvas update? So let's say 50, but the lower the number, the faster the game. And a space size. How large are the items in our game, like the food and body parts of the snake? So I'm going to pick 50, but you can change this. And body parts. How many body parts does our snake have when we begin a game? Let's say 3. How about a snake color? You can pick a color name, you can use RGB values, or you can use a hexadecimal value. So I'm going to pick green, 00FF00, but you can pick any color you want. How about food color? Equals red, and that is FF0000. And what about a background color for the canvas? Background color. I'll pick black, so that is 6 zeros. Feel free to mess with some of these colors too. So we have a green snake, our food is going to be red, and our background is going to be black. So that is all of the constants for our game, but you can feel free to adjust them if you like. Let's head down to the bottom and make our window. So we have window equals tk. And at the very end, we should have window.main loop. Let's set a title for this window. Window.title. Snake game. Okay, fine, I'll spell it right. Snake game. And if you do not want your window to be resizable, you can use resizable. And then you have to pass in false twice. It's kind of strange, but it's how it is. Okay, we should have a small window. And we cannot resize this, even if we tried. Okay, let's create a score label. But we probably need a score first. So let's say score equals 0, and an initial direction. Direction equals, let's say, down. Now let's create a score label. So let's say label equals label. We're adding our label to our window. Let's set the text equal to score, colon. Then I'm going to use the format method, and we will pass in our score, whatever it is. And I'll set a font, pick whatever font you prefer. And 40 is a decent size. And then I'm going to pack this label. Let's test it. Okay, we're getting somewhere. We'll need to create a canvas. Canvas equals canvas. We're adding it to our window. I'm going to set the background color equal to our background constant. I'm going to set our height equal to the game height and the width equal to the game width that we set. And we need to pack this, canvas.pack. And we should have a game board. I'm going to try and center this window when it appears, so we can do that using a few lines of code. The first thing we'll do is update our window so that it renders. And then we need to find some dimensions. So let's say the window width equals window.w info width. And window height equals window.w info height. We'll need our screen width equals window dot screen width, and screen height equals window dot w info screen height. Where is it? There it is. Okay, then we need to see how much we're going to adjust the position of our window. So let's say x equals screen width divided by 2 minus window width divided by 2. And do the same thing for y, except this will be screen height and window height, and that will be y. Okay, then we need to set the geometry. Window dot geometry. We're going to use an f string. So let's set the window width times window height. And then add plus x plus y. So when we pass in x and y, these cannot be floats. They have to be whole integers. So let's add a cast around x and y. Okay, now this should be fairly close to the center. Yeah, that's not too bad. Now, when we begin a new game, we should create a snake object as well as a food object. Snake equals snake, and call the snake constructor, and food equals food. Okay, let's fill in our food class first, because I think that'll be easier than our snake class. So let's head to the food class. Now let's create an init method. So def init, this will construct a food object for us, and we need to place our food object randomly. So for the x coordinate, let's say x equals random.rand int, and we need a range. The range is going to be 0, comma. Now, with our game board, I view it like a chessboard. There's a given amount of spaces. So 700 divided by our space size is 14 possible spots on the x-axis, and then 14 possible spots on the y-axis. So I need to pick one of these spots randomly. So let's say game width divided by our space size. So we'll get a random number between 0 and 14. However, this should be exclusive, so let's say -1. And for good measure, I'm just going to add a set of parentheses around this. Okay, and then we'll convert this to pixels. So let's multiply all of this by our space size, the size of each item in the game. And we'll do the same thing for y, but change game width to height. Okay, we should be good. All right, now let's set the coordinates. Let's say self.coordinates equals a list of x and y, and that's it. But make sure you spell coordinates right. Now we need to draw our food object on our canvas. Canvas dot create oval. You can pick a square too if you like. We need a starting corner. That will be where x and y is, and an ending corner. So that will be x and y plus our space size, the size of an object in a game. So x plus space size, y plus space size. And you can set a fill color too. Fill will be our food color that we declared. And I recommend adding a tag as well. That'll make it easy to delete this object. So tag will equal the string food. Now let's just test this. So we should have a random circle, or a square if you picked a square, appear someplace at some spot on my game board. Cool, seems like it's working. Let's work on the snake class next. Our snake class will need a constructor. And we will set a body size equal to our body parts. We'll need a list of coordinates. We'll fill this in later. And a list of square graphics. So that will be a list. Okay, so we need to create a list of coordinates. We can use a for loop for that. So let's say for I in range 0 through body parts. We will take self.coordinates and append a new list. And the coordinates for each body part at the start of the game will be 0, 0, so that our snake will appear in the top left corner. Now we'll need to create some squares. Okay, so for x, y in self.coordinates, and remember that we have a list of lists, so that's why we're using xy in self-coordinates. We'll create a square equals canvas.create rectangle. So we need a starting corner that will be x and y. Then x plus our space size, the size of each object in the game. Let me use the constant though. Space size, y plus space size. And let's set a fill color equal to our snake color. All right, and let's set a tag for convenience. Tag equals a string of snake. Okay, so we have a list of squares and we can append each square into our list. Self.squares dot append and pass in whatever square that you create. So we have a snake that has a body size, a list of coordinates, and a list of square graphics. Now after testing this, we should have the head of our snake in the top left corner, and now we just need the snake to move in a given direction every turn. So the initial direction is down, but we'll be able to change that later. So let's head to the next turn function. And there's actually two things we'll need as parameters that I forgot to fill in. Snake as well as food. And we will call this function when we begin our game. So let's unpack the head of the snake. So that's x, comma, y equals snake dot coordinates at index of 0, so that's the head of the snake. The coordinates will be stored in x and y. So let's check to see if our direction, our initial direction, equals up. And we'll need some else if statements. We'll fill this in just a moment. Else if our direction equals down, then left, and then right. Okay, if our direction is up, then let's take our y-coordinate for the head of our snake minus equals our space size so that we move one space up. And then down is plus equals space size. Left is x minus equals space size. And lastly, right is x plus equals space size. Okay, then we need to call the next turn function again for the next turn. So we can use window dot after. We need a time. So let's say our game speed. We're going to call the next turn function, and we need to pass in our arguments of snake and food. Snake, food. Oh, and make sure you're not actually calling the next turn function inside of the after method. You just have to write the function name of next turn without the parentheses. Okay, so let's update the coordinates for the head of the snake and write that before we move on to the next turn. So snake dot coordinates, and we will insert a new set of coordinates after updating one of them. So 0 will be the index, the head of the snake, and we will insert x and y coordinates at this new location. Now we're going to create a new graphic for the head of the snake. Square equals canvas dot create rectangle, pass in x and y for the starting corner of our rectangle, and the ending corner will be x plus our space size, y plus our space size. And then I will add a fill color of snake color. And then we need to update our snake's list of squares. So that will be snake dot squares, and insert at index 0 a new square that we create. Okay, let's test this. One last thing that we'll need to get this program to run is that after you create your snake and food object, we should call the next turn function and pass in our snake and food object. So we should be able to test this. So our snake is going to move, but we need to delete the last body part in our snake within the next turn function. But before we update to the next turn, let's delete the last body part of our snake. So delete snake dot coordinates at negative index of 1. That is the last set of coordinates. We will update our canvas. Canvas dot delete snake dot squares, an index of negative 1. And lastly, delete snake, the list of squares, at index of negative 1. So it should appear that our snake is moving. Cool. We need some controls for our snake. So at the bottom of our program, let's bind some keys. Let's do that here. So window dot bind. Let's bind the left arrow key. And we will use a lambda. The argument is event, and we will call the change direction function and pass in the word left. Okay, then we have to do the same thing for the other directions. So we have right, pass in right, up, pass in up, down, pass in down. Let's head to the change direction function. We need to access our direction, global direction. This is the old direction. If our new direction that is passed in is equal to left, and if our old direction, just direction, does not equal right, because we do not want to go backwards and do a 180-degree turn, then we will set our direction equal to our new direction. And we just need to repeat this for the other directions for new direction. And I'm going to change this to else if. Else if new direction is right, and our direction is not already left, then we have up. If our direction is not down, and down. If our direction is not up. Okay, so we should be able to change the direction of our snake. Sweet. Okay, we need to eat that pesky apple next, so let's work on that. There's nothing else that we need to change within the change direction function, so I'm going to minimize this function and head to the next turn function. We'll place an if statement here. If x, remember that we unpacked the coordinates for the head of the snake. If x, the x coordinate for the head of the snake, is equal to our food object's coordinates at index of 0. That's the x coordinate for our food object. And y is equal to food coordinates at index of 1. That means they're overlapping. Let's take our score and increment it by 1. And change our label, label.config. The text will equal score, and then I'm going to use the format method and pass in my new score. Let's delete our food object, and we gave our food object a tag, so we can just use the name of the tag to delete it and create a new food object. Then I'm going to write this part of our program within an else statement. We will only delete the last body part of our snake if we did not eat a food object. Okay, let's test it again. So I have 3 body parts. Now I have 4, 5, 6, 7, 8, 9, 10. You can see that the score is going up too. Okay, let's work on collisions next, because I should not be able to go off screen like this. There's one thing that we're going to change. So let's add an if statement that will check collisions. This will return true or false if we detect a collision, and pass in our snake object. If there is a collision, we'll call the game over function. Else, we will update to the next turn. Okay, let's fill in the check collisions function, and we no longer need our function of next turn. Actually, we don't need these classes either, so I'll minimize them. Okay, check collisions. So it looks like we will need a parameter of snake, so be sure to set that. Let's unpack the head of the snake. X, Y equals snake dot coordinates at index of 0. And let's check to see if we cross the left or right border of the game. If x is less than 0, or x is greater than or equal to our game width, then return true. I think for testing purposes, I'm going to print something to the console window. Game over. Let's test it. Okay, I'm going to go over to the right border, game over, and our game stopped. Let's go over the left. Game over. Cool, so we know that it's working. Okay, let's do the same thing for Y. We can use else if here. If Y is less than 0, or Y is greater than or equal to our game height, let's print game over and return true. And we should probably test it. Okay, I'm going up, game over, and let's go down. Game over. So what if our snake touches its tail or another body part? So let's say for I, actually I isn't too descriptive. Let's say for every body part in snake dot coordinates. So we're going to set this to everything after the head of the snake. We're going to check to see if any of the coordinates are matching. If x is equal to body part at index 0 and y is equal to body part at index 1, then return true. And I'll print game over to test it. Print game over. Otherwise, we can return false. There are no collisions. I think I'm going to change the size of the snake to 10. Okay, let's run into each other. Cool. Game over. And the last thing that we need to do is to fill in the game over function, because it looks like everything else is fine. So head to the game over function, take your canvas, and delete all. And we'll create some game over text. Canvas, create, text. I would like this in the center of my canvas. I'll take canvas w info width divided by 2, comma, canvas w info height divided by 2. I'm going to put some of this on the next line for readability. I'll set a font. Pick whatever font that you want. We'll need some text. Text equals game over. Pick a color. Red's decent. I'll add a tag too, for convenience. Game over. And that should be it for the game over function. I'm going to change the body parts of the snake back to what it was originally, and we should probably test that game over screen. Alright, it appeared. Okay, so let's change some of these settings around. You can create a larger game board, let's say 1000 by 700. That still works. You can slow down the speed or speed it up. So 100 will be about half as fast. It's going pretty slow now. But what if we set it to 20? You can change the space size. So everything is a lot smaller now, including the food object. You can change the body parts. What about 20 to begin with? That's fairly excessive. I'll change that back to 3. You can change the snake color. Let's say we would like a blue snake. So that is for a hex color. 4 zeros and then 2 Fs. You can change the food color. So let's say we would like a yellow food object. So that would be 4 Fs and then 2 zeros. Kind of resembles the Python logo, that color scheme. You can change the background color too. So let's say all white, that would be 6 Fs. I do not like that. Go back. Delete, delete, delete. All right, well, that should be everything. Let's run this game one last time. Well, everybody, that is a very basic game of Snake for beginners. I will post all of this code to the comment section down below. But yeah, that's a basic game of Snake using Python. Hey you. Yeah, I'm talking to you. If you learned something new, then help me help you in 3 easy steps by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro.